there, welcome to Simplilearn's Data Analytics Full Course. Let's be real, data is everywhere and companies today run on it. Whether you're just starting out or looking to upgrade your skills, data analytics is no longer optional. It's one of the most in-demand skills in the job market. And here's the exciting part. We're not just talking about traditional analytics anymore. With generative AI stepping in, data analysis is becoming much more smarter, faster, and way more impactful than ever before. This course, we will keep it simple and practical. You'll build a strong foundation in the core concepts of data analytics. You'll explore real-world applications and get hands-on with collecting, cleaning, and visualizing data. We'll also walk you through predictive analytics and dive into powerful tools like Excel, Power BI, Python, SQL, R, and even ChatGPT. That's right. You'll see how GenAI tools like ChatGPT can automate tasks, speed up insights, and completely change the way analysts work. And with practical projects and tool-based training, you will come out of this course confident enough to analyze data, present insights, and make smarter decisions that actually drive impact. And by the end, you won't just understand analytics. You will know how to leverage generative AI in your workflow and stay ahead in this evolving field. So let's get started and set you on the path to become a skilled data analytics professional. Now, before we comment, if you are interested to supercharge your career in data analytics, then the Professional Certificate Program in Data Analytics and Generative AI by Analysts Academy IT Guwahati is the perfect choice for you. This is an 11-month live online course which offers interactive masterclasses by IT Guwahati faculty and industry experts combining cutting-edge tools like Generative AI, ChatGPT, Python, Tableau, and SQL. You will experience hands-on learning with real-world projects and immerse yourself in the campus environment with a special session at IIT Guwahati. Plus, earn executive alumni status from IIT Guwahati and IBM recognized certifications to stand out in the job market. So what are you waiting for? Hurry up and enroll now, and you can find the course link below.
In this video, we will discuss what data analytics is and the need for data analytics. Then, we will look at the different ways in which data analytics can be used, followed by the various steps involved in the data analytics process. After that, we will get an idea about the different tools used in data analytics and the companies using data analytics. Moving forward, we will see a case study on how Walmart uses data analytics for better customer service. And finally, we will perform a regression analysis in R to predict sales based on the advertising expenditure from three mediums: TV ads, radio ads, and newspaper advertisements. So what is data analytics? Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large data sets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial. Now that we have looked at what data analytics really is, let us understand the ways in which you can use data analytics. First is improved decision making. Data analytics eliminates a lot of guesswork and manual tasks from choosing the right content, planning marketing campaigns, and developing products. Organizations can use the insights they gain from data analytics to make informed decisions, leading to better outcomes and customer satisfaction. It gives you a 360-degree view of your customers, which helps you understand their behavior completely, enabling you to better meet their needs. Second is better customer service. Data analytics provides you with more accurate insights of your customers, allowing you to tailor customer service to their needs, provide more personalization, and build stronger relationships with them. Your data can reveal information about your customers' communication preferences, their interests, their concerns, and more. It helps you give better recommendations for products and services. Next is efficient operations. Data analytics can help you streamline your processes, save money, and boost production. When you have an improved understanding of what your audience wants, you waste less time in creating ads and content that don't match your audience interests. This helps you optimize your campaigns, create better content strategies, and hence improve results. And finally, we have effective marketing. When you understand your audience better, you can market to them more effectively. Data analytics also gives you useful insights into how your campaigns are performing so that you can fine-tune them for optimal outcomes. You also find out the probable customers who are the most likely to interact with a campaign and convert into leads. Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps. So as you can see, we have 7 tools including a few programming languages that will help you perform analytics better. Now let's discuss them one by one. First, we have Python. Python is an object-oriented open-source programming language that supports a range of libraries for data manipulation, data visualization, and data modeling. Python programmers have developed tons of free and open-source libraries that you can use. You can find many of them via the Python package index, which is pypi, the repository of Python software. Python provides the default package installer called pip or pip. Python has libraries such as NumPy for numerical computation of data, pandas to manipulate data on numerical tables and time series. Then you have SciPy for technical and scientific computations. It also provides scikit-learn, which is a machine learning library for creating classification, regression, and clustering algorithms. And finally, it also has PyTorch and TensorFlow for deep learning. Up next, we have R. R is an open source programming language majorly used for numerical and statistical analysis. It provides a range of libraries for data analysis and visualization. Some of these libraries are ggplot, tidyverse, plotly, dplyr, and caret. Then we have Tableau. Tableau is a popular data visualization and analytics tool that helps you create a range of visualizations to interactively present the data, build reports, and dashboards to showcase insights and trends. It can connect with multiple data sources and give hidden business insights and patterns. Then we have a competitor of Tableau, which is Power BI. Power BI is a business intelligence tool developed by Microsoft that has an easy drag and drop functionality and supports multiple data sources with features that make data visually appealing. Power BI supports features that help you ask questions to your data and get immediate insights. You can also forecast your data for predicting future trends. So the next tool is QlikView. QlikView provides interactive analytics with in-memory storage technology to analyze vast volumes of data and use data discoveries to support decision making. It provides social media discovery and interactive guided analytics. It can manipulate huge data sets instantly with accuracy. Up next, we have Apache Spark. Apache Spark is an open source data analytics engine to process data in real time and carry out complex analytics using SQL queries and machine learning algorithms. It supports Spark Streaming for real-time analytics and Spark SQL for writing SQL queries. It also has Spark MLlib, which is a library that has a repository of machine learning algorithms, and then it has GraphX for graphical computation. And finally, we have SAS. SAS is a statistical analysis software that can help you perform analytics, visualize your data, write SQL queries, perform statistical analysis, and build machine learning models to make future predictions. SAS empowers our customers to move the world forward by transforming data into intelligence. SAS is investing a lot to drive software innovation for analytics. Gartner has positioned SAS as a Magic Quadrant leader for data science and machine learning. Moving on to the applications of data analytics. Data analytics is being used in almost every sector of business these days. Let's discuss a few of them. First, we have retail. Customers expect retailers to understand exactly what they need and when they need it. Data analytics helps retailers meet those demands. Retailers not only have an in-depth understanding of their customers, but they can also predict trends, recommend new products, and boost profitability. Retailers create assortments based on customer preferences, invoke the most relevant engagement strategy for each customer, optimize supply chain and retail operations at every step of the customer journey. The second application is on healthcare. Healthcare industries analyze patient data to provide life-saving diagnosis and treatment options. They also deal with healthcare plans and insurance information to drive key insights. Using analytics, they can discover new drugs and come up with new drug development methods. Advanced analytics allows healthcare companies to improve patient outcomes and experience. Cancer cells and diabetic retinopathy can be discovered using medical imaging. At number 3, we have manufacturing. For manufacturers, solving problem is nothing new. They fight with difficult problems and situations on a daily basis. From complex supply chains to motion applications to labor constraints and equipment breakdowns, they deal with such problems on a regular basis. Using data analytics, manufacturing sectors can discover new cost-saving and revenue opportunities. The fourth application is related to the banking sector. Banking and financial institutions collect vast volumes of structured and unstructured data to derive analytical insights and make sound financial decisions. Using analytics, they can find out probable loan defaulters, customer churn-out rate, and detect fraudulent transactions immediately. The final application is based on logistics. Logistics companies use data analytics to develop new business models that can ease their business and improve productivity. They can optimize routes to ensure delivery reaches on time in a cost-efficient manner. They also focus on improving order processing capabilities as well as performance management. With that, now let's look at the companies using data analytics on a daily basis. So we have the e-commerce giant Amazon, then we have Accenture, followed by the American Healthcare Service Organization, Cigna. Then we have the American supplier of health information technology solutions, services, devices and hardware, Cerner, followed by Target and antivirus company McAfee. Next, we have Rapido, which is an Indian bike rental company based in Bangalore. After that, we have Flipkart and the world's largest retail company, Walmart. With that, let's understand a case study from Walmart and how it uses data analytics to grow its business and serve its customers better. Walmart is an American multinational retail company that has over 11,500 stores in 27 countries worldwide, and it has e-commerce websites in 10 different countries. It has more than 5,900 retail units operating outside the United States with 55 banners in 26 countries with more than 7 lakh associates serving more than 100 million customers every week. It has over 2.2 million employees around the world and 1.5 million employees in the United States alone. Walmart's e-commerce branch alone employs more than 3,000 technologists from Silicon Valley to India, England and South America. More than 240 million customers shop at Walmart each week online and at its banner stores. Walmart.com sees up to 100 million unique visitors a month according to ComScore and is growing every year. Walmart collects over 2.5 petabytes of data from 1 million customers every hour. That's really huge. Now to make sense of all this information, Walmart has created Data Cafe, a state-of-the-art analytics hub located within its Bentonville, Arkansas headquarters. Here, over 200 streams of internal and external data, including 40 petabytes of recent transactional data, can be modeled, manipulated, and visualized. Teams from any part of the business are invited to bring their problems to the analytics experts and then see a solution appear before their eyes on the nerve center's touchscreen smartboards. Walmart also constantly analyzes over 100 million keywords to know what people near each store are saying on social media to understand the customer behavior on what they like and dislike. Walmart uses modern tools and technologies to derive business insights and improve customer satisfaction. Some of these tools include Python, SAS, NoSQL databases such as Cassandra and Hadoop. Now, using all these technologies and data analysis techniques, Walmart can better manage its supply chain, optimize product assortment, personalize the shopping experience, give relevant product recommendations, and finally, optimize and analyze transportation lanes and routes for its fleet of trucks. With that, let's jump into our use case demo where we will predict the sales based on advertising expenditure using the linear regression model in R. The advertising expenditure has been made via different mediums such as radio, television, and newspaper. We will use the R programming software to implement the demo. So why R? Well, R is a free and open source software that can be downloaded from the RCRAN website. It is easy to learn and use. R language is built specifically for performing statistical analysis, data manipulation, and data mining using packages such as plier, dplyr, tidier, and lubridate. R supports data visualization with the help of packages such as ggplot, Google Viz, R Color Brewer, Leaflet, and ggmap. And finally, the R software can be used in a wide range of analytical modeling including classical statistical tests, linear and nonlinear modeling, data clustering, time series analysis, and more. Now, let's have a look at our data that we will be using for this demo. Here is our advertising CSV dataset, which has 4 columns. You can see there's TV ads expenditure. The next column is for radio ads. Then we have the newspaper ads. And the last column is our target column, that is the sales. So the dataset has in total 200 rows. Now, to understand the data, let me give an example. So consider the second row. So suppose you spend around $230 on TV ads, then $37.8 on radio ads, and $69.2 in newspaper ads. You can expect to sell nearly 22 units of a particular product. Similarly, if you are spending $44.5 in TV advertising, $39.3 in radio ads, and $45 in newspaper ads, you can sell around 10 units of certain item. We will analyze this data using linear regression. So linear regression is a supervised learning algorithm, which means the data has labeled columns and is used to predict numeric continuous variables. So our sales column here is the target column and it has continuous numeric variables. Now let me go to the R Studio and start with the demo. So first, I'll create a new file, then I'll select R script. The next step is to install all the necessary packages that we need for this demo. If you already have the packages installed in your R Studio, you need not do it again. You can just call these packages using the library function and pass the package names. So first, I will install the dplyr package, which is used for data manipulation. I'll be using install.packages function and I'll give the package name. So I'll type install.packages. If you hit tab, it will autocomplete. Then under quotations, I'll write dplyr. I'm not going to run this because I already have it installed in my R Studio. The next step, I'll call this package using library function. I'll give the package name dplyr. I'll run this. Then I'll install the broom package. It takes the messy output of built-in functions in R such as linear model or LM, then t-test, and turns them into a tidy data frame. So I'll copy the above code. I'll just paste it again. I'll change it to broom. Here also I'll change it to broom. I'll run this. Okay. Then I'll be installing the CA tools package, which will help us build our linear regression model. I'll paste the same code and I'll take CA tools and I'll call that using the library function. I'll run this. Now sometimes people face issues with installing this particular package. If you also face this problem, do visit the RStudio community page. Now let me show it to you. So this is the RStudio community page, and here they have the solution. You can just go through this 2 pages. Alright. After this, I will install the ggplot2 package, which is a very popular package in R for data visualization. I'm not running install.packages because I have already installed all these packages before. If you have not, so you have to run install.packages first and then call the library function. With that, let's now load the dataset. For this, I will use the read.csv function and provide the path location where my data is located, followed by the dataset name and the extension. I'll assign the loaded dataset to a variable. Let me now go ahead and show you where my dataset is located. So here is my advertising CSV dataset, and this is the location. I'll copy this location. I'll move back to RStudio and let me comment this line, load the dataset. So I'll take a variable name ads, and then using read.csv function, I'll pass the path location where the dataset is present. Now one thing to note is we have to change all the backslash to forward slash, otherwise R won't accept it. And finally, I'll give the dataset name, which is advertising.csv. Let me run it. Okay, we have successfully loaded our dataset. Now let us look at how our dataset looks like using the head function. So I'll give a comment, display the head of the dataset. I'll be using the head function and I'll pass ads. Run it. So you can see the head function has displayed the first 6 rows from the advertising dataset. Let me now check the dimensions of the dataset. So I'll use the dim function. It will give you the total rows and columns present in the dataset. Give a comment, check the dimensions. I'll use the dim function and I'll pass in the ads variable. You can see it has given the number of rows, which is 200, and the total columns, which is 4. Now, if you want to get a summary of the dataset, you can use the summary function. So I'll directly type in summary and I'll give ads. Let me expand this. So actually summary function gives you information about a few statistics for each of the columns. So you can see the minimum value for each column, the maximum value for each column, the mean, the median, first quartile and the third quartile values. The first quartile or lower quartile is the value that cuts off the first 25% of the data when it is sorted in ascending order. The second quartile is the median, which has the value that cuts off the first 50%. And the third quartile or the upper quartile is the value that cuts off the first 75% of data. Moving ahead, let's do some data visualization now to visualize our data. Since our data has only numeric values, using scatter plots would be the best option. So we will visualize our sales against each of the independent variables. For that, I will use the plot function and give sales in my x-axis and the independent variable names in the y-axis. Let me now do that. So I'll give a comment, data visualization. First, I'll use the plot function, and then in x-axis using the dollar symbol I'll give sales. Then in the y-axis I'll give my independent variable. You can see R is automatically giving you the suggestions. I'll select TV. Then I'll take type is equal to under quotes, I'll give P, which stands for points, and I'll take the color as red. So you can see under plots we have our scatter plot. If I zoom in, you can see the red dots are pretty much aligned in one direction, which means if you are increasing the expenditure on TV ads, the units sold are also increasing equally. So the more you spend on TV ads, the more sales you can expect. I'll close it. Now let's look at how sales vary based on radio advertising expenditure. I'll copy this. Paste it, and under y-axis I'll change it to radio, and I'll take the color now as, let's say, blue color. I'll run it. Now if I were to zoom in, now if you look at the blue dots, it is not that linear compared to our previous graph. You can see there are a few data points like this that show the sales were not good even after spending decent money on radio ads. But still you can expect a decent amount of sales if you are willing to spend on radio advertising. Close it. Let's now look at how sales will vary based on the newspaper advertising expenditure. I'll change the radio to newspaper column, and this time I'll take color as green. I'll run it. Let me zoom in. You can see the plots are very haphazardly present. The data is completely non-linear, and there seems to be a low correlation between the sales and newspaper advertising expenditure. Now if you want to look at these plots at a time, you can use the pairs function. So I'll type pairs and then pass in my variable name, which is ads. I'll run it. Let me zoom in. So this is our plot, and you can see this has all the visualizations. So you can see the TV sales. Now you can see the sales that were made with radio expenditure and with the newspaper expenditure as well. I'll close it. Moving ahead, let's check the correlation between the variables and see what insight we can get. We will use the core function or COR function and build a correlation matrix. First, let me go ahead and install the core plot package. So I'll give a comment, correlation analysis. For this, I will have to install the core plot package. I have already got it installed. Then I'll call this function using library. I'll run it. You can see core plot, the version has been uploaded. Now I'll tell you how you can grab only the numeric columns. Now our data only has numeric columns, but still let me tell you how you can do it. Since correlations are based on numeric columns only, this can be done using the sapply function. So for that we have already installed the dplyr library. I'll give a variable name as num.calls, which is numeric columns. Then I'll pass in the sapply function. I'll give the adds variable and I'll check if the variable is numeric or not. So I'll use is.numeric. Let me run it. And now let's display what's there in num.calls. You can see it says TV, it's true, which means TV has numeric values, even radio has numeric values. Similarly for newspaper and sales also. Then I'll use the correlation function, which is COR, to display the correlations between the variables. So I'll give my variable name as cor.data, and then I'll take the core function, pass in the adds variable, and I'll only filter out the numeric columns. So comma numeric columns means we need all the rows and the selected columns. Let me run it. And now to display, let me call cor.data again. So this is our correlation output. As you can see, the correlation values are all above 0, which means there is a positive correlation between the variables, and a change in one of the independent variables will have a positive impact on the sales numbers. TV ads have the maximum correlation with sales and the value is around 0.78. Then there is radio advertising, which has correlation of about 0.57 with sales, and newspaper ads have the lowest correlation compared to the other two, which is at 0.22. Now you can also build a correlation matrix using the correlation plot method. This will give you a visual representation of the correlation between the variables. So let's see how we can do that. I'll type core plot and I'll give core.data and I'll pass a method as color. If I zoom in, you can see this is our correlation matrix. On the right, you can see the scale. So -1 is for negative correlation. Then there's light red, 0, which is almost white color. Then there's light blue, and finally dark blue for the maximum positive correlation. The diagonals are dark blue, which represents the same variables as in rows and in columns. So it's dark blue. TV ads and radio ads have the next highest correlation, while newspaper ads have the lowest correlation with sales. With that, let's jump into the most important part of this analysis, which is building our regression model. First, we will look at a simple linear regression model where we will take one input variable, that is TV ads. I'll be using the lm function or the linear model function to build the model. So I'll give a comment, simple linear regression. I'll take a variable name as model underscore simple, and then using lm function I'll give my target variable, which is sales, and using tilde I'll give my independent variable, which is TV, and data as ads. I'll run it. Now that we have built our linear regression model, let's check the summary. Take summary function and I'll pass in model underscore simple. Let me run it. Now if I expand this, you can see our intercept estimate is around 7.03. So when the TV advertising budget is 0, we can expect sales to be around 7030 or 7030. Also remember, we are operating in units of thousand, and for every $1,000 increase in the TV advertising budget, we can expect the average increase in sales to be around 47 units. Now the same summary can be checked using the tidy function present in the broom package. So if I call tidy and I'll give the model name, which is model underscore simple, I'll run it. So there you go. This gives us a tidy representation of the summary figures. Now let's build a regression model with more than one input variable. So we'll build a multiple linear regression model. I'll take my variable name as model underscore multiple this time, and I'll use the same lm function. I'll pass in the sales, and using tilde I'll take all the column names. Stevie, then I'll use an addition operator, then I'll take in newspaper, followed by the radio column, and then I'll take my data as ads. Let's run it. I'll follow the same drill. Let me now call the summary function over this newly created model. So I'll write summary and I'll select my model name as model underscore multiple. Let me run it. So the interpretation of our coefficients is the same as in simple linear regression model. First, we see that our coefficients for TV and radio advertising budget are statistically significant, since our p-value is less than 0.05, while the coefficient of newspaper is not, which is around 0.86. Thus, changes in the newspaper budget does not appear to have any relationship with changes in sales. However, for TV ads, our coefficient suggests that for every $1,000 increase in TV advertising budget, holding any other predictors constant, we can expect an increase in sales of 45 units on average. Similarly, the radio coefficient suggests that for every $1,000 increase in radio advertising, holding all the other predictors constant, we can expect an increase of 188 sales units on an average. Now you can also call the tidy function over this multiple linear regression model. So let me do that. I'll call tidy and I'll pass in model underscore multiple. You can see it has given the output. Now you can also find the coefficients of the model using another method. It's called the coefficient matrix. Here is how you can do that. So take a variable name and I'll use the summary function. I'll pass in model underscore multiple, and using the dollar symbol I'll take the parameter as coefficient. Let me call C coefficient now. So these are the coefficients of different variables. Let me now show you another example of how you can train a linear regression model using the CA tools library. First, I'll take a seed value, a random seed value of say 101. Next, I will split the data into training and testing sets. I'll take 70% for training the data and 30% for testing the data. So I'll use a variable sample, then I'll call sample.split, take ads, and then I'll use another parameter called split ratio, and I'll take the split ratio as 0.7, which is 70%. I'll run it, and then I'll use another variable called train and take the subset of the sample, pass in my ads variable, and I'll select sample is equal to true. Similarly, I'll take another variable called test. I'll use my subset function and given the same parameters, but this time I'll take sample is equal to false, which means the test sample dataset won't have any values that are present in train dataset. I'll run it. Now we will use the same lm function to create our model. So I'll take model as my variable and assign it to lm function. So I'll assign the linear model to the model variable. I'll take sales as my target column, use the tilde followed by a dot, which means I'm taking all the variables in terms of the independent variables, and then I'll select my train dataset. With that, let's check the summary as well. So this is the summary of our newly created model. Now you can also check the residual collected from the trained model using the residuals function. Let me go ahead and assign a variable called res for residual, and I'll use the residuals function. Pass in my model. Then I'll convert the residuals into a data frame. So I'll use the as.dataframe function and pass in res. Now you can check the residuals. So these are the residual values. Now it's time to make our predictions using the test dataset. I'll use the predict function for this. Let me take another variable called sales.predictions, and I'll use the predict function, pass in my model followed by the test dataset. Now I'll run it. Then let me call sales.prediction to display the values. As you can see, these are my predicted sales values. Now let me combine these predicted sales values to our original sales for the test data. For that, I'll use the cbind function and pass the column names. I'll take another variable called results and use the cbind function. I'll take sales.predictions and I'll consider the sales column from the test data. Let me check the values now. So you have the predicted sales values and the original values of sales, but you can see the columns don't have any name assigned to them. So let me go ahead and assign the column names using the call names function and convert it into a data frame to make it look better. So I'll use the call names function and pass in my results variable. Then I'll take a vector and give the column names as spread for predicted values and let's say real for the original values. We run it. Now I'll convert this into a data frame. So I'll use as.data.frame and give my results variable. Now if I display results, you can see, go on top, you can see the columns have been assigned successfully. So on the left you have the predicted values and on the right you have the real values. So we have successfully built our linear regression model and predicted the sales values using linear regression in R. You can also go ahead and find the accuracy of this model to know how good your model is. We won't be covering that as part of this tutorial. I'll leave it for you and encourage you to do some research on how you can find the accuracy of a linear regression model. You will come across terms such as mean squared error, root mean squared error, and R squared value. If you are able to find the accuracy, please post the results in the comment section, or if you face any issues with it, please post your queries. We'll be happy to help you.
So we will learn about functions and formulas. We will learn about conditional formatting, data validation, pivot chart, and pivot table. Now, let's look at a scenario here. So one day in a startup, one professional speaks that their business is growing and they would need an efficient way to work with the data. They would have to find a way to work faster with storing and analyzing data. Now, to that, another colleague responds, well, we can make use of Microsoft Excel to do this job. The question is, will Excel be able to cater to their business needs? Now, the colleague responds, well, we can make use of Excel in several ways, and it also is a cost efficient option. Now, in that case, the colleague who posed the question says, let's go ahead with Excel and let's train our employees in Excel. And the suggestion is welcomed, which would make the job easier for them. And they would basically decide on using Excel. So they decide on taking a training right away and basically starting to learn Excel. Now, before we move to Excel, one of the question is, why should we use Excel? So let's look at some of the points here. So Excel proves to be a great platform to perform various mathematical calculation on large data sets, which is one of the biggest requirements of various organizations these days. Various features in Excel like searching, sorting, filtering makes it easier for you to play with the data. And Excel also allows you to beautify your data and present it in the form of charts, tables, and data bars. Now, when it comes to reporting, accounting, and analysis can be performed with the help of Excel. It can help you with your task lists, your calendars, and goal planning worksheets. Excel also provides good security for your data. Excel files have the feature of password protection. This way, your information can be safe. Now, when we talk about what is Excel and how it can be used, so Excel, or you might have heard as spreadsheet, can be basically used for a lot of different tasks than just storing the information in so-called tabular format. Now, Microsoft Excel is an application that is used for recording, analyzing, and visualizing data. It is in the form of a spreadsheet. Let's have a look at few of the functions and formulas used in Excel. And before we do that, we can also quickly take a small tour to understand how to work with Excel. Now, to do that, what we can do is we can type in our search, say for example Excel, and just select your Excel app which is installed. And here you see you have a lot of options which says take a tour, drop down list, get started with formulas, make your pivot table, going forward with pie charts, and much more. So we can click on this one which says take a tour, and that basically pops up a window which says welcome to Excel. And if you have always wanted to be better at Excel, you have this which can help you. So let's click on create, and that takes us to the store window. Now that says instructions for screen readers, which basically talks about 10 different steps in which we can learn Excel and using the spreadsheet app. So there are more than 11 sheets which we see here at the bottom end, and each one gives us a simple example which we can work on. So for example, if I click on add, now that takes me to this page which says how do we add numbers. Now you might be provided data which we can upload by loading a file from our machine, or getting data from a web source, or even connecting to a database. So there are various options which we will see in some time. So here we have an option which is called data. You can click on this one, and this basically has options where you can use existing connections. If you have created some, you can always click on from other sources, and you can get your data from SQL Server, from analysis services, from OData data feed. You can get in from XML, from data connection wizard, or also from Microsoft Query. You can be running in different queries here, which shows up in the option which says new query. There are connections which you can use, and that basically will display all the connections for this particular workbook, which we do not have as of now, but we can create them. But let's look at simple examples. Now you can follow these instructions here, which says basically adding up the numbers, and that could be easily done by just placing your cursor here. And what you could do is either you can type in the formula, that is from which row to which row you would want to add the data. So for example, I could just do a sum here, and that shows up all the different functions which are available. Then we can open up a parenthesis, and we can say I would be interested in totaling the amount from column D, and I would select, for example, D4. So I could be doing this, and then I could say D4 onwards till D7. So that's the data which I'm interested in. You can close your parenthesis and hit enter, and that gives you the total. There is also a shortcut for this, which you can always do, is we can first delete this, and you can just place your cursor here and just use your alt and equals. That automatically selects the numericals, which we can anytime expand or basically collapse. So I will basically select this, which says this function needs two numbers, which is number 1 and number 2, and then you can hit on enter, and that gives you the total. So similarly, we can be getting in the data here by selecting all the fields. So here it also says that you can use a shortcut. Now what we can also do is we can add numbers over 50 by selecting the yellow cell here, and then giving a condition such as, so I can basically use something like sum if, and then open a parenthesis. I can select I would be interested in this row, and then I can even drag and drop till here. So that tells me D11 to D15. You can then put in a comma here, and you can give your condition. Say, for example, we would say I would be interested in numbers only above 50, and we can select this, close your quotes, and then just close your parenthesis, and that's your formula. So you can do this, and that basically gives me the total is 100. Now similarly, we could do that for the amount here. I could select this. Now there is also an option. I can click on home, and I can go for something like auto sum. So that's one more way of doing it, which anyway says sum is alt plus equals. So it automatically adds up your values, and I can try doing a auto sum that automatically selects my rows, and then I can get my total. Now, as per this activity here, it says try adding another sum if formula here, but add amounts that are less than 100, and the result should be 160. So what we can do is we can basically select all the numbers which are lesser than 100. So the way we did earlier here, there can be always a shortcut. So you can always, for example, if you would want to avoid typing in the formula, you can always copy it from here and then just hit on enter. So you are back into this cell, and then I can basically go here and paste the number, and then as per the requirement, we are required to select anything which is lesser than 100. So what I could do is I could select here, I could say, let's say G, and then I can change this value to G15, and that's one more way. Now we see our selected rows have been changed, so I can hit on enter, and I can check what is the result. So we would be interested in looking for numbers which are lesser than 100, so I will have to also change this one to a lesser sign, and that basically gives me the total, which is 160. So that's how you can simply add numbers. You can use auto sum, you can type in the formula, you can select the fields, or you can just place your cursor where you would be looking for a sum, and then you can just do a alt equals, and that basically populates the sum. Now let's look at some easy options of filling your cells or automatically populating the values in your cells within your Excel sheet. Now here we have an option which says 100. Now we can click on this, and that basically says it is making a sum of column C4 to D4. So if I click on this one, I can check that this is row number 4, which shows up here, and I also know this is column C. I also have D, so this equals is basically giving me a sum of C4 to D4. Now what we can do is we can always place our cursor here at the right corner, and then we can just drag and drop, and this basically gives me a total of all the numbers for all different rows. So this is one shortcut which we can do to get the total. Excel will automatically give the totals, which we call as filling down. Now what we can do is, in the same way, if we would want to get the totals here, we can first check what is this 200, and this tells me it is C11 to C14 total. So it is totaling the rows from C11, so column C and 11th row, till 14th row, and that's the sum. Now what I can also do is I can similarly, like above, we can do a filling right, which basically means bringing your cursor here and then just dragging and dropping it all the way where you would need the totals, and this basically gives me the total. There is one more quick way to check if this is right. So the easiest option would be to select this cell. Now what I can also do is I can just select all of these fields by just highlighting and selecting all the fields. Once it is selected, press on Control R, and that gives you the total. Now if we would be doing this top down, then I could select all these rows for this particular column, and then I could do a control D. So that's your filling down, and this one was filling right. So this is an easier option of doing a fill when you would want to have the formula applied to every row as it occurs in the first row or the last row. We could test this by, for example, selecting these fields. I could delete them, and I have here which says 130. I could just place my cursor here and I could drag it all the way up, and that should also do the same magic which we were seeing from top down. So this is a simple way wherein you can fill up your cells, and you can also automatically propagate or move your computation to all the cells. Let's look at the split option, which basically helps us in splitting the data when we have some kind of pattern or when we have some kind of delimiters in our data in, say, one particular column, and we would want to derive the values out of it. So we can always use the splitting option. Now the easiest option would be, so for example, we have our email column which has the email IDs, and which we can clearly see has a first name dot last name. Now I see that there is a last name Smith filled up here, first name is empty. So what I can also do is I can just type in, say, Nancy here. Now that's the first name. I can again start typing the second name, and as soon as you do that, you would see a faded list of numbers, and that's your clue to hit enter. And once you do that, you would see all the first names have been filled in here. If you would want to maintain the case sensitiveness, you can just go ahead and delete these, and let's type in as it occurs. So let's say Nancy as the first name. Go down to the next cell and just type in Andy, and there is your grade list. So just hit on enter, and that basically fills up your first name. What we can also do is we can just select this particular field, and either we can type in control E, which basically fills up all the options. Now I can just do a undo by typing in or clicking control Z, and that's basically gone. What I can also do is I can select a particular field, and then I can go into home option, and under home you have an option here which says fill. So you can select this, and then you can do a flash fill, which is what we are doing here. So click on flash fill, and that automatically fills up the values. So in this way you can work within your spreadsheet, and you can be filling up the values where a delimiter by default is understood, and we can split the data. Now however, sometimes you might have some data which has a different kind of delimiter, and there is again a smarter way of splitting your data. So you can always scroll down here, and that says splitting a column based on delimiters. So we have some values in the data column, and these values in each row are separated by comma. So select this. Your data is already selected. Text to columns, delimited, comma is selected, and now click on next. So it basically says what is the destination. Let's select this one, and I can choose what would you want to have. So that shows me this would be my data preview. Now I can basically select this one. I can say finish and say okay. And now if you see, our data has been placed in the columns appropriately. So this is how you can split your data based on a delimiter and then organize your data in a better way. Now there are some advanced options which we can learn later, but this basically tells about using a formula. So this is something, if say if we have some name in one cell, and if you would want to split it into first name, your helper column, your middle name, last name, so that can also be done using formulas. And this basically tells how would you extract characters from your left cell and how would you place them in your right cell. So you can try this activity, which is a little more of advanced option. The benefit is that you can always use this, wherein if you do some kind of transformation using your formulas, If your original data gets updated, then the split data will also get updated. And that's the benefit of using formulas, where you can place values from one cell into multiple cells based on execution of your details in the formulas. How about using the transpose option? Now, you might have heard of situations where you would want to switch or turn your rows into columns and your columns into rows, and that's where transposing comes into picture. It might be useful when you have your data in your x and y axis, or as I would say, in rows and columns, and you would want to switch your rows to become the columns and columns to become your rows. So what we can do is, the simplest way is, you can select all your values. So here we basically have 6 columns and I would say 2 rows. Now I can select all of these, and then I can select an empty field. For example, the one which is highlighted here. Well, you can always do a Control Alt V. That's a shortcut. What you can also do is, once you have selected all your fields, you can just copy them. So just do a Control C and then click on an empty cell, and then what you can do is, you can do a special paste or paste special. So under your home, you have the paste option, and here you can go for paste special. And once you do that, you need to select the transpose option over here and click on OK. And now you will see that the columns and the rows have been transposed. So your row name was item, and that has become the column heading. You had row name as amount, and that has become the column heading, and all your values have been transposed in this particular format. Now there is another way of doing that, and again, that's using your formulas. So what you can do is, you can transpose with a formula also, and that basically works when you have similar kind of data. So this has 6 columns and basically 2 rows. So you can basically do this. So you can select this, and earlier we were doing a copy, but now what we would want to do is, we would want to just look at the row numbers, which tells me it is C33, C34, and it starts with C and ends in with your H column. So what we can do is, we know that we have 6 columns and 2 rows. So transposing that would actually give me 2 columns and 6 rows. So what we can do is, we can select 2 columns and 6 rows in our Excel sheet. I can then basically start typing in the message, or I can just go to the address bar, and here I can say transpose. Let's go for C33, H34. It basically selects my data, and now I can just do a Control Shift and enter, and now if you see, all the values have been populated. Now you can just place your cursor in one of the cells, but if you see the address bar, the formula remains the same. This is because this is an array formula. So we can read more about an array formula here. It's basically something which performs calculations on more than one cell in an array. And in the example here, the array is the original data, that is C33 to H34. So your transpose is just changing the horizontal orientation to the vertical orientation. So this is a very simple way in which you can basically use the Excel's capability to transpose your data and convert your rows into columns and columns into rows. Apart from working on additions, subtractions, filling up your data, sorting the data, or basically splitting your data, transposing your data, one of the other requirements is sorting and filtering your data. Now that can be very handy when you're working on huge data and you would want to sort it in a particular order, say ascending or descending, or might be based on a particular field, or if that field was, or if the cell was highlighted with a particular color, sorting the data. So let's look at how Excel can be used for sorting and filtering. Examples are pretty simple here. So let's check that. So if we go into sort and filter and say this is the data I have, say for example, I would want to sort the values in the department column alphabetically. So what I can do is I can select department column, and I'm already in the home tab. I can straight away go here which says sort and filter. I can then say sort A to Z, and that's basically alphabetically sorting your department column. And once I do this, you would see the data has been sorted. But it's not just this data. We can just do a Control Z and check what are the values we have. So here we have meat, which is beef, and 90,000, 110,000, the values. Then you have bakery, which should ideally be the first row if we sort it in an alphabetical order, which goes with bakery as desserts. You have the values, so we can check this again. So select department and then just do a sort and filter, and let's say sort A to Z. And if you see, the data has changed, but it's not just changing your first column, but then it has taken care of all the data. However, the data has been sorted based on the department column. So you have bakery, which aligns with desserts, which has the values, and now we have all the data which has been filtered. Now what we can also do is we can sort December's amounts from largest to smallest. So what we can do is we can basically click any cell in the December column, let's say 20,000, and then what I can do is I can go into sort filter, and then I can say sort largest to smallest. So if you see, bakery breads is the row which has the smallest data, or might be you have deli sandwiches, so that one looks also smaller. So let's do a larger to smallest, and if I do this, you would see the values have been shifted now. So it is no more based on the department column, because now the data is being sorted based on the values in the December column. And you see bakery, which was alphabetically the first one, has become second last. So either you can sort the data based on a department column, which goes based on the values. These are all string values or words, so it sorts alphabetically. If you have numbers, might be you can give some values and you can sort the data. You could anytime do a custom sort, and you could basically select if you would want to select the data. So I could do a custom sort, and then I could choose which is the column which we would want to use for sorting. What is the sorting needs to be done? Is it cell values? Is it cell color, font color, conditional formatting? And then you can also choose the order. So that's one more way to do that. Now, if you scroll down, that also shows how you can sort by date or a color. So for example, if you would want to sort based on the expense date, so there are different options. So what I can do is I can select this date field. I can just do a right click. I can go into sort, and then I can choose, I would want to sort oldest to newest. So since I selected the date field, it basically has sorted all the data, and it has taken the expense date into consideration. Now there are these filters which you see on the row headings. We could have also used those. So I could have selected this, and that basically says or mentions which are the dates I would be interested in looking at. I also have sort by color here. I can do a sort oldest to newest or newest to oldest. So I could also use these filters which have been applied here. Now we have the data which is in color. So if I would want to basically select the color columns or color cells, I could select this. I can basically do a right click here, and when I go into sort, I could choose put selected color or cell color on the top, and that basically will make sure that my data is sorted, and it has also sorted that in a descending order. So in this way you can sort or basically filter your data. What we can also do is we can add filters. So sometimes we can go for formulas which we would want to use. What we can also do is we can basically select the filter which has been applied here. Now how does the filter come in there? So if I would select a particular row, I could select a particular row, and then I could decide if I would want to just add a filter to this one. And that's how the filter has come in. So we have the filter. What we can do is we can basically click on this drop down, and then you have something like number filters. So we can always go here. We can basically choose one of these. So we can basically choose above average. So I could select this, and then basically it shows me the values. We could also delete the filter by clicking on this one, and we could say, well, I'm not interested in this filter anymore. So I could clear the filter, and that shows me all the values. Or I could say that let's click on some other field, for example, food. I can go in here, I can go into number filters, and then I could say, well, I'm interested in values which are below average, above average, might be greater than, and then I can choose what is the value. So for example, if we say I'm interested in food which is greater than $25, I could give a value here. I could say okay, and now I have applied the filter. Similarly, you can select this, and then you can just clear your filter and your data is back. So remember, no data is lost. It is just hidden, or basically based on the filter not shown. So that's good enough for us. And in this way, you can sort and filter the data. So for more details, obviously in all these sheets, you have the links which point to more information on the web, and you can always refer to these. So this is simple way in which you can sort and filter any amount of data which has been stored within your Excel within a particular sheet. Now that we have learned about add, fill, split, transpose, sorting, and filtering, it will also be good to learn how to work with tables, or basically converting your data into a tabular format and then doing some easy computations. So click on this tables option here. Now here we see there is some data which is in 5 columns and n number of rows. So I can basically select this data, and then what I can do is I can insert, choose the table option, and then it says my table has headers, and we'll be okay with that. I'll say okay, and now if you see, this is the table created. It basically has different filters which we have learned earlier how to use, and this is basically my table, which is a collection of cells which has some special features. So we can easily add rows to this table, we can add columns to this table, and we can even do some calculations. So for example, here I can click on this one. I can basically enter some field, and then I can hit on enter, and we see that this row has been inserted, wherein we can easily fill in values. For example, I would say chocolates. I could give some value here, say 25,000, might be 35,000, and then basically I can give in some values here. Now what you can also do is you can continue adding rows in this way, and say for example you would want more columns, so you can select this option here in the top bottom right corner. You can just drag it towards the right, and that basically has automatically created columns for my next months, wherein I can feed in the data. So this is a simpler way wherein you can keep adding more rows and columns to your data if that has been converted in a tabular format. Now let me just do a Control Z, that basically deletes the columns. Again, Control Z deletes the last row which we added, and I can stop here, or I can even remove my values by doing multiple Control Z and removing my rows. So this is how I converted my data into a table, and then I can easily work on this. What I can also do is I can do some calculations. So what we can do, we have a table here, we have a total field, and what we can do is we can just select one cell here. Now as we have learned earlier, we can do a alt and then equals, and that basically says what is this doing. So it says it is calculating the sum of the last 3 months, and if that's what you would want to do, just hit on enter, and it has automatically calculated the totals for all your rows for these 3 columns. So the sum formula is getting filled up. Now I can select any particular cell and I can look in my address bar. So it has already given me the formula where it has started calculating the sum from the October column till the December column and has given me the calculated values of the columns. What we can also do is we can get total rows in the table. Now that's a simpler option. So what we can do is we can select any cell in this particular table, and then we see that there is a table tools design option showing up here. Now I can select this, and then it says, well, let's get a total row. So let's select this, and it automatically populates the total here. And if you would want the average, then we could select this, and from the drop down I can select what I'm interested in. So for example, I would want the average values and not the total. I could just select this, and that gives me the average of these values. So we can always do simpler computations here by converting our data into table format. Let's learn about one more efficient way of working with the data, and that's using your drop downs. So let's see how drop downs work here. Now, say for example, you have this data which has the values in the food column and department is empty. And say for example, you would want to enter the values in department. However, you would want to select the department should either have produce or meat and bakery, and these are the only 3 options which should be available for any user to fill in the values. How do we do that? So we can basically create a table by pressing Control D. So what I can do is under my department here, I can select one of the cells, and then I can do a Control T that basically converts this into a table. I can say OK, and my table is created. Now what I can do is once this part is done, we can select all the blank fields here where we would want this drop down to be applicable. Now under your data tab, you can go in and select data validation, and this has an option called data validation. Click on this, which basically says allow any value. So here I will select I would want to give a list of values, and then I can type in my values here, which I can say produce, say for example meat, and then say bakery. Now these are the values, so we can click on OK. And once we have done that, we basically have a drop down here next to apples, which will only show us the values which we can feed in under the department column. So I can go into every cell, and then I can basically choose what is the department which handles this, and then basically I can select one of these from the drop down. So this is an easier option of creating your drop down and then feeding in the values from the set of values which you have defined here on the right. So this is a simple example of using your drop downs, working with your tables, working with your sort and filter, transpose, split, filling up your data, adding in some data here. And similarly, you can use Excel for more than one use case using its inbuilt features to easily work with your data. Let's see how we can import data or bring in data into our Excel from your local machine or from an external web source. So what we can do is we can open up a blank Excel sheet and say, for example, you have been provided a text file or a CSV file and you would want to import that data into your Excel sheet. That can be easily done. So right now I've opened an Excel sheet. Now I can click on data, and here I have an option which says existing connections from other data sources. So, or you can click on connections if you have already created some. So we can click on from other sources. So this is one option where you can connect to your different data sources and you can get the data from one of these. What we can also do is I can click on connections. Now it says there is none. I can click on add. It says, well, show the connections where connection files on network, connection files on this computer. So I can say, let's get some files from this computer. Now, if that does not show up something, so say browse for more, and that basically shows you different options. So let's basically select a folder where I have some data sets. I'll click in here, and this is basically a folder where I have some data sets. Now let me select this particular file, and I know it is a CSV file. So let's click on open. Now if you would want to verify this, you could have gone and looked into the properties of the file, and it says it is a .csv file, which is what we are interested in. So I'll take this file, I'll say open. Now this basically shows me the text import wizard option, which says, is the file delimited? I'll say yes, click on next. So I will select comma as my delimiter. I can say text qualifier is none. Now this is my data. So my data preview is already showing me the data is what is the data in the CSV file. You can click on next, and then you have an option which says data format is general. You can go for date format, you can go for advanced options. So I'll just say finish, and basically now this has been created here. So we basically have this, and now I can click on close. Now once you have done that, you can click on existing connections. It shows me the data which we have here, the connection which we have created, say open, and then it says, do you want to import this data or bring this data into existing worksheet? You can also say add this to a data model if you are doing some data modeling. So click on OK, and now this data is automatically inserted in my Excel file. I can basically save it into this particular sheet. Now what we can also do is we can also start a new sheet, and that does not have a data, and we can get some other data from web. So what I can do is I can go into my GitHub, and let's say I would be interested in this CSV file. So I can select this, and this is my GitHub path, a path on web. So I can click on raw, and that basically gives me the raw path where this particular file is. Now you can select this, copy this particular path, and here you can come back to your Excel sheet. We would be interested in getting the data from web, might be from a text file where we will have to specify the delimiters, or let's go to web, and here I can give in the web path from where I would be interested in getting the file. Let's give the GitHub path, which is publicly available, and then click on import. Now once you click on import, it tells me there are two fields, data and value. These are within double quotes, separated by comma. So first let's click on import. Now once we do this, it will basically get the data from web and put in here. It says existing worksheet, so we had already created a new worksheet. So let's click on OK, and now you have the data coming in, but then this basically shows me in one particular field. So what we can also do is we can just do a Control A, that selects all my columns here, and that's my data. So we can then basically filter this out. So we can say text to columns. It's a delimited file. Click on next. We can select comma and let the text qualifier be quotes. It shows me data preview. Click on next. So you have the general format. It shows the destination, that's the column. Click on finish, and now your data has been split, and you have the data which you have imported from web. So this is the data which is coming in from web. This is the data which came in from my local machine. And similarly, we can even create connection with an existing database. So I can basically click on connections if I would want to do that. So I have an option called connection here, and it says where the selected connections are used. I can basically click on add. I can basically choose if I would want to get the files from network or from computer like we did earlier. I can click on browse for more, which should show me different other options to create connections. Say you would want to create a new SQL server connection. You can connect to a new data source coming in from different place. You could basically choose what kind of connection would you want. So these are all the different options which we can go for. And we can basically connect to a database. For example, if I have some database and say for example access database, I can see if there are some files with that particular database and I can import it. So similarly, we can also click in here which says new query, and that also gives you an option of getting the data from your files, from all these folders, from databases. So you can basically click here and then you can import data from a MySQL database, provided that is set up on your local machine or on a particular server. You can go from cloud, you can get it from online services, you can get it from other sources, which says from web, from your Hadoop file system, from Active Directory, from a blank query, and you can even combine queries wherein you can run a Power Query editor. You can get the data from different sources and then you can bring it into your Excel. So in this way, you can get your data from different sources into your Excel, into your spreadsheet, and then you can continue working on those data sets. We have already learned some basic operations which you can do in Excel, and let's implement our knowledge by working on this particular data which is coming in from housing data set. Now here, if we see some fields, we have agent, date listed, area, list price, and this is basically the data which has been sorted in newest to oldest order of date listed. So how do we arrive at this? So what I can do is I can just click on data listed, and then I can either go in here, I can select sort, I can get into custom sort, and then I can choose the column based on which I would want to sort the data. So I would look for the newest data to the oldest data. That means that would be in a descending order of dates, or you could say the oldest date or the earliest month will be towards the lower side of your sheet. So here we can select date listed. Now I can say let it sort based on cell values and the order what we have here. So we have newest to oldest. So let's select this. I can say okay, and now if you see, the date has been sorted. So we have your 10/18/2007 on the top, so that seems to be the latest date. And as we go down, we will see an earlier month or an earlier month than that in this date listed. So we have sorted our data into newest to oldest order, and that's based on your date column. So the result shows up here. Now what we can also do is we can have different questions which we would want to answer. So for example, I would want to sort the data in ascending order of area and descending order of agent name. How do we do that? So let's look into this. So this is here. I already have the result here. And how did I get this? So I'm looking for ascending order of area and descending order of agent name. So we can start with any particular column, that does not matter. So for example, if I look into this Excel sheet, I have my agent name, select this, which we want in a descending order. So we could either do a sort and then go for descending sort Z to A. We could also use the filter option here on the top right, and we could do it, or I could just say sort Z to A, and then it has arranged the data based on the agent column being in descending order. Now I can go into area and then I can again do a sort, and I wanted my area column to be used for sorting the data in ascending to descending. And that basically not only changes the order of this particular column but for my complete data. So let's do that. And now if you see, we have the data which has been sorted. So we can see how many values we have here and the area values which we see, and this is how you get your result. So I'll just do a Control Z and again, and I'm back to my original data, and this is the sorted result which we are seeing at. Similarly, we can answer other questions. For example, sort the data according to the following order of area. That is, we are saying county, central, and then your county. So we can basically choose in which particular way we would want to do it. So it is county, central, and then again county. So if I look into my sheet 3, so here I basically have my data which is having some South County, then you have your central, and then you have your North County. So we would want to sort the data to solve our problem, which is according to the following order. So first we go for area, then we go for South County, Central, and North County. So what we can do is we can basically have area field selected, and I would want to sort this particular data. So I have South County, Central, and North County. So I can basically go for custom sort, and then I can choose which is the value or column which I'm interested in. Let's go for area. We will go for something like cell values. Well, you can also try to explore conditional formatting icon if this is what you would want to use, or we can basically go for just cell values. And here we can say if I would be interested in first getting my values for South County. So for example, I can say custom list, and then I can basically give in the new list here. So I can say S dot county, and then I would want central, and then I would want North County. So let's select this as it exists. We can basically say add, and that's basically the order which we want. Say OK, and then say OK here. And now what we would want is we would want our data, so we can compare that with the values which we see here. It starts with Kelly. You have in the 12th row something like Lang, and that's what we are doing. So we can basically arrange the data in a particular order by choosing a custom list and then sorting your data. So that's one more simpler task of what we have done, where we have sorted the data in the order where under our area column, we first wanted South County, then we wanted central data, and then we wanted North County. So this is how you can do it. Now, let's look into one more problem. So it says find all the houses in the central area, and we would want to basically apply a regular filter. Let's see how do we do that. So we can click on this, and here we have the data. So the problem statement is we would want to find all the houses in central area. Now how do we do that? We can do a sorting, but we would want to use the filter which you see here is implemented. So how do you do it? So you can select this area, and say for example I would want to apply filter. I can just go in here and I can say let's get a filter on my first row, and now I have filters applied. So we are interested in looking into the central area houses. Let's go in here. It says all these fields are selected. That means it shows everything wherein your area has all these values. Let's unselect this, and then I will only be interested in the central. So let's say OK, and then say OK. So now you see the area filter has been applied, and we are looking at the central column. So what we have done is we have applied a simple filter and we are looking at our data. At any point of time, if you do not want the filter, then what I can do is I can select this and I can say, well, I'm interested in all the data. So I could do this, or you can clear the filters from area and you get your data back. So that's in one way you can filter out your data. So let's look at an example of sort and filter where we might have to filter the data based on two columns or multiple columns with different kind of values, where it could be and or condition. Now say for example, this is the data I have and this is the question which we need to answer, such as find the list of all houses in the central region with pool and South County without pool. Now, if it was a simple filter based on one cell, I could have just selected my header row. I could have then applied the filter, and once I have the filter, I can look in area where I have three regions. So I'm only interested in Central and South County. So I can get rid of North County, and that's fine. But then we have two different conditions here. So we need the data in Central region to have the value for pool being true, and for South County the value has to be without pool. Now how do we do that? So what we can do is we can first create a copy of these headers here. So let me do that. Now the area has to be South County. So basically I can either just select this and I can choose this value, and then I can select this and then I can choose Central. So that's the criteria which I have, and the pool value has to be, so Central region should be with pool. So then this one basically has to be true, and this one has to be basically false. So South County is without pool. So let's select one of the values here, and this is my criteria. Now to get my result, we can always place your cursor here and you can check this is M column and 8th row. Okay, so we would want the result here. So let's go ahead and now click on data, and then in filter you have an option called advanced, and here what I can do is I can say I would want to filter the list in the place, but that's not what I would want to do. So I'll say copy to another location, and here if you see the list range will tell me that this is the data. So A1 to J126, so A to J column selected and all the rows. Criteria range is basically based on what I've given here. So that is M from 1 to V, which is 3. So I'm selecting these columns and then I'm saying all the way whatever criteria I've given, and copy to, I'm saying M8 to V8. So that basically will give me my filtered result. So you could basically just say okay, and now I have my data which has been filtered, and I have my area which is South County, that is without pool, Central with pool, again South County without pool, and then if you look at your Central value, that's pool. So this is an advanced filter which we have applied, where simply we have filtered the data based on two columns and then we have our result. So in this way you can have your customized filter applied on two different columns and get your data, which can be either replacing the existing content, or in the same sheet in different set of columns and rows you can have your result. Let's look at one more example of filtering where you are trying to filter the data based on an AND condition being met in two different columns, and then you would want to filter out the data for only specific columns. So the situation is the agents with a house in North County, that should be county, area having two and a single type family. So we are talking about 2 bedrooms, and we would basically have a single type family, and here the criteria is that we would want to only populate these columns, which is agent, area, bedroom, and type. Now what you can do is, as I explained earlier, that you can get your result in the same sheet in a different location. So here I have created these headers which says agent, area, bedrooms, and type. Now this is basically a copy of all the columns what we have here: agent, data listed, area, list price, bedrooms, bath, square feet, and so on. So you can basically create a copy of the headers here, and this is where we will give our advanced criteria to filter the data. So the conditions which need to be met is we need to look at North County. So for example, here in area, I can basically go ahead and select one of the values, North County. Now the criteria is having 2 bedrooms only. So let's say bedrooms, and let's say the value should be 2. And then basically I am saying a single type family. So when you would want the single type family, so here under type, I can give the criteria single type. So this is my AND condition. So we are saying North County area having 2 bedrooms and the type is single family. Now this is the criteria, which basically means if I select this one tells me that this is M1 row onwards till V2. So this is what we have, and we would want to filter based on this. So let's go ahead and then go for data filter advanced. And here in advanced, it says filter the list in place. Now that's not what we would want to do. So I'll say copy to another location. This basically selects the list range. So which is telling me A1 to J126. So that's the columns and rows selected. Criteria range is based on M1 V2, which we have given here, and copy to, I would say, for example, from M7 to P7. Now this is the area where this is the place where I want the result. Let's say OK. And now I get my data, which is based on the question which has been asked, that you would want the agents with a house in North County area having 2 bedrooms and single type family. So in this way, you can basically do advanced filtering, get your data and get it stored in the sheet anywhere at a different location. Well, I could have also done filtering in place, and that would have replaced the data which we have, but that's not what we want. We would want the filtered result in a different place. So this is how you can do some advanced filtering. We can also use Excel to filter out the data in one particular column, which might be conditional or say using some numerical filters. Now here, say for example, the problem statement is that you would want to display all the houses whose list price is between 45,000 to 600,000. Or say for example, we would want to filter out the data to something else. Say for example, let's say I would want to filter out the data between 300,000 and 400,000. So we can basically update this. Say for example, I'm saying I'm interested in 300,000 to 400,000, and that's the criteria to filter out the data. Now there are two different ways, or there are two easier ways to do it. One is I would want to look at the list price. So I can select this, I can go ahead and do a filter here, and in the list price, now this is where we would want to do the filtering. So it's pretty easy. You can click on this one and then you can go into number filters and you can choose between. Now that's one easier way of doing it. So I could basically select this. I could say I'm looking for value which is greater than or equal to 300,000 and then is less than or equal to 400,000. So if I just do this, I have applied my filter and I have my data which is filtered based on my criteria, right? So that's one easier way of doing it. or let me do a control Z. Now let the filter be there, which you can anyways use. But what we can also do is, as we have seen earlier methods, so get a set or get your column headers here, and then you are giving two columns here. Now the only difference between my this set of columns, which I have 1 2 3 4, and then you have 7 and 10 columns, and if you see here we have 4 5 6 7 8 9 10 11, right? So whenever you want a AND condition, you will basically add the columns where I can give add condition if it is the same column. If it was a different column, then it would be same number of columns, but AND conditions will lie in the same line and OR condition would lie in a different line. Now here I can give this value, so I am looking for listed price being between 300,000, so I am saying it should be greater than or equal to 300,000, and then I can say less than or equal to 400,000. Now that's my criteria, and then I need my result here, which is in M7. So what I can do is, once I've given my criteria which I'll be using to filter, I can get into data, I can get into advanced, and then I can say copy to another location. So it is selecting my A1 to J126. Criteria range is based on M1 to W2, and then I would want my result from this particular column. So let's say OK, and now you have your data filtered out in a different location in the sheet, which has been filtered based on your AND condition. So you can filter out the data in this way, or you could just apply a filter on a column and give the conditions. Now let's solve one more interesting problem, and here we would want to use Excel, where we would have an and an or condition. So say for example, this is the data given to you, and the question is that you would want to find all the houses in North County. Again, that's a spelling mistake, but then they are North County area with a list price greater than 300,000 and having 3 or 4 bedrooms. So the bedroom has conditional, so it has or 3 and 4, and then basically you have list price which is greater than 300,000. Now I could have obviously selected the columns and then basically gone for a filter. So I can just do a filtering here, and then I'm looking for list price being greater than 300,000, so which we can always give a number filter, and I can say greater than, and then I can say greater than or equal. So I can say greater than, and then I can give 3,000, 30, 300,000, and that's basically the filter which we would want. And here I would want to select the bedrooms, which should be just either 3 or 4. So if for example here I go in here and I unselect this and then I say 3 and 4, right? So I am getting my data which is greater than 300,000, and it should have the bedroom values which will be either 3 or 4 selected. Now that's one way of doing it. Let's do a control Z and get it back to as we were, or you can even just say clear filter, so you get your data back as it was. So what we can do is we can here give the criteria. So for example, I have my list price. Now this is what I would want as a condition. So let's say greater than 300,000, and bedrooms should be 3, and then I can say greater than 300,000, and then I can say 4. So this one basically gives me a situation where your list price has to be greater than 300,000 and bedroom should be either 3 or 4. So we have given our filtering criteria. Now to get the result, what we can do is we can go into data, we can go into advanced, and we can say copy to another location. So our list range is selected, which is columns A to J, row number 1 to 126. Your criteria range is given in M1 to V3, where we have specified, and we are saying the result would be in M7 to V7. So if I do this, now I have got the same data which we were seeing earlier, and here the bedroom values are 3 or 4, and basically the list price is greater than 300,000. So this is a simpler way in which you can create your filters, and all this advanced filtering what we are seeing, it will be saved with your sheet. You can always go back and change this value, or you could do filtering where one person has to look into the filter to see what values have been selected. Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now, Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions, and you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal, so you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this is returns the current date and time formatted as a date and time. So this is the function which we would want to use, and if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example, I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or SUMIFs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I placed my cursor here, and then if I did a auto sum, so it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows, which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a Control Z and let's get it back. So now we have our data, and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here and let's start with sum if. Now when I say sum if, it shows me there is a function with sum if which we would want to use. And here once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value, or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell, and whatever value that cell has. Well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing, and in this way you have more clarity that you are using SUMIF. You are filtering the data, so you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for sum if. We can open the bracket. Now it needs the range. So we are interested in revenue generated. Now that's the summation we want, and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want to give the filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using sum if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criterias to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now when we are answering this question, we can also look at the order in which things have been asked in the question. So it says what is the total revenue generated from central region. So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs, and when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows. in the D column, and we need to give the filtering criteria. So let's do a comma and then just give in our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones, where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs, I would be interested in E column. Then let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with sum ifs. Now we know that you start with sum ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now, remember, you can answer these questions using filters, and that can be an easier way, but then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this COUNTIF function, and if I go into COUNTIF, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name say Gil appears or Gil has made a sale. Now I could just say COUNTIF and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep. So I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a COUNTIF that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil, and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now what about this question? So which basically says which sales representative made a sale more than 3 times. Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with COUNTIF, then I need my filtering criteria. So that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like sum ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, and this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows. And then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2 10 2019, and then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44, and here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this. And if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being East, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you are saying the region has to be East. So we would want to find out the total number of orders. So my region is East, and that gives me the result. Now, similarly, you can also find out how many times Gill sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil, and then we are looking for sales rep, which is Gill. So that is my column C. So let's say C2 to C44, and the value should be just Gill. So it tells me it's twice where Gill has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gill. Okay, and now we are interested only in the item being pencil. So I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic. Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criterias or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data, and what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule, but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow, and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile, and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green. And if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red. You have mid values, and then you have the positive value. So this is a 3-color scale, and that easily helps me in identifying the data based on the cell values. Now in conditional formatting, what you can also do is you can basically color the cells based on their values. So what we are seeing here is if the revenue generated is greater than average, then that shows in green. And if the revenue generated is lesser than average, that shows in orange. Now how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So in our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below. We'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this, and then I could basically choose my area, just hit on enter. And similarly, you can go in here and then select your area, hit on enter, and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this, and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example, I'll go for blue, and I'll say okay. So now if you see, my top 10 values are blue. Now similarly, I can add one more rule. So I can say new rule, and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say OK. Say OK, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color, and that takes care of the things. You can say, for example, select this, and now this is selected. What I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color. You have no border. This is basically color is black. Now I can go for something like gradient fill, and I can say OK. And now if I say apply and OK, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values. So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color. I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule, and then I can choose. So I'm saying the format style is icon sets. I'm not using a data bar, I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values. if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts, or people who are working in business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis. Let's continue learning on using Excel for various things. Now we have learned on conditional formatting and seen how that can be very helpful. Let's learn one more feature of Excel, and that's basically your data validation. Now this can be very useful when you would want to work on validating the data which is being fed in the cells. So you could limit it to basically a number between a particular value. You could also add some messages to it if you would want, or you could even circle invalid data or clear validation circles. So data validation really helps us in validating the data which is being fed in to particular fields. Now, it's a feature in Excel which is mainly used to control what a user can fill in a cell. You can decide what type of values must be entered. You can also restrict user to enter only valid data, and if any invalid data is entered, an error message will be displayed. Now that's where you can use your data validations. So let's see how that can be done. So for data validation, let's see some exercises here. So for example, you have a name column and you would want to restrict that the name should accept only 15 characters. Now, how do you do that? So you can basically select the cells, or you can just select a particular cell and then we can later drag the property to other fields. Now here, once the cell is selected, so for example, let's try this out and let's see if that works. So for example, I will say Peter Johnson, okay, and that is basically 5 and 9 and 12 characters. So let's say junior, and if I do this, it says input length is greater than 15. Do you want to continue? If I say yes, right? So basically it is allowing me to add the value here, but then it has basically violated the rule. Now this is giving a message to the user that the username should be entered less than 15 characters. Now how do we do that? So for this, we can basically select the column and then we can search for data tab and get into data validation. So this is where you can create or select different kind of rules. So for example, I can go into data validation, I can go into settings, and I can say the text length, and that should be less than 15. Now this is the maximum I'm giving, and it says apply these changes to all other cells within the same settings. So I can do this, or I can just drag and drop. So I can basically apply this formula, and now you can in fact randomly check in any particular cell, is the rule applied. So it says text length less than 15. So we can basically control data validation in this particular column, and that will allow only 15 characters. It will pop up a message if the user really wants to go beyond the particular limit. Now you also have similarly date of birth. So the restriction is date of birth should be between 10 Jan 1990 to 30 December 1998. So this is what we want to restrict. How do we do that? So we can select the field, we can click on data validation, and if you see here, I have selected date, and then date is between, and then obviously you can give a range, that is 10 Jan date 1990 12/30/1998. So that's the start and the end filter which has been applied. And once this is done, you can also check your input messages, which says when cell is selected, show this input message, enter a valid date. So if you see here on the left, there is a pop-up which is coming up which says enter a valid date. Now I can also say when user enters invalid data, show this error alert. So I can say stop. I can say invalid entered, and this is how I have set a rule. So for example, if I just do something like this, and that says invalid date entered, I can do a retry. It will take me back here, but unless and until I do not give the right format, the date will not be accepted. And again, the same thing applies to all the cells. Similarly, email. So we are saying the email should have @ present in the value provided. Now for this, we can use a formula and we can select, well, I would want to apply this rule to all these rows starting from C2 to C14. So let's get into data validation. Let's look in settings, and here we are choosing custom. Now within custom, I'm choosing what is the formula. So I'm saying is number, and then I'm saying find @ for the rows C2 to C14. So the only thing we are concerned about here is the value should have an email icon. You can input a particular message. You can say what has to be done for error alert. So for example, we can basically go in here and we can say invalid email. That's the title I'm giving. And we can say email should contain @. So if I do this and if I say OK, now you can test it. So you can say A, B, C, D, and that says email should contain @, and basically that will not allow me to add the values. So now you have the field called salary. It says salary should be greater than 50,000. Now we can limit the values by choosing a whole number. So for example, for salary, I can go into data validation. I can go into settings. So here I can say something like decimal, or I can go for whole number. So both of the things are fine. It depends on what kind of values get into this particular field. So if I say whole number, and if I say it has to be greater than 50,000, so I'm saying the minimum is 50,000. Or I could have given a decimal, and then I can say greater than, less than, equal, or anything, or even between. So I can select greater than, and then I can just say OK. Now for rank, the rule is rank should be between 100 and 200. So again, we can use a whole number. So ranks will generally not be decimal. So this would be whole number. Salary can be a whole number, or it could be decimals. So we have chosen decimal here. And in rank, if you click on data validation, I have chosen whole number. I've set data between 100 and 200. Input message, nothing. Error alert, nothing. But that depends. I can give this. So this is how you can just do a simple data validation and control the values which land in the cell. Okay, so now let's also understand how we can restrict the values in a particular cell, which might be based on a list of items. Now, for example, here, if you see, I have two columns. So one column basically has the values of city, names, and then you have places within that particular city. So if I would want to implement a data validation based on this, so for example, if you see here city, and that basically shows me only the 4 values which can be entered. And if I go to place, then it tells me for Maharashtra, I can only enter Pune, Mumbai, Nasik. Now, how do I do this. So say for example, you take an empty field and you want to restrict the values of city names. So I could select data validation. I could basically select list, and then it tells me you need to enter the list values, that is the source. So you click here and then I can just select these fields. Now if I do this and if I say okay, it has implemented a data validation, but if you look into this, it will show me the same thing, but then it shows me some empty cells which did not have any value. So this is fine, but it would be better if we do it in a different way. So I can select this and I've already given my city names here. So I can just do a data validation, and here in the source, let me get rid of this. Now I can just have my cursor here. I can select these values, and then if I say OK, so now if you see, my city names have been restricted to these values. And that's how you can implement your data validation. So I have this data validation here, but I will get rid of this one by just doing a Control Z. Now I'll come here and say, for example, I would want to implement the same data validation. Now the easiest way would be in doing this for all my 4 cities. Now if you see here, I have data validation. I could choose Bangalore. And if you come and check here, there is no data validation, but we have implemented data validation here. Now, how is that done? So I could select this, or for example, I can go in here. I can select data validation. I can select list. And then here in the source, I will say for Bangalore, the values should be these. And then if I basically say, okay, now if we see, these are the values which are fed into Bangalore. So we could do this, or like what we have done here. So if you can check the data validation rule, I have used list and then I have said indirect F2. So basically I'm giving in a formula which relates to the value which is in for the city Maharashtra. So we could do this, or in a simpler way, we could do this and then just drag and drop here. So we could check for Maharashtra, what are the values? Let's choose a different city. So for example, Kolkata, and here I will choose. Now, since we did a drag and drop, it has basically taken the values of Bangalore. So that's not right. So we select this, we go into data validation, and here I can either feed in the values, that is such as Bangalore. I could basically say something like this, Kolkata, and I could say okay. So now if you see, it shows me the places in Kolkata. Now here we have, let's choose a different city. So for example, let's go for Delhi, and here I can go to data validation and I can just say Delhi. So this is an easier way of doing it. Or if you remember the formula, then what you can do is you can just give in indirect and then basically give the value of the cell for which you would want to keep in the values. So this is how you can do list validation. So you can provide a list of values and then you can restrict the values in a cell which should be belonging to a particular list. So this is how you do a simple data validation by restricting the data in the form of a list. Now let's learn about pivot charts and tables, which is one more very useful feature of Excel and which allows you to work with your data or perform data analysis. Now, pivot table is a summary of your data. It is used in cases where there are numerous rows and columns in your data set, and it allows you to group your data in several ways so that you can derive meaningful information from it. Now, the visual representation of a pivot table is termed as a pivot chart. Now, how do we do that? So let's see an example. Now, here is some data. Here you see we have some row labels, which basically gives me some category of items here. It also tells me the sum of sales. and basically it gives me per item what is the total sum of sales which were made. Now, how do I get this here? So for example, if I would want to delete this, and I would be interested in getting the total sales under each category of items. Now we know that we have different data here and it's huge. For example, on the row end, if I just do a control and right arrow, it tells me what's my right last column. And if I just do a control and down arrow, it tells me there are 9,994 rows. Now I can use this, and what I can do is I can basically work on insert and go to pivot table. Now this basically tells you need to choose the range. Now since I have chosen my first row and first column, it basically has selected the data, and that's fine. Now do you want the result in a new worksheet? I'll say existing worksheet, and I can choose a location. Now that basically needs me to select a field. Might be we can just select this field, and that should be good enough. So for example, if I close this or if I say OK, so this is basically an indication that my pivot table will be created. Now, what are the fields we are interested in? So as per the problem, we need to find out what are the total sales for each category. So let's go in here and let's select the field category. Now, as soon as you do that, it shows that the rows which are being selected are for this column category. And now we are interested in getting the sales. So we would want the sales per category. So let's select this. So you see sum of sales is selected. Now close this, and that's it. That's your data. So it shows you row labels. It tells you what are the different categories, and it also gives you sum of sales, which is per category. Now this is one easy example where we have solved the problem, where we have tried to find what were the total sales under each category of items. So for example, let's have another data set. So again, you can just check how many rows we have, and it is basically the same 9,994. And if I look in columns, it basically shows me profit is the last column. And here we would want to find out which category. So for example, let me get rid of this. Which subcategory of items sold the maximum under each category? So we have some categories here which says furniture, and it shows some subcategories, and then it shows me office supplies and then some subcategories, and same thing with technology. Now we know how we got this data, but this is different than what we were seeing here. So here we were just getting the categories, but we did not have any breakdown of subcategories within this particular category. And here you see there is a breakdown, and then basically you can also apply a filter which basically says what is the data you want, and if you are interested in finding out a particular value. Now how do we do this? So for example, let me get rid of this. Now we know how we can find out the category of items, but we would want to find out which subcategory of items sold the maximum under each category. So here we are not looking at sales, but we are looking at the quantity. Okay, so what we can do is we can go to the first row and first column, click on insert, click on pivot table. Data is already selected. Let's choose existing worksheet. Let's choose a location in our worksheet where we would want to have this. So might be I can select this particular field and then just close this. So it says this is the existing worksheet. Say OK, and now you need to select your columns. So for example, if I would want the data for categories, so I can select this. Now I know that within category, these are the options which we have, and then there is a subcategory. So let's select that. And if you see here, now we have the data which will be filtered. So based on your category and subcategory, and then we will choose quantity. So it automatically understands that this is something on which summation can be done. So let's select this and close on this. Now if you see here, we have got our items where we can see the subcategories within a particular category. Now I can basically close this, and that just shows me high level categories here. So here I can again select a particular row and column. I can go for either a new pivot table. So we could basically select this. The row is already selected. Existing worksheet is what I want. So now I will select this particular place, say OK. Now we do the same thing like what we did earlier. So we will select category, subcategory, and quantity. So the data has already come in. Just select this, and now you already have all your data. But this is not what we want. We want to basically apply a filter to this. Now how do we do that? So we can go for slicer. So I can go for insert slicer, and then it tells what are the subcategories which you are interested in. So for example, if I go for something like subcategory and say OK, so this tells me what are the categories you are interested in. So for example, we know that furniture has furnishings with the highest value. So I can select, say, furnishings, and then I was interested in office supplies. So within office supply, I can basically search for here binder. So I can just do a control and select binder. And then I can also know for technology, I can select phones. So I'll say control and select phones. And now if you see, the filter has been applied and we have these subcategories which are selected. So we have our data here. Now we don't need really this. So I can just delete this, and I have my data which shows me furniture being the main category, and that has only furnishings, office supply having binders, and technology having phones, and that basically is a filter applied on the result of your pivot. So this is how we are seeing which subcategory of items were sold maximum for each category. So this is how you can easily use pivot tables, and you can do some analysis. Let's look at some more examples. Now, let's see if you have to answer this question, which says which were the top 3 states for each region that made the highest average profit. Now, how do we calculate that? So for example, this is the data we have, and as I've instructed earlier, you can select the first row and first column. You can click on insert, go into pivot table, and that basically selects all your data. We will choose the result should be in this existing worksheet. So select this, click here, and then basically let's select this cell, and I will say OK. So now my pivot table will be here. So we are interested in finding out top 3 states within each region which have made the highest profit, or which have made the highest average profit. So for that, first we will select region. So when we select region, it shows here region, and within region you will then select state. So within every region you have multiple states, so that's what we are selecting. And then we are interested in looking at the profit, so let's select profit, and that automatically shows up here. So we can now say close this. So basically we have all the data, but we are looking at the sum of profit, but that's not what we want. We are looking for top 3 states from each region that made the highest average profit. Now, how do we change that? So here we have sum of profit. So I can do a right click, and basically I can say summarize values by average. So now I'm getting the average here, and that basically tells per region I have the average profit. But first is let's sort this data. So let's go into sort more options, and here I have average of profit. Or for example, as I said, you can select region, say OK, and now it is basically having the regions, and then you have your state value. So again, we can do a sorting here, and I can say, let's go for more sort options. I'll say descending. The state values should be based on average profit. So let's say OK. And now if you see, in particular region, we have the data which has been sorted, wherein you have the highest average profit on the top. Now what we can also do is we can basically then go for filtering. We can say top 10, but I'm not interested in top 10. So I could reduce this to top 3. And this is the items, average of profit, say OK. And now you see per region, you have the data which is showing me top 3 states, what are the average, and then you are also looking at the subtotal, so which basically says average profit for your west. Now if you would want to arrange this, your west and south and east and central, in a particular alphabetical order, if you would want to sort it, you can always do a sorting, and you can choose sort Z to A if that's what you would want to do, or you can go for sorting, more sort options, and you want to sort the region, which is as of now based on descending Z to A. Let's make it ascending, say OK. And now you see the data has been filtered. So it says per region. Now you can always select this and you can say, what is this? So this is basically your average of profit. Now we are looking at each region and the states, the top 3 states as we wanted within a region, and what is the average. Now we have one more question. What is the percentage contribution of each subcategory of products under each category to the total sales? So we know there are different products, there are different categories, and all the categories contribute to the total sales. So we would want to find out what is the percentage contribution of each subcategory of products under each category. So we not only want the category percentage, but we would also want what is the contribution of each subcategory to each category to the total sales. How do we do that? So for that, we need to again just place our cursor here or select the first row and first column, click on your insert, click on your pivot table, and now the data is already selected, existing worksheet. Place your cursor here, and then let's select this cell, say OK. Now your pivot table fields are here, so we are interested in category. So let's select category, and then within a category we will have subcategories, and we are interested in the sales data, wherein it is already going to give us the sum of sales, but we would want this in the form of percentage rather than just the sum. Now we can click here value field settings, and it says if you would want to summarize this, it says show value as, and what are the values you would want. So you can straight away go ahead here and say percentage of grand total. So we could do that because we know we will get a sum of sales and grand total. Now I could basically say percentage of grand total, say OK, and then just close this. So once you have closed this, you see already the data is in percentage. So now we have our data with subcategories, but we also want the data to be sorted, might be in a descending order, which tells which subcategory is contributing more than others. We can select how many subcategories we are interested in. So we can basically select one of the subcategory cells, right click. Now you have option filter and you have sorting. So we can say more sort options. Now here I will say descending, and you want the descending to be sum of sales, which is already showing as percentage. Click on OK, and now you see for each category it shows the percentage contribution towards the sales. It shows the subcategories contribution to a particular category and also to total sales. So technically speaking, if you look at all these values which are subcategories and if you would total them, that would be your total grand total. So this is how we can solve a simple problem like this. What is the percentage contribution of each subcategory of products under each category to the total sales? The next question is, which customer made the lowest profit in the home office segment in each state? Now here we know that we are looking for home office segment. We are looking for customer which made the lowest profit. We are also looking for the state as the main criteria. So in each state, we would look for home office segment, and within that we would look for customer which has made the lowest profit. That means the lowest value of the profit. So how do we do this? So let's get into selecting our row and column. We will go into insert. I'll say pivot table. I'll say existing worksheet, and let me get my result here. So let's say okay. Now that gives me the pivot table. So the first thing is we are looking at per state, and I would be interested in home office segment, or I could first start with segment. Now here we have segment, and in segment I can basically select home office. So I can just do a uncheck and select home office only, and now I can select state. So that will be my subcategory within segment, and then within state we would want to find out the customer. So let's get the customer name, and we are interested in finding out the lowest profit. So let's select profit, and here we have sum of profit. So the fields are selected. Close this, and now you have your data which basically shows me the names of customers which made the profit, but it's not sorted. So we can sort this, and we have state entries also, so that's fine. So what I can do is here I can basically say sorting, go to more sort options. I can say I want to do a descending, or I want to do an ascending based on sum of profit. So let's do that. Now you see the topmost value is the lowest value per state within home office segment. Now what we also want is we just want one value per state. So how do we do that? So we can just go for filtering, go for top 10 values. I'm interested in bottom value, and in that also I'm looking for only the lowest value. So let's select 1, say okay, and now you see we have data for home office segment per state, customer who has made the lowest profit. So we have easily answered this question using our pivot table. Now say for example we have a question which says find the sales made in each quarter of 2016 for all the regions. So the data has to be divided quarterly, and use order year as a slicer. We can do that by selecting what data we would want to slice, and then we would want to create a pivot chart also. So for example, how do we do that? So for example, I will get rid of this, I will get rid of this, my pivot chart, which we can recreate. So find the sales made in each quarter of 2016 for all the regions. So this is what we want. Now how do we do this? So for example, let's select this. We will do a insert pivot table. We will basically say existing worksheet, and then I can select this particular cell. I'll say okay, and now I'm interested in data quarterly. So first let's select our field here. So we should basically have, if all our fields are selected, say for example if I say order date, now You see, we have quarters and years which are selected. Now we could be selecting these fields which says quarters, years, and if I would want data to be filtered based on years, I could do that, or I could get rid of years. So I have quarters, I have order date. So that's being already selected. Now, what else we need? We need to find out for every region. So let's select the region, and we can also add region as a column here. So that will basically give me all the regions as different columns. And then finally we want the sales. So let's select this. And now let's look what we have. So if you see here, we have our data, which is for each quarter. It gives me the total data, but what we would be interested in is not looking at the total data, but we are only interested in quarter of 2016. Now, how do we do that? So what we do here is we have row labels. So let's click on this. So we have date filters, and then in date filters, we can go for between, and then we will say 2016, and the value has to be 1. And then let's select this, and let's change this to 2016, and this is 12th month, and then we can say 31. So we are saying the date has to be 2016, and it basically says not a valid date. So let's select a particular date and see. So the month has to be here. So let's change this, and let's make it date and say OK. And now we have our data, which is for 2016. So for example, I could basically select this, and here I could be looking at what are the filters we have. So it says clear filter from order data. So we have applied the filter on order date, and these are your date filters, which is basically date 16. Oh, this is wrong. So this one has to be changed to 2016. So select this, and now we have our data for 2016. So we have found the sales made in each quarter of 2016 for all the regions, the grand total for a particular quarter if we are looking at the value, or for individual months in a particular quarter. And we have sliced the data. Now we could have also introduced a slicer by selecting which field we would want to implement. So for example, if I would select a particular field and then I could click on slicer, I could choose I would want to slice the date based on order date, and then could have done it. Or we have just given the date for 2016. Now we just need to plot a graph for this, and that's very easy. So you just need to select the complete pivot data, and here you have the chart options. So let's go for line chart, and that basically shows me the line chart. So we can select this, we can just drag and drop it here, and then we can basically check if that data we have created a pivot chart, and basically we have sliced the data for 2016. Let's answer one more question, and that's finding the profit made in each year for all the categories of products in East and West regions only. And then we would want to create a histogram for the same pivot table. So histogram usually gives us the frequencies. So let's look at how do we calculate the profit made in each year for all the categories. So what I can do is I can basically select my row ID here, and now I'll do a pivot table. So the data is already selected. I'll choose existing worksheet. Let's select this particular cell, say OK. Now what are we interested in? Now, if you look at the fields, we don't see any years or quarters and so on. So for example, here I can just choose order date, and then basically I can choose, say for example, years or quarters, the data which is coming out from my order date. So here I will just select years. Now, then I have my order date. So we are interested in the years, orders, and we are interested in, let's look at our column or the question what we had here. So we have years, find the profit made in each year. So let's select profit. So that basically says sum of profit. But then I'm also interested in for all the categories of products. So what I can do is here I have my field which is category, and that I'll add to the columns. So that shows me what are the different categories, and this looks fine. Now I'm also interested in east and west regions, so that is basically in the region. So either we could add a slicer or we could do a filtering here by adding the filters. So first is I'll click on region, and here it says select all. I'm only interested in east and west, so let's select this, take this, put it here, let's say okay, and now we have the data which has been filtered based on the region. So here we have region, so you can always look at the filter, it is east and west, and we have our year data per year. We have different categories. You can always look at what are these column labels. So this is my different categories, and this is the profit per category, and then you have your grand total. So we have already our data. Now let's say close this. So we have our data for all these years, different categories, the profits made per year. And if I would want, I could go into an year and I could look into different months. So that also is showing up. And now we would want to basically plot a histogram with this data. So I can just place my cursor here, I can select this, and then I can go into insert, and here I have different options. So we can go for bar chart, we can go for insert hierarchy chart, we can go into waterfall, funnel, stock, surface, or radar chart. So there are different options what you have here, and we will go for a simple histogram which is two-dimensional. Let's select this, and here you see you can obviously select different regions. You have your years which shows up, you have your order date, and then you have your categories which can be chosen for your histogram or for your bar chart. And that basically is how you use your pivot table. You use some calculations, and then you can plot your needed graph to visualize the data and understand it in a better way.
Hey everyone, welcome back to Simplilearn's YouTube channel. Today we are going to talk about ANOVA in Microsoft Excel, and I will walk you through a step-by-step guide on how to perform this in Excel. But before we dive into that, let's first take a quick look at what ANOVA really means. ANOVA, which is analysis of variance in Excel, is a statistical method to compare the means of three or more groups to see if they are significantly different from each other. It helps determine if variations in data are due to real differences or random chance. It's useful because it helps in finding differences as it shows if groups have different results. It saves time as it tests all the groups at once. It clears insights and helps make decisions based on our data. For example, if a teacher wants to compare the effectiveness of the three different teaching methods on students' math scores, they can divide the class into three groups of 14 students each. Using ANOVA, the teacher can analyze the math scores to determine if one teaching method is truly better or if the differences in scores are due to chance. Now that we have a basic understanding of what ANOVA actually is, let's get into Excel and see how you can easily calculate this using the built-in tools. I have a sample of data in my Excel to perform the ANOVA over. There is an amazing feature in Excel that many people are not even aware about is a data analysis tool pack. If you have not come across this word, the Data Analysis Tool Pack in Excel is an add-in that provides the advanced data analysis tools for statistical and engineering calculations. It simplifies the complex data analysis task by offering the built-in features to perform various statistical tests and data processing without needing to write formulas manually. So we need to ensure first if we have activated the tool pack correctly. So for that, we need to go to the file and then options, and then we have to move to add-ins, and here in the manage you have to choose for the Excel add-ins and click on go. After that, you need to click on this analysis tool pack and click on OK. Now when you see the topmost bar, that is the data, if you click on this data, you will see a data analysis button over here. Now we are all set to perform the analysis of variance. To perform this, I will click on data analysis button, and from there I will choose ANOVA single factor and select on OK. Now here in the input range, we need to enter the range of the cells containing your data. For that, I will click on this upper arrow button and highlight my cells that are containing the data. The next option is grouped by, depicts how your data is arranged in your sheet. If it is arranged in a column like I have arranged, choose columns, and if it is arranged in a row, go for the rows. Now here in the labels in the first row, if you have labels like mine, like group A, group B and group C, do tick this button. Then alpha is generated, and here in the output options, this is where you want your result to be returned. The first option is the output range, is where you can specify a particular cell where you want your result to be returned. The second option will enter the answer in a new worksheet, and the third option will enter the result in a particularly new Excel file. I will choose the second option and will name it as ANOVA. Now we have got this result. Within just one click, you can definitely get the ANOVA single factor results. Now I will explain each factor, what it means, count, sum, average, variance, SSDF, MS, etc. in the next PPT. So the first table depicts a summary of the data available in the analysis. So the first one we have got is count. Count is the total number of data points in each group. Here, in group A, group B and group C, we have 14 data points. Now moving on, we have sum. Sum is the total value if we add up all the values in each group. So the sum of group A is 958, sum of group B is 1093 and sum of group C is 1280. Now moving on, we have average. Average is the sum divided by the total number of data points in each group. So the average of group A is 68.42, the average of group B is 78.07 and the average of group C is 91.42. Now, lastly we have variance. Variance is the average of the square differences from the mean. Now, the variance of group A is 141.34, the variance of group B is 209.60 and the variance of group C is 119.49. Now the second table here is divided into three groups, the between groups, within groups and total. So the first row depicts the result when the between rows are classed as a source of variation. The second row depicts when the source of variation is within the groups. And finally the last row is just the total. Now we will see what each column represents. So the first one we have is SS. SS stands for sum of squares. Between group SS is the total variation explained by the differences between the groups. Within group SS is actually the total variation within the groups due to the random error or individual variability. And the total SS is the sum of the between group SS and within group SS. So the between group SS over here is 3735.19, within group SS is 6115.78 and the total SS is 9850.97. Now moving on, we have DF. DF stands for degrees of freedom. This is calculated slightly differently. For between groups, DF is the number of groups present in your data minus 1. I have 3 groups, so 3 minus 1, I have got 2. To determine this, Within groups, DF is the number of observations minus the number of groups, that is 42 minus 3, that is equal to 39. Then we have MS. MS stands for mean square. You can think it as the variance for each source of variation. To calculate this, we can simply divide the sum of squares by the degrees of freedom. Now moving on, we have F. F stands for F statistic. Here the F statistic is calculated as MS between the groups divided by the MS within the groups, and it is equal to 11.90954. Now moving on, we have the F critic. F critic stands for F critical value. It is calculated easily by Excel, or you can perform it manually by looking at the critical value table. So the F statistics is then compared with the F critical value. If the F statistical value is greater than the F critical value, we can conclude that the test is significant. Now moving on, we have the p-value, the probability of obtaining an F statistic as extreme as or more than the observed value, assuming the null hypothesis is true. A small p-value that is less than 0.05 suggests that the significant differences between groups exist. As my p-value is more than the alpha level, that is the 0.05, we fail to reject the null hypothesis. Therefore, there is no difference between the means of the three groups.
Tableau is a very powerful and fastest growing data visualization tool used in the business intelligence industry. It helps in simplifying raw data into very easily understandable format. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. So today we will learn Tableau through the following agenda. First, we will understand what exactly is business intelligence and what is the importance of business intelligence in real-time business. Followed by that, we will have a brief introduction of Tableau, and we will also learn how Tableau really helps in business. Next, I will guide you through the installation procedure, where I will help you to install Tableau into your local system. Once the Tableau is installed into your local system, we will have a brief tour about Tableau, the kind of worksheets you can work with, the kind of data it can import, the options provided in the Tableau, the kind of charts, everything. So once we have a better understanding of Tableau and the options provided in it, we will directly move into the worksheets, where we will work on the Excel data and try to create some worksheets. Once we are good with the worksheets, we will enter into the next segment, where we will understand how to create a real-time dashboard. I hope I made myself clear with the agenda. Now let's begin with our first topic, that is the business intelligence. So what exactly the business intelligence term mean? So to understand business intelligence in a much better way, let us imagine that you have started a business. So a business of online marketing, where you sell some phones, some products, and some other items which are necessary for your customers. So what would you do to best reach your customers? First, you will understand their needs and requirements. You will either try to mail your customer or try to contact your customer through a phone call, and you will understand what exactly he needs and what type of requirement he has. Just imagine that your customer needs a phone. You will understand his need and then try to call him and understand his requirements. For example, it may be an Android phone or it may be an Apple phone. So he will be having some requirements, certain size of RAM, certain size of ROM, and extended memory or operating system. So you will basically understand his needs and requirements and try to provide him with the best product. So in this situation, if you provide him with the right and best product, then you'll be having a good customer satisfaction and positive reviews. This customer satisfaction and reviews come under the sentimental analysis. These sentimental analysis and positive feedbacks and reviews from your customers will help you gain more customers. And in result, you will have a good market profit. So this is what exactly business intelligence means. So to make things easier in business intelligence, we have certain softwares: Tableau, SAP, SAS, Oracle, MicroStrategy, Click. These softwares are the segment leaders in market research and business intelligence. So today we will be learning about Tableau. So why Tableau? You might have that question in your head, right? So the answer for that is, according to Gartner, there are multiple business intelligence softwares like MicroStrategy, BestLooker, Demo, IBM, Salesforce, Tableau, Microsoft, Click. But the best in the market leader in the ability to execute and completeness in the vision, Tableau is ranking in #1 position. Now we have understood what exactly business intelligence is and why Tableau is on the top. Now we will understand a brief introduction to Tableau. So Tableau is a business and analytical software tool developed in America. Tableau helps people to understand, visualize and make data-driven decisions in real time with extreme agility and accuracy. To better understand what exactly Tableau does, let us imagine that you're given some data in the form of Excel sheet that has thousands or even lakhs of rows and some hundreds of columns or even thousands of columns, and you had to kind of filter or kind of apply some operations on that and get some insights of that particular data. So basically, if you do it in a brute force method, it could be really time consuming. But what if there is a software that can write all the SQL queries possible on your data, and all the data you wanted is readily available, or all the information you ever wanted on your data is readily available just by a single click? Yes, exactly. That's what exactly Tableau does. It automatically writes all your SQL queries in the background, and it can provide you the information in the form of a variety of charts like the bar charts, pie charts, and it can even give you some live data and also the advices based on which you can move ahead and improve your business. Now let's go through some sample data and understand how it exactly does it. So on my screen you can see some Excel data which is based on some store in America. So here you'll be having different regions of America, that is South, North, East and West, and the category of furnitures, subcategory bookcase, and etc., which kind of category is selling most in which kind of region, and what's the discount, what's the quantity, and what's the profit, etc., in this particular Excel data. So you'll be using this particular Excel data to get some insights of the sales happening in America. So this is how business intelligence works basically. So here we should use the Microsoft Excel to get the necessary insights of this particular data. Now just select all these cells of this particular Excel and select insert, and on the left corner you can see pivot table. Select that, and here if you had an existing worksheet you can select the existing worksheet, or if you don't have that you can select the new worksheet option and then just press OK. Now we have our pivot table over here, and we have our fields in the Excel data on the right side part. Now just select a region and push that into the columns, and now let's select sales and push that into the values. Now we have the sum of sales option, so we have the east zone, central zone, south zone, west zone, and the summation of sales happening in that particular section of America or region of America. Now we can also make some changes to the values, like we have summation, and we can select some value field settings, and inside that you can go through count, average, maximum, minimum, and select few more options based on which you have to calculate it. Now let's push the rows, or let's push the regions from columns to rows so that we can have some good data in a more understandable form of view. So there you go, you have the central region, east, south and west on the left side, and on the right side you have the summation of sales happening in that particular region and the grand total of the sales. Now let's try to do this in the Tableau. So there you go, your Tableau just got started. So on the left side you have got the connect option and the various types of files it supports, that is the Microsoft Excel, text file, JSON file, Microsoft Access, and more on that in the next upcoming part where we'll have a tour on that. Now let's select Excel. So we have already an Excel file on the downloads part. Just select that one and just open it. And there you go, you can see all the rows and columns here. Now let's go to our sheet. So on the screen you can see that on the left part we have the data which is connected to the Tableau, that is sheet 1, the store data, and these are the dimensions and these are the measures. So basically Tableau divides the data into dimensions and measures automatically, and you can see some options provided on the top row, which is the file, data, worksheet, dashboard, story, analysis, map, format, window, help, etc. And here you can see some marks, which is the color. So here you can just imagine that you worked on some bar data or bar chart, so that you can use color options to provide different colors to your bars. And you can also select the size of your bars, add some text if you wanted to add in, and you can add some details if you wanted, and some tool tips, etc. And on the right side you can see show me option, and this particular tray helps you to get different types of charts you wanted to keep on your data. For example, you want to select pie chart, you can just select pie chart. If you wanted to go with bar chart, you can go with bar, and some area charts, and you can see maps, etc. And the best part is when you hover over this particular chart or any kind of selection you wanted to make, then Tableau automatically helps you for having the dimensions and measures for that particular chart. You can see in the bottom part where it is highlighted for pie charts, try one or more dimensions and one or two measures. So if you hover over the bar chart, you can see that Tableau tells you for side-by-side bar charts, try one or more dimensions and one or more measures. So basically it is telling you to have one or more dimensions or one or more measures in order to use the side-by-side bar charts. Now let's do the same thing what we did in Excel. So here we'll just select the region and pull that over the columns, and now we shall select the sales and push that over the rows, and there you go. You can see the bar chart over here, and it's automatically telling you the kind of sales happening in that particular region. Now you can even select the region part and drag that over to color so that it gives you different colors. Now if you see on the right side show me tab, you can see different types of charts available for your data. So you can have a pie chart, you can have the bar chart, you can have few more map charts, etc, etc. So that's how Tableau gives you automatically all the types of options that you can work on the data visualization by using different types of charts. So that's how Tableau basically works. Now we will go into the next step where I'll help you to install Tableau into your local system. Once the installation is done, we will get back to Tableau again, and we will understand each and every part of Tableau in much more detail, and we'll also work on each and every type of chart present over here, and we'll work on multiple sheets, and finally we'll enter into the dashboard. So far so good. I hope you have understood the basic introduction to Tableau and basics of the Tableau fundamentals, how to use rows and columns, what are dimensions, what are measures, and what is show me, and how do you change colors of your bar charts over here, and you can highlight this. So we'll work on everything after we finish the installation process and get back to worksheets.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So before we go any further on Tableau installation, let us understand the Tableau products first. So there are multiple types of Tableau products. So here we will be having Tableau's desktop, Tableau public, Tableau server, Tableau online, and Tableau reader. So let us understand Tableau desktop first. Tableau desktop is a paid desktop application. It is also called as Tableau Desktop Professional Edition. This is where the developers create charts, formula, dashboards, actions, and everything. It has a 14-day trial too. The dashboards we create here can be published on any server listed above. The data can also be opened from Tableau Reader. Moving ahead, we shall understand the Tableau Desktop. So for beginners, let me tell you, Tableau Desktop is like open source data. Whatever the data or whatever the sheets, whatever the dashboards you work on using Tableau Public will be available for public. So keep this as your reminder. And it is not preferable if you want to use Tableau for your company's confidential data, because it might go public and it might be risky. So Tableau Public Desktop is a free desktop application. It is the developer place for Tableau Public Server. It is free and has to come with some limitations like cloud save only, no live or database connection. They are widely used by learners, bloggers, and public information related institutes like media, etc. Now moving ahead, we have the Tableau server. So Tableau server is a free server in the internet. This is the YouTube or Blogspot in Tableau data visualization world. It is free and people post their ideas and visualizations here. We call it the visual blog. It has no user management or folder management options. You can hide your work though. It cannot have live data source, but only extract. So many people publish their ideas and custom visualizations here. We could find the inspiration from here. Now next we have the Tableau Online. Tableau Online is a paid server application too, but it is already hosted by Tableau software and so no need to install it on any Windows server. It is better you need the Tableau dashboards to be accessed from anywhere. It has almost all the features of Tableau server but only on the internet, not on your local system. And finally we have the Tableau Reader. So Tableau Reader is a free desktop application which can help us to view the Tableau dashboards created by Tableau Desktop. It supports only extract connection files. It can help new people to try Tableau by getting one license for Tableau Desktop and installing this free software on their end user's machine. It can open the dashboards, interact with them like filtering, tooltip, and parameters. We cannot edit the formula or charts here. Now I hope we have some good understanding of Tableau, its introduction, and the various products of Tableau available for users. Now let's begin with the installation. So the third segment, Tableau installation into your local system. Now here we'll be trying the Windows operating system. Now to install Tableau into your local system, all you have to do is open Google and type in download Tableau Public. And you have the first option that reads download now Tableau Public. I would recommend for beginners to select Tableau Public because it is free. Now let's go back to Google once. Now on my screen we have opened Google. Just now type in download Tableau. So once you type in download Tableau, you can see various options. The first one though is Tableau Desktop, which is a paid version. As I said you have to select Tableau and it is free of cost, and you can try out your sample data over here for free. And once you select the Tableau Public option, you have this particular web page open. And if you go back to the presentation, you can see that I have written something called abc@gmail.com. This is basically your email address for getting registered and downloading the application. So you can write in your email over here, which can be anything like I have written abc@gmail.com. Just make sure that the mail ID you provide is an official one or it is an operational one, as you might have to confirm your download. Once you write in your mail ID, just select the download app option and you can see on the bottom left corner, the application will be getting downloaded. Now I have already downloaded the Tableau Public Desktop exe file into my local system, so I'll just cancel it for now. Now we are back on the presentation mode and we were in this particular stage where the Tableau Public Desktop.exe was getting downloaded. Once the file is downloaded, just run the file from your downloads part and you can see this particular screen on your Windows, which will greet you, welcome to Tableau. And here you might have to select I have read and accept all the terms of the license and just install. And there you go, the Tableau Public 2020.4 is installing into your local system, and that's how you install Tableau into your local system. Now we have entered into our next segment where we will be having the Tableau tour. So once you open your Tableau, your screen will be looking something like this. So this is the Tableau in my local system and you'll be having the screen which is similar to the presentation one. And here you have various options to connect to your data file, which might be an Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical file, or if you had to download some data directly from the server, you can even do that. So now we'll be working with the local data or the local Excel file in your local system. Just select that Excel file and open it. And there you go, you're on your first worksheet. Just select the Go to Worksheet option and you'll be having your screen redirected directly into the worksheet. And you have the dimensions and measures on your left corner, and you have the Show Me tab on your right corner, and some marks in here, and filters, pages, and various options on your toolbar. Now we have finished the introductory tour to our Tableau, and we'll understand more about all the options provided in this particular Tableau screen through our worksheets as we start with our first worksheet. So far we have understood what is business intelligence and the Tableau's role in improving your business. Followed by that we have understood what exactly Tableau is. Then we have understood how to install Tableau into your local system, and we had a brief introduction or brief tour on Tableau. Now we will move ahead and continue with making our own worksheets and the dashboards based on the worksheets we have worked with. So advancing into the fifth part, we will be working with the Tableau worksheets, and followed by the worksheets, we will be working on the sixth part, which is the dashboards. Now without further ado, let's get back to Tableau. So we have successfully booted up our Tableau and we are on the home screen of the Tableau. And on the left bar, you can see that we have various connect options to the Microsoft Excel, text file, JSON file, Microsoft Access, PDF file, spatial file, statistical file, etc. And if you had to connect to a server, this particular option is not provided in the public Tableau. It might be available in the server Tableau, and you can see that if you had to connect to the server just in case, then you're provided with various options here. Like you can connect with Google Sheets, OData, Web Data Connector, etc. etc. So today we'll be working with local data that is present in my local system that happens to be an Excel file. So you can see that in my downloads we have a set of Excel files. So we'll be selecting car sales updated data file. Now you can see that the data has been connected to the Tableau and the rows and columns have been presented on the screen. So before getting started with Tableau, let's have a quick update on the data. So many times it happens that you download a data from Google and sometimes one or the other rows or columns might have some incomplete data. As you can see, there is an incomplete cell over here, which is the curb weight of a particular vehicle that happens to be Cadillac Chevrolet. You can either try to remove this row or you can add some value over here. Like I'm going to add some value. I'm just going to drag this one because they both look a little bit similar. They have a same wheelbase and a kind of same width, so might be the curb weight might match. So we'll just drag it over here, or we'll just write it. Okay, I forgot to enable editing. Fine. So I'll just drag it here and I will have some values. Let's change it a little bit. Okay, so you can see that we have filled up the cell over here. Let's just check if anything else is incomplete. Yeah, there is another one incomplete over here. Let us just add some random values because this is just for practice. Yep, everything else seemed to be fine. So the important point or the update I wanted to give you guys is that when you save this, so when you get into a file and save as sales updated, so when you save it, make sure that you select the Excel workbook. If you don't select the Excel workbook, you might face some troubles while connecting the data to your Tableau. That was the important update I wanted to give you guys. So just select OK and your data has been saved now. And let's get back to Tableau. Now let's connect to the data again. By selecting the connect data option, you can see the dialog box come up on my screen. So you can just select Microsoft Excel and car sales updated. Open, and you can see the data got connected just now again, and you can see the rows and columns over here. So everything looks fine, and now let's get back to our sheet. So this is the sheet we'll be working on. We'll be creating multiple sheets. So we are creating multiple sheets because we have some options over here. You can see that, right? So this is the sheet, and this is the new sheet option, and this is the new dashboard option, and this is a storyteller option. So basically we'll be working on multiple sheets, and then we'll start a new dashboard, and we will drag all the sheets that we have worked on onto the dashboard so that we can have a view on all the sheets in one single screen. So basically that's what dashboard is. There are multiple operations on dashboard, like connecting to multiple dashboards together and applying some operations like filter, etc. on the dashboards. We will learn more advanced topics on dashboards in the advanced part, which is the next part 2 of the Tableau tutorial. So we'll have a basic understanding of Tableau functions in this particular part 1 right now. No worries on that. So you can see that we have options or the row names written in 2 different colors. You can see that the manufacturer, model, vehicle type, etc. are written in blue, and we can see that there is some sort of ABC text represented on the left side. And similarly on the other half, you can see the curve weight, engine size, fuel capacity, fuel efficiency, horsepower, length, price, etc. And you can see that there is an asterisk written just besides them. So why is this difference? Because Tableau automatically categorizes your data. So it will categorize the data into 2 forms, that is the dimensions and measures. So the dimensions happen to be the unique values of the data, and the values are the numerical values used in your data. So basically the curve weight is a numerical value, engine size is a numerical value, the price, resale values, width, wheelbase, car sales, etc. are the numerical values. And in the dimensions you have manufacturer, model, vehicle type. This happens to be the non-numerical values. So the manufacturer might be Audi, BMW, etc., etc. And the model would be some 320i from BMW, S-Class from... Imagine that you are in a college, and the name, address, and your percentage, etc., etc. are your values, and the percentage will be categorized into the numbers, which is the measures. And if you have a student ID which happens to be a number, that will not be in the measures, that will be in the dimensions. But why? Roll number happens to be a numerator, will be considered as a unique value, and Tableau automatically considers it as a dimension. If you want that to be in the measures, no problem in that. You can just drag it down into the measures and it will lie in the measures from dimensions. So that's about the left tabular column, where you can see the dimensions and the measures used in your data. And these are the filter options, these are the page options. This is a mark sheet where you can make some modifications onto your chart by making different colors, sizes of the charts, adding text to your results, and adding some details, adding some tooltip. Tooltip is basically something which explains you about the data which you're working with. We'll work on that. We'll see everything in detail, no worries on that. And now coming on to the right side, you can see the Show Me tab, which will help you with the various kinds of charts available that you can work with. So you have text tables, you have heat maps, you can have pie charts, you can have symbol maps, and just maps, pie chart, and side-by-side bar chart, stacked bar chart, horizontal bars, line graph, etc., etc. You can have scatter plots, you can have histogram, you can have box and whisker plots, and many more. Don't worry, we'll be working with various types of charts over here. And the best part of Tableau is that if you wanted to use a specific chart, then it will automatically help you with the kind of data you need for that. For example, if you wanted to go with text tables, you can see that it is providing you the prescriptions over here. So it needs one or more dimensions or one or more measures together on the rows and columns in order to use this kind of text table kind of chart to represent your data with. And if you wanted to go with a pie chart, it says you need to have one or more dimensions and one or two measures. That is a must. If you have these kind of data on your rows and columns, only then you can use a pie chart. So this actually helps you out in real time. And now let's get started with our data. Now let's try to identify which is the manufacturer with the highest pricing. Now when you double click on the sheet, you can actually edit it, or you can actually right click on that and just select the rename option, and you can rename it. Now let's select or just write in the highest pricing. Yeah, there you go. Highest pricing is the name of our sheet right now. And now let's grab the manufacturer and drop it down onto the columns. And now let's select the price from the measures and drop it down onto the rows. Yeah, there you go. You can see that we have the data output on our screen. So this particular bar chart helps us identify that Mercedes-Benz has the highest pricing amongst the other manufacturers. Now you can actually make some modifications onto this chart, like you can increase the size of the bars. It is automatically selected over here. You can just scroll it to the right and left by manually, and you can make some changes to the bars. And apart from that, you can even choose an option here which says the sort ascending by sum of price with manufacturer. Basically it sorts it out. So if you select this particular option, you can sort it from the least value to the highest value in the ascending order. And if you choose this one, it'll be arranged in the descending order, and you'll get to see the highest one on the left and the lowest one on the right. So this is how it works. And you can see that the first highest pricing manufacturer is the Mercedes-Benz, and the least manufacturing pricing is the Infiniti. And you can see the Beamer over here, the BMW. Personally, I'm a fan of BMW. Okay, now it's just looking, kind of plain without some any additional colors or without a vibrant way of representing your data. I think you know what I mean. So for that, you can just drag the manufacturer onto the color option, and voila, you can see different colors for different manufacturers. And this one basically tells you the highest manufacturer, or this color basically tells you the highest pricing manufacturer, that is the Mercedes-Benz. And yeah. And another option is the chart type. So basically when you chose the manufacturer and the sum of price, the Tableau automatically chose the bar chart. But you can change that. You can just select a line over here, and you can see the complete data has been represented in the form of a line, and you can even select density, and you can select area. So this is how you can change the way you can represent your data. So automatic was the best one over here. So basically the Tableau automatically chose the best way to represent your data, which happened to be the bar chart. You can even select the shape though, and you can make some changes to the shapes. So that's how it is. Now let's get back to automatic again, and it's got the bar chart again. Now let's try to create a new sheet, and this time we'll be working on the horsepower. So which manufacturer offers the highest horsepower? Yeah, so we are on the sheet 2 now. You can see that we have named it to highest horsepower. And yeah, when you come back to this one, you can see the name over here. You can even edit your table by just double clicking on the name, and you can reset some things over here. And that's how it is. And now when we come back to the horsepower, which is the second sheet, I think you remember, right? We are making multiple sheets just so that we can work on our dashboard. So now on the second sheet, we'll be taking up the model name. We are going to identify the car which is having the highest horsepower. Okay, those are a lot of cars. Now just select the sort option, and there you go. We have the Dodge Viper. Yeah, Dodge Viper happens to be a muscle car, and yeah, it should be having the highest horsepower in the manufacturing model, or what do you say it, the basic model without any modifications to it, extra modifications. So the production model of the Viper will be having a 450 brake horsepower. That's really huge. Now we can actually make some modifications. Since we have different manufacturers like Bema, Merck, and any other manufacturers, you can actually categorize the models over here. You just need to drag the manufacturer over here, and you can bring the manufacturer to the first position and then the model. Okay, another trick I would like to tell you guys is, if you wanted to switch the manufacturer with the model, then all you have to do is just drag the model and place it on the manufacturer. This will automatically switch them. Okay, I didn't place it correctly, I hope. So when you do it, it will actually switch it. Yeah, that's how it's done. So we're going to categorize this models based on the manufacturer now. Let's bring back our manufacturer. Now let's drag it to the second place. And now we have the manufacturer first. So you can see that the data got automatically categorized based on the manufacturer. You can see we have Acura, which happens to be the American version of Honda. So we have Integra, RL, TL, what happens to be the car or model names. So these are the cars offered from Acura with the horsepower 255, or no, it's 225 and 210 and 140. So this is actually the tooltip which is giving you the data according to that bar chart. And now we have the Dodge Viper here with the highest horsepower in the production model. You know, the Dodge and the Ford are known for their muscle cars with highest horsepower. And here we have the Merck and Mitsubishi, Nissan, and some other Plymouth, Porsche, etc., etc. Now we'll go ahead and create our next worksheet. So let's name it the fuel efficiency. Now let's select the manufacturer and the fuel efficiency on the rows. Now let's select a different type of chart over here. I think you remember the color option. And if you close the show me option, and then you can see the manufacturer over here. Now you can just make some changes for it. You can actually select a manufacturer, and you can either keep only or you can remove it. So in Tableau you have the Control Z option, which will undo the changes you have done. You can actually exclude if you want someone to be excluded from the list. So I've excluded Buick. So this was the one we excluded. So that's how you can do it. So when you press on the tool tip, you can see that we'll be having the manufacturer, and followed by manufacturer we'll be having the fuel efficiency provided by that manufacturer. So you can see that we have the good fuel efficiency from Chevrolet and the considerable efficiency from Jaguar. So basically Jaguars are the luxury cars which provide you the maximum comfort and maximum drive feel, so it will actually consume a lot of fuel. Now let's get back and create another sheet, and let's name it as highest resale. Now let's select the highest resale value and model. Now let's arrange it. So according to that, Carrera Cabrio has the highest resale value. That's good. Let's drag the color. There you go. Let's add the manufacturer here so that we can have a good idea of which manufacturer has the highest resale value. So Mercedes has the highest resale value, and also we have the model names over here. We can remove model from marks. This is the reason why we have multiple cars from single manufacturer. So we have all the cars from a single manufacturer. If we remove this model from the marks sheet, you can just see the manufacturer here. Now actually we can make some changes to the sizes. We have the size option in our mark sheet, right? So you can just drag and drop the manufacturer on the size, and then you have various sizes for the various options. And when you come to the rows, you can see that we have the sum of resale values. Basically you can make some changes to it. You can just select measure, and inside measure you have various options of providing average, median, count, minimum, maximum. So let's go with maximum. And now let's try to drag the manufacturer again onto the size, and this time you have the different sizes. So you have Porsche over here, Mercedes-Benz over here. So this is how the categorization takes place. Now let's create a new sheet and understand the filter option. Now just let's name it as filter. And now let's drag the manufacturer. So we have the manufacturer in our columns, and now we discussed that the highest pricing is from Mercedes, right? So if we wanted to find the next leading one, actually you can see it on the screen, but just imagine that we have a lot of options rather than the few options which are available on the screen. Then what if you wanted to find the second leading highest pricing car? So in that case you can just make some filters onto it, right? You can add or remove options using filter. So I would like to drag the manufacturer into filter and select all from the list, OK, and apply. Now you can just select the filter, right click it and edit filter, and you can see all the options over here. Just select OK. Now let's right click the manufacturer and select the show filter option so that you can have a filter bar on the right side. So now you can actually remove some options by selecting them. If you just click on the Mercedes-Benz, you can actually see the Mercedes-Benz got removed from the list. So you can see after the Mercedes-Benz, the highest pricing is from Dodge and Lexus. So this is how you can use filters. Let's bring back Mercedes-Benz again. Yeah, there you go. So far we have dealt with the bar charts and the overlapping bar charts, or what do you call it? This is the stacked bars, yeah, I forgot. And line graphs. Now we'll deal with the scatter plots and pie charts now. Yeah. So for that, let's create a new worksheet. Let's name it as scatterplot. There you go. Okay, spelling mistake. So when you had to use the scatterplot, the special thing about scatterplot is you need to select both the axes, that is row and column. And when you're selecting the values for rows and columns, you need to select the values from this particular segment, which happens to be the measures. So you'll not be selecting anything from the dimensions. So for now, let's select the engine size for columns and horsepower for rows. So we've selected the engine size for columns and horsepower for rows. So once you have selected the data, you can see a dot over here, which happens to be the engine size for 70 and horsepower 28,000 for 28. This is some random value. Now let's dig a bit more detail into this scatterplot. Now to know the exact details of all the models and all the engine size and horsepower, let's drag the model name into the detail. Now you have some good, a more representable or the more readable form of data. So you can see that we have the highest horsepower engine, that is Dodge Viper, and the engine size is 8 liters and the horsepower offered is 450. Now if you have dragged the manufacturer into the details, then you can see that we have the manufacturer name as well. So the Viper belongs to Dodge, and if you kind of select the manufacturer into shape, then we can actually have different shapes for different manufacturers. So you have the shape option over here. So you can see that we have various shapes for various makers. For example, we have the plus symbol for BMW. So if you can just select keep only BMW, then we have two cars from BMW, which happens to be the model 320i, and the engine size is around 2.8 liters and the horsepower is 193 brake horsepower. And another car we have from BMW is the 323i with the engine size 2.5 and the horsepower 170. Now if you want to bring back all the cars, the simple step is just press Ctrl Z and you have all the cars back in here. And if you want to highlight a specific car, then select the highlighting option. And then let's select Dodge. You can see the Dodge cars got highlighted over here. So just select Dodge Viper, and then we have Dodge Durango. I don't know how to spell that. I'm sorry if it's wrong. And then Dodge Ram Van, and we have the Dodge Intrepid over here. So if we hover onto the highlighted parts, we have the Dodge over there. So that's how you highlight it. Now we have worked on the scatter plot. Now let's create a new sheet and let's work on the pie chart now. I'm just writing pie and that's done. So for a pie chart, you need to select an option and hold Control and select another option together, and then we can do a pie chart. So for that, let's follow the steps. Open Show Me, select pie chart. Okay, I forgot to say, actually we need to select the dimensions first. So let's select something from dimensions. Okay, let's select manufacturer and hold Control, and let's select some value from the measures. So let's select sales. So now open show me, and there you go, you have the tab. So I'm in the pie chart in the tab. So we have the pie chart over here. Now I think we can increase the size of the pie chart. So you can just drag it manually, and you can see that the pie chart size is getting increased. So here we have the manufacturer, and it has the sales. Ford has the highest sales, and followed by Ford we have Dodge, and then we have Honda and Chevrolet, Toyota. So far we have understood the types of charts you can make, the types of options that are color, size, label, detail, tooltip, etc, etc, and filters, and the show me tab, etc, etc. Now we will move ahead and try to understand hierarchy in Tableau. So let's kind of make a new sheet. Let's rename it as hierarchy. Now we know that the model and manufacturer can be considered as an hierarchy because a model comes under manufacturer. So we can use these two from dimensions and use them as hierarchies. Now let's try to drag model onto manufacturer, and this should automatically show me a dialog box on my screen. Now let's rename it as manufacturer model hierarchy, or just let it be as H so that it's a bit more readable. Now you can see that we have the manufacturer model H hierarchy, and inside that we have the manufacturer and model. Now we can drag the manufacturer model hierarchy onto columns, and we can drag the car sales into rows, and we have the hierarchy values over here. Let's rearrange them. And now if you press the plus option, it's really minor. I don't know how to expand the screen. Let's try Control plus or Shift plus. It's not working. So I think you can see the minute plus option over here. Now let's try to press that plus option, and there you go. You have these sales according to the manufacturer and the models, and that too in hierarchy. Let's remove the car sales and try to put in the horsepower over there. Yeah, you can see the horsepower of each and every car, which is categorized according to the manufacturer. So in Ford we have various types of cars available, and similarly in Toyota, Mercedes-Benz, Chevrolet, Mitsubishi, etc, etc. So that's how the hierarchy works. Now I hope we had a sound understanding of how to create various types of charts, and we have the filter option, scatter plot, pie chart, hierarchy, everything discussed so far. I think you have a brief idea how to work with Tableau. Now let's go through an example of dashboards. Now let's rename this dashboard as car dashboard. Now dashboard is no rocket science. The only thing you do is just select the charts you've worked on and drag them onto your dashboard. That's all. Now let's select the scatter plot and drag it onto the chart. And now let's try to drag the horsepower. And now the fuel efficiency. So you can see the horsepower and fuel efficiency and the highest number of sales and the horsepower compared to engine size all together on one dashboard. So you can see the dashboard name over here, which is a car dashboard. Now you can have some options over here, like you can download the dashboard image and much more. You can even make multiple dashboards just like we made the worksheets, and then you can interconnect the dashboards and you can work multiple operations on multiple dashboards. I hope you had a good understanding of Tableau in Tableau tutorial for beginners. And now let's get back to the presentation. So now we'll discuss the company's hiring and salaries. So there are a lot of companies looking for Tableau experts, and some of the MNC companies which are looking for Tableau experts are Accenture, EY, PepsiCo, Deloitte, Capgemini, and Wells Fargo. Now let's also discuss the salary for Tableau experts. So the salary for Tableau experts in the United States of America is $81,514 per annum. Now that's an average salary, and these stats are from the Glassdoor. And the highest salary is anything around 110 to 120,000 US dollars per annum. Now let's discuss the average salary of a Tableau expert in India. So the average salary of a Tableau expert in India is anything around 5,06,000 per annum, and the highest salary is anything around 8 lakhs to 10 lakhs per annum. That's for a good experienced employee like 2 to 3 years. And you can also earn more than that. Now these stats are from the Glassdoor website.
Hi everyone, welcome to Simplilearn. Today we will learn how to become a data analyst. The demand for data analysts continues to rise across all industries. It's a field that blends creativity with logic, allowing individuals to uncover meaningful insights from raw data. For learners, it provides the perfect platform to combine technical skills like programming and visualization with problem solving and business acumen. To become a data analyst, start by learning foundational tools like Excel, SQL, and Python for data manipulation. Focus on statistics and visualization tools like Power BI, Tableau to present insights effectively. Hands-on projects and internships are critical to solidify your understanding and showcase your skills. So this was a brief overview of the roadmap to becoming a data analyst. Now, let's dig deeper and extract the best targets that you need to set to become one. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Just for a quick info, if you want to upskill yourself, master data science and data analytics skills to land your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers various certification and postgraduate programs in collaboration with some of the world's leading universities like Caltech, Purdue, IIT Kanpur, and many more. For our courses, you will gain knowledge and work-ready expertise in skills like advanced Excel, Python, machine learning, data visualization, generative AI, and over a dozen others. That's not all. You also get the opportunity to work on multiple projects and learn from industry experts from top companies and academics from top universities. After completing these courses, thousands of learners have transitioned into a data science and data analytics role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a data science and data analytics program that fits your experience and areas of interest. Now, let me also tell you that there's a simple quiz linked in the description box below. Solve it and let us know your answers in the comment section. Now, without further delay, let's get started. If you categorize the steps to become a data analyst, these are the ones. Firstly, you need to focus on skills. Followed by that, you need to have a proper qualification. Then, test your skills by creating a personal project, an individual project. Followed by that, you must focus on building your own portfolio to describe your caliber to your recruiters. And then target to the entry-level jobs or internships to get exposure to the real-world data problems. So these are the 5 important steps. Now, let's begin with the step 1, that is skills. So, skills are basically categorized into 6 steps: data cleaning, data analysis, data visualization, problem solving, soft skills, and domain knowledge. So these are the tools: Excel, MySQL, R programming language, Python programming language, some data visualization tools like Tableau, Power BI, and next comes the problem solving. So these are basically the soft skill parts. Problem solving skills, domain knowledge, the domain in which you're working, maybe a pharma domain, maybe a banking sector, maybe automobile domain, etc. And lastly, you need to be a good team player so that you can actively work along with the team and solve the problem collaboratively. Now, let's move ahead and discuss each and every one of these in a bit more detail. Starting with Microsoft Excel. While advanced tools are prevalent, proficiency in Excel remains vital for data analysts. Excel versatility in data manipulation, visualization, and modeling is unmatched. It serves as a foundational tool for initial data exploration and basic analysis. Data management. Database management skill is indispensable for data analysts. As data volumes soar, efficient management and retrieval from databases is critical. Proficiency in database systems and querying languages like SQL ensures analysts can access and manipulate data seamlessly. Followed by that, we have statistical analysis. Statistical analysis allow analysts to uncover hidden trends, patterns, and correlationships within data, facilitating evidence-based decision making. It empowers analysts to identify the significance of findings, validate hypotheses, and make reliable predictions. Next, after that, we have programming languages. Proficiency in programming languages like Python is essential for data analysts. These languages enable data manipulation, advanced statistical analysis, and machine learning implementations. Next comes data storytelling, or also known as data visualizations. Data storytelling skill is paramount for data analysts. Data storytelling bridges the gap between data analysis and actionable insights, ensuring that the value of data is fully realized in a world where data-driven communication is central to business success. Data visualization skill is a cornerstone for data analysts. As data complexity grows, the ability to present insights clearly and persuasively is paramount. Next is managing your customers and problem solving. Managing all your customers' data and companies' relationships is paramount. Strong problem solving skills are important for data analysts with complex data challenges and evolving analytical methodologies. Analysts must excel in identifying issues, formulating hypotheses, and devising innovative solutions. In addition to the technical skills, data analysts in 2025 will require strong soft skills to excel in their roles. Here are the top ones. Data analysts must effectively communicate their findings to both technical and non-technical stakeholders. This includes presenting complex data in a clear and understandable manner. Next soft skill is teamwork and collaboration. Data analysts often work with multidisciplinary teams alongside data scientists, data engineers, business professionals. Collaborative skills are essential for sharing insights, brainstorming solutions, and working cohesively towards common goals. And last but not least, domain knowledge. Knowledge on domain in which you're currently working is really important. It might be a pharmaceutical domain, it can be an automobile domain, it can be banking sector, and much more. Unless you have a basic foundational domain knowledge, you cannot continue in that domain with accurate results. Now, the next step, which was about the qualification to become a data analyst. Master's courses, online courses, and boot camps provide strong, structured learning that helps you gain in-depth knowledge and specialized skills in data analysis. Master's programs offer comprehensive, academically rigorous training and often include research projects, making sure you're highly competitive in the job market. Online courses allow flexibility to learn at your own pace while covering essential topics, and boot camps offer immersive, hands-on training in a short period focusing on practical skills. All three paths enhance your credibility, keeping you updated on industry trends and make you more attractive to potential employers. If you are looking for a well-curated all-rounder, then we have got you covered. Simplilearn offers a wide range of courses on data science and data analytics, starting from master's, professional certifications, to post-graduations and boot camps from globally reputed and recognized universities. For more details, check out the links in the description box below and comment section. Now, proceeding ahead, we have the projects for data analyst. Data analyst projects demonstrate practical skills in data cleaning, visualization, and analysis. They help build a portfolio showcasing your expertise and problem-solving abilities. Projects provide hands-on experience bridging the gap between theory and real-world application. They show domain knowledge, making you more appealing to employees in specific industries. Projects enhance your confidence and prepare you to discuss real-world challenges in interviews. Proceeding ahead, the next step is about the portfolio for data analysts. A portfolio is a testament that demonstrates your skill and expertise through real world projects, showcasing your ability to analyze and interpret data effectively. It provides tangible proof of your capabilities, making you stand out to the employers. Additionally, it highlights your domain knowledge and problem solving skills, giving you a competitive edge during job applications and interviews. Last but not the least, data analyst internships. Internships provide hands-on experience with real-world datasets, tools, and workflows, bridging the gap between theory knowledge and practical application. They offer exposure to industry practices, helping you understand how data is used to drive decisions. Internships also build your professional network, enhance your resume, and improve chances of securing a full-time data analyst role. Today, we will learn data analytics with AI. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Let's get started with the main topic of today's session, which is data analytics with AI. So, before proceeding with data analytics with AI, let's understand what exactly is data analytics. So, data analytics is not just a step where you just give your data to AI and it will be done, right? So, it's a stage by stage process. Let's understand all the stages one after the other. Firstly, you might have different sources. So before we go ahead with the sources, let's understand the situation. You might be dealing with your client. You might be working with the company as a data analyst. So before you begin with the data analysis, you might have to have a conversation with your client or the company. You might have to go through something called as requirement gathering, right? So requirement gathering will let you know from where exactly you're getting the data. Is it in the form of a PDF? Is it in the form of an Excel spreadsheet? Or is it going to be cloud or anything like that, right? So you'll be understanding what's the source exactly is. And followed by that, you will understand what is the request of your client, what he's looking for, what he wants you to give him, right? The insights of the data, which part of the business he wants you to focus on, and which part of the business he wants to improve, right? And followed by that, you will come up with a time span. Within that time span, you need to use that data, build some insights, and give it to the client or your business owner so that he comes up with a business decision, right? So that's the first requirement gathering step. Once you have the source, you come up with the next step of the data analytics, which is cleaning the data and transforming the data. So it's really obvious for any beginner or an expert who is a data analyst. It is cleaning and transformation what makes or what adds value to your data. Once you clean your data and transform it. So what exactly you mean by clean and transform? So let's say you might have some blank entries or might be some wrong data type, or there might be some places where you might have to split the data. For example, if there is a customer and customer ID mixed up together, let's say customer ID 1345 hyphen the name of the customer, right? You wanted to split the customer ID and split the customer name. Then comes the data split option. Apart from that, if you want to categorize the data into buckets, let's say you might have a column for customer age. There might be customers starting from 10 and all the way end up to 80, right? In those scenarios, you might want to split the data into buckets. Let's say 10 to 20 are teenagers and above 20 to 30 are youth and above 30 to under 50 are, or under 60, like let's say like 59 are adults, and after that maybe senior citizens, right? Then you have a smaller window so that you can capture which category of the age group is bringing you the most of the revenue, right? So these are the parts of cleaning the data and transforming the data. And once you're comfortable with it, then you can choose a platform where you want to analyze your data. which can be Tableau, which can be Power BI, ClickView, or Excel, or any of the tools that you might want to prefer. In our scenario, we want to go with AI, right? So AI can be anything. You can go with the Microsoft's Copilot. You can go with the OpenAI's ChatGPT. You can go with Google's Gemini, or any of the AIs which can perform data analytics. There are some AI tools out there which are dedicated for AI data analytics, right? And once you're done with it, and the final stage is analyzing the outcomes and reporting that to your business owner or client. So I hope I made myself clear with these stages of data analytics and reporting. Now let's look at an example to explain this a little better. So I have the dataset in Excel for now. This is our source, the first part of data analytics. Let's expand the columns. So there you go. I said something about data type. So here you can see we have some different data type which we don't want, which is in general. So we will change this data type to short date to make a little more meaning out of it. And after that, here we have customer ID, right? So what we will do is use data split here. Go to text to columns, delimited. Next. So we have other. So here's the preview. So you will be receiving it in this form. And if you want to format the data as you like, you can go ahead. So I'll leave it as general for now and finalize the data type after the split is finished. So what you can do is add a column, new column here, so that you can get an empty column here to split the data. Go to text to columns once again, select delimited, select next, and we have the input other, next, and finish. There you go. You have customer ID and you have customer name, the respective customer name here itself. So proceeding ahead, we have quantity, the quantity of product ordered, and we have traffics, leads, orders, and revenue, right? Cost to company and delivery status. So in case if you wanted to kind of calculate profit, what you can do is add a new column, profit, and here you can do a mathematical calculation equals to revenue minus cost to company. And you can extend this particular column all the way to the end so that you have the profit numbers. And here you can also change the data type to currency and go to home. And here the data type from general to currency. And there you go. And if you want it in rupees, you can go with rupees. Or if you want it in dollar, you can also have dollars. Right? So that's how you do it. I would like to go with dollars. So more. And here go to currency. And in currency symbol, I'll go with the dollar. Then okay. There you go. You can quickly save it. If you want to add some borders to the data, you can also do that. There you go. So far, so good. So we are now good data. Now comes the next step, which is loading the data and analyzing it, right? So currently we choose the platform as Excel. So you can do this on Excel, Power BI, and ChatGPT as well. So let's go with the first one, which is Excel's AI. So here you can see analyze data, or also people call it the co-pilot of Excel, right? Now you can just click all the data and click on analyze. Basically what you can do is insert and go to the pivot table option, and here you can insert a pivot table, and after that you can find out the requirements what you want, the sales from the central region, south region, and which category of the products have been sold the highest, and what's the highest grossing product, what are the number of leads, and you can estimate the performance of traffic on a month-on-month basis, right? You can do that all, but if you want to reduce the time, basically I would like to tell you, go to that particular part first. Understand manual process, and after that go to the analyze data option, which is the automated or AI generated report, right? It will now read your data and it will give you some insights from the data given. Right here you can see the cost to company by order status, and here you can see you can set up a pivot table for that, and here you can see you can insert some graphs and charts here, bar graph, and here you have another one. Now you can see that it has all 24 results, all the insights. Now if I can ask, give me a pie chart of sales and category. Here you go. Here you have so basically what Copilot did is it created a pivot table of sales and category, and out of that pivot table it extracted the pie chart and generated one for you. In this way you can create multiple options. Let's say I want to create a line graph month on month. Enter. Now here it again created a pivot table, and here it generated a line graph on month basis and how many number of traffic or how many number of visitors your website had. And in this way you can create a long list of all the required charts and graphs for your website and or the client, and create a dashboard out of it, which is completely interactive. Now this was the Excel's AI. Now if we go to another one, which is Power BI, so here you can see a completely prepared dashboard in Power BI, and we can create this once again, or you can at least understand how it was done, right? Now let's get the data from Excel workbook. So my workbook or my data set is somewhere here, sales data. I would like to go with orders data. Only one file is enough for 2024, and your data will be shortly loaded. Select spreadsheet 1 and load the data. Since we already transformed it, there is no need for transforming it once again. So the data is being loaded successfully. It's going to take some time. 2000 rows loaded. Sheet 1. So we are going to work with sheet 1. Now you can select the visualization you want. Like I want to create a line graph here. Repeat. Like I want to create a line graph here. Select. And for this particular line graph, you will have fields, x-axis and y-axis. Now what I'll do is I'll drag and drop date to x-axis field, and traffic to y-axis field. Now here in x-axis, I would eliminate year, I would eliminate quarter, I would eliminate date. I just want month on month, right? Here you have a clear month-on-month traffic line graph. Right now, let's quickly delete it. We don't want this now. And remove it. Now, what if I tell you there is an option where you can just double click and or right click, and you will get an option. Here you can query, right? You can just write down the query, line graph, type of graph you require, traffic, write the spellings correctly, month on month. And enter, you will get the graph you are looking for. There you go. Right? So apart from this, let's put the month-on-month graph here. Apart from this, let's double click once again and category by sales. Category sale, pie chart. There you go. And now, region-wise, double-click once again. Region-wise sales bar graph. Select the first one, and there you go. I think there is a small mistake in the selection, spelling. Select the first one once again, and there you go. You will have a bar graph in region-wise basis. Or we can also go with similarly, we can also go with a map chart for states and revenue. Select the first option, and you will have all the American states and their revenue details here. Right? So in such way, you can use the artificial intelligence of Power BI and create a completely interactive graph just like this one. So if I select the standard shipment mode, what are the sales reports? And if I select the entire shipment modes, what are the reports? And if I select the home category, what are the sales reports and which part of the nation and and what are the sales and order per month, traffic and everything details here, right? In one go. It is completely interactive. Now, let's move on to the next part of our session for today. So we will be using ChatGPT for our data analytics. So here you go. Now, let's load the data. Before that, let's write a prompt. Some data on sales or sales report visualization. And now load the data. Upload from computer, and we have the sales data here, the orders data. Select the orders data file and open. The data will be loaded shortly, and since it's loaded, you can just push the command or prompt. It'll first review the contents and understand what exactly is present in your content and the data type, along with the data type, right? It has 2000 entries, 17 columns. Here's the brief overview of all the columns. So it's asking you, would you like an overall summary or a specific aspect? So let's go with the specific aspect instead of overall summary. I want region-wise sales as a bar graph. Okay, we didn't have a column as bar sales. It's in turn taking revenue. Yes, there you go. Sales revenue by region as a bar graph. Now, pie chart for category revenue. Okay, so there is some limit for analysis. Okay, that's not a problem. We can change the account and try to do it once again, or I should have chosen the overall summary, right? But if you go to the ChatGPT Plus edition, you can get that. Let's try the Plus edition once. So we are on the Plus edition now. So it generated some visualizations, which is completely downloadable here. You can go with that as well. So the prompt is still running. Let's wait for a couple of more minutes and see what exactly ChatGPT is up to. So here we have a profit by category, which was our second request, which did not get successfully authorized because we didn't have a +1. So now we can see revenue versus cost to company in top 10 products. So which are the top 10 products which are giving the maximum revenue? And here is a detailed report. And if you would like to continue with a few more reports like we did before in Power BI and Excel, like traffic versus month on month,
is a line graph. Let's try that. There you go. So we have a line graph of traffic on a month-on-month basis. So that's how you can conduct some data analytics using different AIs on different platforms. So there are many number of platforms: Tableau, Power BI, ClickView, Excel, SQL, ChatGPT, Gemini, and a few more dedicated artificial intelligence tools which are for AI data analytics. And that brings us to the next part of data analytics with AI. So how does data analytics and AI work? So first, basically, once you load the data, AI will start preparing and processing your data, right? So the transformations, what you do, are also can be possible in AI as well. If you request AI to do the transformations, it can do itself. But I would recommend you perform the transformations because you know what are the exact requirements are. Once your data is completely transformed, you can load it and get the reports. The next part of it is pattern recognition. As you've already seen, ChatGPT recognizes each and every aspect of the data, from the data type to the minute details like currency and everything. It understands the data first, and then it will request you. It will ask you if you want a complete summary or if you are looking for a particular aspect, right? Machine learning algorithms can identify patterns, trends, and relationships that may not be apparent to human analysts. And there is a possibility that ChatGPT can even identify a few more insights that you never expected to have, right? And moving on to the next part, predictive analytics. AI can also perform some predictive analytics and give you the forecast of what exactly is going to happen in the upcoming future in your business. That may or may not happen. If you find something is about to go down, you can prevent it by taking some predictive steps or measurable steps which can avoid that loss, right? And automated insights and reports. You can also request ChatGPT, right? In Excel, there is something called as Power Query. It acts like a macro or Excel VBA where it stores each and every transformation step you apply. In a similar way, each and every transformation or step that you apply to modify or try to add value to your data and teach that to your AI so that it can also understand that particular automated transformation steps and report to you on a month-on-month basis, right? So this will stop your month-on-month activity of cleaning your data, transforming your data, loading your data, analyzing, extracting some insights, and then creating a strategy. So all these steps will be eliminated because ChatGPT or any other AI will take care of it, and you can focus on implementing some business strategies. And we have decision making. So AI can also help you with some critical business strategies and also help you in decision making. AI algorithms can optimize complex processes and decision making by evaluating multiple variables and multiple scenarios. Now, last but not least, continuous learning. So AI is capable to adapt and learn new things in your business, like how it processes, how it functions, and what's the data source, and most of the aspects in which are involved in business and data analytics. AI systems have the ability to continuously learn and adapt based on the new data and feedback.
Hello and welcome. Welcome to Data Analytics with R from Simplilearn. So, are you excited to begin with today's session? Yes, you are? Okay, great. I'm excited as well to be a part of this session. What are we going to cover in today's session? We will cover a couple of topics. We will begin with understanding the basics. We will focus on why data analytics and the importance of data analytics. And then, what is data analytics? We will also focus on understanding the life cycle of data analytics. And I'll also try to give you some real-time examples so that we can relate these concepts with the real-time examples or scenarios. And then we will understand the types of analytics and what do they mean. We will also focus on the benefits of using R. For this session, we will be using R Studio tool. Hence, we have to understand why we use R. for data analysis. And finally, we will perform some hands-on exercise. In today's session, we will only focus on how to import the data, how to structure the data, and also how to create some beautiful visualizations by using RStudio. Alright?
Python and R are top programming languages that are in demand in data science community. Both have their own pros and cons. Therefore, it is vital that you understand the crucial differences between the two programming languages and decide which one is the best fit for you. After watching this video, you will understand which language is better for you in terms of different parameters. Before unwrapping today's topic, I request you to subscribe to our channel and press the bell icon to never miss any updates from Simplilearn. And also get notified every time you get a similar video. Now let us look at what are we covering today. We are covering Introduction to R and Python, parameters in R and Python, best tools and libraries offered by Python and R, and conclusion to the topic. Introduction to R and Python. Let me ask few queries regarding Python and R. R language is superficially related to Python, C, C++, Java. Please leave your answer in the comment section below and stay tuned to get the answer. And another question is, which one of the following is a Python file extension? .p, .python, .py, and .pyt. Please leave your answer in the comment section below. Coming to Introduction to Python and R. R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows, and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode, and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, our language is significantly slower. Our packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial, and Python has some incredible visualization tools. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community-related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. A recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic, which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language. Next question was, which one of the following is a Python file extension? It was an easy question. Answer for that question is .py.
So, firstly, let us understand why data analytics. Can somebody here tell me why data analytics and why is it used in organizations? So, let us understand why data analytics and what is the use of data analytics. As we all know that data is growing exponentially year over year. It is collected and it is also available everywhere. Data is no more just available in structured format, but it is also available in semi-structured and unstructured format. I'm sure you would have come across this term called as sentiment analysis pretty often, right? What does that mean? Can we perform that in data analytics? Yes, right? We use some natural language processing models, try to identify what are the good reviews, what are the bad reviews spoken by the customer, correct? So we try to classify the text based on the good, bad, and the neutral. So that is what sentiment analysis is about. So for that, to perform that activity, we have to also do some data analytics. Now that companies have realized the importance of these informations, not just structured but also unstructured data format, the companies have started utilizing these data to take some crucial business decisions which can boost their business and also which can increase the efficiency of the business. So now that the raw data is accessible to the organizations, it becomes very important that the data is also stored well. I'm sure you all have pretty much heard about data warehouse. In the last few decades, the trend was mostly on the data warehouses, the business intelligence tools. So the data warehouse used to collect this data, pre-process the data, and also filter the data and make it available in a structured format for further analysis. However, now that is not the scenario. A term coined as data lake is available, and many firms are utilizing data lake because it is a central repository which stores the raw data in form of structured and unstructured data. And now let us take a scenario. Let us choose one of the participants here, Mark. So Mark has recently joined an organization as a data analyst, or in essence a data scientist. The business connects with him and says that, Mark, we have a business problem for you and we expect you to provide us a data analytics solution. So Mark sits with the stakeholders and he listens very carefully to the business question. So the business question says that we have a couple of products which are performing really well in the market and we see higher sales. And some of the products are just not catching up in the market and we experience lower sales. Can you help us identify what are the factors driving these higher sales and the lower sales? Now, Mark has to think with the data scientist mindset and be prepared to ask them right questions. Some questions such as, do you have the price of all these products available in the database? And can I also know what is the duration of data availability? And also, Mark can ask some questions such as, do you also have some features of these individual products already captured in your database? So these are some of the interesting questions that makes sense to the business, and the conversation continues, which also means that data is not only information. Data analysis is about unlocking insightful information from this raw data. And hence, data analysis plays an important role in discovering insightful information, asking questions or answering the right questions, and also predicting the future or the unknowns. And to perform all these activities, we use data analytics. So are you all with me so far? Are we on the same page? Yes? Great. Now the question is, what is data analytics? So can somebody tell me what is data analytics? So let us see what is data analytics. We understood why data analytics and the importance of it. But to perform any activities, there has to be a process, right? So data analytics is a process to extract meaningful insights from data. Now let us continue with the scenario of Mark. So Mark now understands the business problem, and he has also started asking some relevant questions to the stakeholders, and he has also got the answers in return. He may start thinking about what could be the suitable solution for this. He may have to perform some exploratory data analysis to unlock some hidden patterns, to identify some correlation between the variables, and to also know which are the key variables in the data set. And he may also have to view the market trend, which means he may have to see that how the sales has been performing across the years or across the months. There might be some insightful information there. He may see that the sales has been growing exponentially for some of the products, and some may be volatile, some may have some seasonality pattern or a cyclical pattern, etc. And also he may have to focus on the customer preferences via the customer reviews and do some sentiment analysis. So now let us understand what are those life cycles of data analytics. We will begin with the discovery phase. This is the first phase. Now that Mark has understood the business problem, he will also start focusing on identifying the resources, that is the data resources. Some may be internal data resources that is available within the firm, could be some transactional data, and some external data sources may be via web scraping, identifying and capturing some competitor price on the products. After gathering all of these right data, Mark will focus on data preparation, which is the next phase. Now Mark, either individually or along with the team, will start focusing on the data preparation, which includes data wrangling, which means cleansing the data, imputing the records if there are any missing values, or he may also go ahead by removing those records if they are not required, and also doing some exploratory data analysis, which can include some statistical analysis like looking at the data distributions, understanding the summary of this data distribution at individual variable level, doing some bivariate analysis, and also trying to figure out which are the important variables that might be required for the model building phase. After performing all of these EDA activities, which also include some visualization, Mark will now sit with his team and try to identify the suitable models. The suitable models could be simple statistical techniques, or it can also be some machine learning models. So let's say that Mark and his team has identified some 5 models that can provide the required result. And out of these 5 models, they will filter down and they will prioritize only 3 models. Now there are only 3 models that Mark and his team have finalized. After this, they start focusing on model building activity. Now for model building activity, they have a data set already in place. So this data set will be split into training data set and test data set. It's not only training and test, we can also do some validation in between training and test. But here let's focus on training and test data set. He will separate 75% of the data as training and 25% of the data as test. Now if your question is that why perform this activity of splitting the training data set and test, can't we just go with the one single data set? What happens if you just utilize one single data set? Let us say that you have used the original data set and also executed this data in one of the selected model, and you will also observe the accuracy. Let's say the accuracy returned is about 98%. 98% is a very good accuracy percentage. And you may also be overconfident because of this. That may be a case due to overfitting. Now what will happen when you add some new records into this data set and you rerun it? The executed model may not return you the same accuracy what you had seen. The accuracy might be 72%. Now that's not fair, right? To avoid these overfitting issues, we ensure that some new records are tested separately. So hence we locate 25% of the data to the test data set. And then we predict those records, the unknown records which is located in the test data set. We predict them and then we test the accuracy of training data set and the test data set and we make a comparison. Now let us say the accuracy result of training is 98% and the test is 97%. In this case we can say that the model is performing really well. However, while executing the model, there are certain things that has to be considered. For example, inclusion of the parameters, tuning the parameter, which also will execute the optimal results. So this is very important. Now let's say after performing this model building, the time comes to analyze the results. That is the next phase. Now the team will sit and analyze the result, and they will notice that out of the 3 filtered models, only 2 models are returning excellent accuracies. They will sit with the business team and they will also explain them the result and what are the activities that they have performed to obtain this result. Some of the stakeholders may be technically savvy, some of them may be non-technical people. So it has to be very important that you also communicate these results accordingly. Alright, now that you have the results, you will also gauge them based on the business objective, which was developed in phase 1. Looking at the results of the 2 models, now the business might select one of the model and say that, okay, this particular model seems to be returning some right information and it also appears valid to us. Let's go ahead with this one model. So finally, the result and the model needs to be operationalized. And that is where the team will start documenting the business problems, the steps that were taken for executing the models, and they will include all the codes and the findings. And finally, they will implement this model so that the business can view the results and also utilize them for strategic decision making at your firm. So are we good so far? with the understanding of the life cycle? Alright, great. Now let us focus on the types of analytics. What are the types of analytics? Can somebody tell me which are the types of analytics you are aware of? Okay, predictive analytics, great. Descriptive analytics, good. Alright, good enough. Now let us focus on this example of Google Maps. So as we look at this particular Google map, we understand that the blue color route is nothing but the route direction from Sacramento to Florin. And also we see a display of the duration estimated as well the distance to travel from Sacramento to Florin. As well we see another route here that is gray colored. This is a substitute route or the connecting route just to avoid the traffic, which is in orange within the blue color route. So the gray colored route as well shows us the estimated duration to travel as well the distance. Now let us understand what is descriptive analytics and why do we focus on this particular map example. As we understand the route map, the estimated duration as well the distance to travel via the blue color route as well the gray color route. This is one way of understanding descriptive analytics, as in what is happening. But there is another way of understanding descriptive analytics, that is by focusing on summarized past data. And this is a descriptive analytics. We see that what had happened in the previous year. Now let us focus on predictive analytics. What is predictive analytics? This type of analytics looks into the historical and present data to make predictions of the future. What does this mean? So Google has already suggested the best route, which is the blue color route, to travel from Sacramento to Florin, and the duration is 18 minutes and distance is 9.7 miles. Let's assume that Google Map has already collected historical data of this particular route, and based on the available data their model has predicted the best route and also the duration that will be taken to travel from Sacramento to Florin. Now let us focus on prescriptive analytics. Prescriptive analytics describes the solution to a particular problem. What was the problem in this case on the predicted best route? Some predictions on the traffic congestions. And that's when Google Map recommends the substitute routes, correct? Now these substitute routes are also prescribed by Google Map as a recommendation. So prescriptive analytics is nothing but a solution and a recommendation provided for a problem. So in this case we have the best route and we also have other substitute routes. So let's quickly summarize. Descriptive analytics is about summarizing the past data or to see what is happening, for example in the Google Maps scenario. Predictive analytics is about what would happen. And prescriptive analytics is about prescribing the solution, the best solution and the recommended solutions. Now let us refer back to Mark's earlier scenario. Mark along with his team identified the best model. They also did some testing and they identified the best results, and they also finalized on one particular model. Based on that particular model, now the results have to be provided in such a way that they are the best results and also the recommendations, correct? So it may not be just one single solution. It may be a solution with couple of other recommendations as well. So that is exactly what happens in the entire process of data analytics. I hope this has been clear so far. Yes? Okay. And now let us focus on benefits of using R. Why do companies extensively use R for data analysis, and why is it chosen? Firstly, R is an open source programming language, which means that there is no license required to work with R. And R does not require you to have a coding experience, which means that a non-technical person in your team can also learn R very easily and start coding or building models in few lines of codes. R can also be used with other programming languages such as Java, C++, and Pythons. And the integration of R with other programming tools or BI tools is very simple and easy. And various statistical models are readily available in R, which also means that there are plenty of inbuilt libraries and packages already available. And reporting the results of an analysis becomes easier by using these inbuilt packages and for creation of these models in just simple few lines code. With this understanding of the benefits of using R, let us quickly hop on to R Studio and start performing the hands-on exercise for data analysis. For this exercise, we will use a dataset named as demographics, which is in a .csv file type. Firstly, let us load the dataset to R Studio, and we will locate this in an variable named as demo. We also refer to this as a data frame. And now you will notice that a variable is created in an environment section, which is in the bottom right hand side of the R Studio window. And this particular variable comprises of 510 observations or records with 8 variables. Let us simply expand this particular data frame and have a quick check on the data structure and understand the data types. This particular data frame includes variables such as age, marital, income, the unit of income is dollar per day, education levels, the car price, car category with several levels, gender, and retired status. Now let us view the top 6 records of this particular data set. For this, let's simply type head of demo. And the result is now visible in the console section. If you're interested to view all the records, then simply type view of demo. And this new window will show you every single record that is being loaded to R Studio. You may also simply apply the filters and the filter section here on individual categorical variables. Now that we have loaded the dataset and also viewed individual records, let us focus on creating subsets of records by applying filters on individual variables or multiple variables. So firstly, let us apply filter on gender. We will only retrieve the records where gender is equal to female, and we will locate these records in a variable named as demo2. As you notice now in the environment section, the second variable is also created, that is demo. And this now is comprising of 250 observations, which means the records are filtered down to only gender female. Next, let us see how to apply a filter on income variable. Let us only retrieve the records where income is greater than 100. Let's view the result. As we see here, all the records include income greater than 100. Now let us modify this query and we will ensure that the retrieved records includes income greater than 100 and also specific variables are returned. Let's say we only want to have the first variable, third variable, and the seventh variable returned as the result. Let's have a quick check. So we only have the first, third, and the seventh variable returned. How about we only exclude the variable 6 to 8? For this, we include a prefix of minus sign. And now let us see what is the result. We have the variables from first to the fifth variable. However, we don't have 6, 7 and 8th variable. I hope it's clear so far. Yes? Alright. Now let us see how can we apply condition by including both the variables, that is gender and income, and then we will filter the record and create a subset of data. Now let's view the result. Income is greater than 100 and the gender is only female. This is one way of creating subsets. However, now let us see how to use the subset command and create the subset. Let's create a subset of records by applying filter on marital status and age. We'll only retrieve records where marital status is equal to married and age is greater than 35. Let's now view the result. So here we have the age greater than 35 and marital status is married. Let's use the same code and this time we will retrieve selected variables. Let's say variables ranging from 1 to 3. Let's have a quick check. So there are 3 variables. Age is greater than 35 and marital status is married. Now let us see how to structure the data by sorting the data frame in ascending and in descending order. We will apply this order function on the variable income. Firstly, let us see how to order income variable in ascending order. Let's do a quick check. And here we have income in ascending order. Now let's see how to modify the same code and view the records with income in descending order. So we have now the income in descending order. How about include 2 variables and sort the variables accordingly? Firstly, we will sort the records by ordering income and age in ascending order. Let's quickly view the result. We have income in ascending and age as well in ascending. Let's now modify this code. This time we will order income in descending and age in ascending. Let us view the result. So the income is in descending and age is in ascending order. So hope this is clear on how to sort the data frame by ascending and descending order per variable or by using multiple variables. With this, we will focus on learning statistical analysis. How to perform statistical analysis on individual variable or multiple variable. Let's start by understanding the data distribution of variable income so that we identify what is the minimum value of income, what is the maximum, what is the range, what is median, what is the mean, and we will also focus on the quantile distribution, which is also analyzed in a box plot. What is the minimum value in the variable income? It's 9. And what is the maximum? So we have the maximum value. Now let us see what's the range. So the range shows you the result with minimum and the maximum value. How about the difference of maximum and the minimum? Now let us focus on other summaries of data distribution for this variable income. Let's identify what is the mean value of income. The mean is 78. Let's also understand what is the standard deviation. Alright, so the standard deviation is $112. Let us see what is the variance. The variance should be larger than the standard deviation. Now let's say what is the median absolute deviation. As you notice here, the median absolute deviation value is lower than standard deviation. Why do we make this comparison? From this, it is evident that median absolute deviation is robust to outliers and standard deviation is sensitive to outliers and also to the change in the mean value. Now let us understand the quantile distribution. This is the same analysis that is visualized in a box plot, ranging from 0% to 100%, identifying the individual data points. And we can also refer and compare this to the min, the max, and the median values. Let us quickly see what is the median value of income. As you notice here, the median is 45. As well, the 50th percent of quantile is 45, which means 0% is minimum and 100% is the maximum value. Now, if your question is what is 25% and 75%, this is again used for identifying the range of interquartile. The interquartile range is nothing but the difference of 75% minus the 25%. Let's quickly see what is the IQR of income. The IQR of income is 58. Let us do a quick check. 75% of quantile is 86 and 25% of quantile is 28. And the value is 58, which is equal to the IQR result. Now that we have focused on the statistical analysis of the individual variables data distribution, let us focus on the data visualization. In this, we will have a pictorial representation of analysis to identify the outliers, to see what is the minimum and where do we see the data densely populated and how is it scattered, etc. We will begin with creating a histogram. Now, histogram can be used for univariate analysis, which means in this scenario, we will consider income variable and we will see how the count of income ranges gets distributed in a histogram. For this, we will have to install a package called as ggplot2 and also call this library ggplot. Let us install the package. Now let us call the library. Alright, and we are ready now to begin with visualization. For this, we will use the geometric object histogram on the data demo data frame. Let me expand this window so that the code is visible, and also use an aesthetic mapping for variable income. This will be helpful for filling colors or filtrations, etc. And only include 30 bins with individual bin size width of 100, which means there will be 100 incomes in individual bins. Let's quickly look at the distribution of this histogram. As you notice, there are a couple of outliers. The counts of these income range are very limited. However, we see the densely populated income ranges with higher counts between 0 to $200 per day. This is also a way to identify and segment the customers based on their income ranges. Now let us see how to change the color of this histogram and also the border of the histogram. For this, we will include some additional options such as fill with blue color, and the border color is black. Now as you notice here, the executed code provides us the histogram with blue color bars and black color border lines. Now we will focus on creating a facet grid. Facet grid is also an aesthetic mapping object. We will see how to enable the multiple histograms across the marital status and the genders, so that we identify how the income is distributed for individual marital status as well the genders. Let's zoom this view and have a look at it. As you notice here, there are some interesting outliers here in the data distribution. Female unmarried drawing higher income, and male unmarried and married also drawing higher income as compared to the females. Whereas if you notice that the female unmarried is drawing much higher income than the male. This may also be very much related to the age. Now let us see how to create a stacked histogram. When I say a stacked histogram, I mean instead of filling the color, we will fill the gender, so that there is a stack within the histogram. So as you notice here, I have made couple of changes. I have included fill equal to gender within the aesthetic mapping. Now let us look at this histogram. As you see here, the gender is filled in the histogram, hence we have stacked distribution of female and the male. Now let us focus on creating a bar chart with education versus income, where we can identify the education levels and the income ranges for these education levels. As you notice here, we are going to create a visualization where we have the aggregation in form of mean, and the geometric object used here is bar plot. Now let's zoom this view and understand which education level have higher average income. So as we see here, the blue color bar is the post-undergraduate degree, which means this education level draws higher average income as compared to other education levels. Now let's create a histogram where we will see car price and the number of cars for individual category. Let's look at this visualization. This visualization provides us some interesting insight. Just by looking at the distribution of the car prices and the counts of the cars at the car category, economy, and even the luxury. Luxury car category or car price is pretty much distributed, whereas economy car category is dense, which means that we could also look back into the income and age variables and try to figure out further more insights, and then segment the customers for further targeting of these customers. Now what happens if we simply change this bin width to 30? As you observe here, changing the bin width or increasing the bin width will also reduce the number of bins. Now we only have 4 bins here, and the car category is filled. That is what we have enabled within the aesthetic mapping. And we see some more interesting insight. As you look at the standard and the luxury car category, the car prices are pretty much overlapping for the car category luxury and standard. This could be the starting car price of the luxury brands. Now let us create a clustered bar chart. Let's look at this visualization. In this visualization, as you observe, though we have enabled fill equal to gender in the aesthetic mapping, we do not have the view in stacked form, but we have the bars one besides the other. It is also because we have enabled a position called as position equal to dodge in the code. Now, what is the insight that we can draw from this visualization? As you see, postgraduate degree with female gender is drawing higher average income as compared to any other education level. Now let us see how to create a box plot for variable income across the genders. So the box plot can be enabled if there is a bivariate analysis to be performed on a continuous variable and a categorical variable, or multiple categorical variables with a continuous variable. Now let's look at this visualization. What does this say? We have data distribution of income for individual genders, that is for female and the male. And we also notice outliers here. Anything above this whisker is considered to be outliers. It might make more sense if we also include some coloring for these outliers. Maybe also enable shape. So now we have colored the outliers and it's colored orange. Let's see if we can also enable the shapes. And now we have here the outlier color as well the shape enabled. Now let us see how to enable a violin plot. What is the utility of violin plot? With a box plot, we understand the analysis and the distribution of the data points is to identify the outliers, to know what is the minimum value, what is the max, what is the median, and what are the outliers. But what is the purpose of a violin plot? Let us have a quick check. As you observe, there is some concentration of data points in the bottom of every car category. However, the concentration is higher for standard car category as compared to economy and the luxury. Now, this is an interesting insight that you wouldn't have come across in box plot. The box plot is a very good representation for identifying outliers. However, violin plot will help you focus on the nuances which is not captured by the box plot. We can also simply combine the box plot and the violin plot together. Simply include this geo object. Let's zoom this. Now you have a representation of box plot and the violin plot, both combined in a single visualization. Interestingly, you notice the outliers as well the concentration in the bottom of this violin plot. So this could be some interesting insights that you draw and focus on these data points and understand what exactly is happening there. Now let's focus on the density plot, that is density estimate of the histograms rather than just viewing the frequencies. Now we see the frequency in the y-axis across the income distributions. How about enabling the probability as true so that we enable the density instead of the frequency? So now we have the density in the y-axis and in the x-axis we still have the income distribution. This is the way of also adding a line plot, which is a density plot on the histogram. Now, as you observe here, the density plot is not in the same level as the bar. So let us adjust this line. For this, we will include adjust, let's say equal to 3. And now let us see how the visualization appears. Now the density plot is on the same level as the bar. Now let us see how to create a cross table for car category and gender. For this, let us call the library DESCR. Now let us create the visualization, enabling cross table for car category and gender. Let's look at the result in console. As you see here, now we see the counts of the gender for individual car category. The values over here represents that there are 67 females falling within the car category economy and 80 males within the car category economy. And for luxury, we see that the count of female is higher than the male. As well, the proportions. Now, how do you understand what proportions are presented here? We may simply turn off some of the proportions like the t-test, the chi-square, etc. Let us see how to enable that. Now let's look at the result. This looks better. Now that we have the counts, the female counts and the male counts across individual car category, we also see the percentages rather than just looking at the absolute value. So there are 45.6% of female within the car category economy and 54.4% of male within the car category economy. Similarly across rest of the car categories. This kind of cross table or a contingency table is also helpful when you want to analyze the different categorical variables and identify the counts or the proportions. Now let us see how to use a scatter plot of age versus income. Scatter plot is a visualization used for bivariate analysis. When you want to perform some analysis between two continuous variables at a data point level, rather than performing the analysis at an aggregated level, such as sum or mean. And now we have a scatter plot of age versus the income, age in the x-axis and income in the y-axis. Though we do not see any kind of a positive correlation or a negative correlation, but we still see some interesting insights over here. Some of the data points are pretty much scattered and much away from densely populated data points. I hope the learning has been informative and interesting so far. We have covered the concepts of data analytics. As well, we have performed some hands-on, doing some statistical analysis and also creating interesting visualization. To learn more and further on data analysis with R, please watch the video above.
After completing this lesson, you'll be able to explain the various types of graphics available in R, list the possible file formats of graphic outputs, describe the methods to save graphics as files, and describe the procedure to export graphs in RStudio. With its large set of powerful functions, R defines a flexible graphical environment for the visual representation of data. These graphics that help in meaningful data visualization can be viewed on screen, and users can create precisely customized graphical output. The graphics can be saved in various good quality formats, including PDF, PNG, JPEG, WMF, and PS. Typically, graphs are designed on screen, which can then be replotted on, for example, a PDF file. You can also copy and paste in case of a Word or PowerPoint file. Using R, you can produce a variety of graphical images. Basic 3D plots, scatter plots, bar plots, histograms, box plots, and pie charts are 8 standard statistical plots that R can provide. R can also support heat maps, word cloud, kernel density plots, and line charts. Let us look into details of each of these graphics in the subsequent screens. Plotted on vertical or horizontal bars, bar graphs show discrete comparisons among categorical data. The lengths of the bars, each of which represents a category, indicates the frequency, percentage, or proportion of values that fall into the categories. The syntax to create a simple bar chart is barplot x. In the function, x stands for height, which is a matrix or vector. If the height parameter is a vector, the values of the vector give the heights of the sequence of rectangular bars that make up the plot. Let's look at a few examples of how to create vertical and horizontal bar charts. Here, by using an embedded dataset of MT cars, you can plot bar graphs. To create the first bar graph, you pass gear data to the bar plot function. The default setting for bar orientation is vertical. To plot a horizontal graph, you can pass horizontal equals true as the second parameter to the bar plot function. In the next screen, we'll take a quick look at a few arguments to edit simple bar plots. You can add labels, colors, and titles to the bar plot by using specific arguments. For example, legend.text is useful when the height is a matrix. The arguments xlab and ylab provide the labels for the x-axis and y-axis respectively. Call will define the color of each bar. By default, if height is a vector, then gray is used, whereas if height is a matrix, a gamma-corrected gray palette is used. Main sub gives the overall and subtitles for the bar plot. This demo will show the steps to create a bar chart in R. In this demo, you'll learn how to create bar charts. For this data, we will use the MT cars dataset available in R. Simple bar charts can be created using the bar plot function. You can create horizontal bars by specifying horizontal equals true as an argument to the bar plot function. You can also add title, colors, and legends to bar plot by specifying details in an argument. For more options or help document, type the given command in the console. You can create a stacked bar plot if the input is a matrix. The stacked bar will indicate each column on the matrix. The argument beside specifies if you want the bars to be stacked or adjacent to each other. By default, beside is set to false, and if height is a matrix, a stacked bar graph results. If you set beside to true, then you get the columns of height as adjacent bars. You can create a stacked bar plot with colors and legends as shown in the screen. Here in this example on the screen, it's a matrix of VS and gear data from MT cars datasets. Using the same example as in the previous screen, you can create a grouped bar plot. Reiterating, if the height parameter of bar plot function is a matrix and beside is set to true, then the values in each column are juxtaposed rather than stacked. Here, you use the row names function to set the legend, which will set or retrieve the names of rows or columns of a matrix-like object. In this demo, we'll show the steps to create a stacked bar plot and a grouped bar plot in R. In this demo, you'll learn how to create a stacked bar plot and a grouped bar plot. For this data, we'll use the MT cars dataset available in R. For a stacked bar plot and a grouped bar plot, we'll have to create a table like data from the MT cars dataset using the table function. You can create a stacked bar plot using the bar plot function. You can also add title, colors, and legends to bar plot by specifying details in an argument. You can create a grouped bar plot by specifying beside equals true as an argument to the bar plot function. For more options or help document, type the given command in the console. Pie chart is a type of graph in which a circle is divided into sectors, each representing a proportion of the whole. Pie charts are not as popular as dot plots or bar charts in R. You can create pie charts using the function pi x, labels equals. Here, x is a vector of non-negative numerical quantities. The value of x indicates the area of a pie slice. Labels are character strings or expressions that give names to vectors. In the example shown here, you first create the slices vector, which contains numbers 10, 12, 4, 16, and 8. LBLS is the labels vector. Then you pass both these vectors to the pie function as parameters. To set the overall title for the plot, you pass main as a parameter. In this screen, you can see how percentages can be added to the pie chart. In the given example, out of the data vector, you can create the PCT vector and a character vector, LBLS, to add actual labels to the slices. To paste data to the labels vector and add the percentage sign, you use the paste function. Another character vector, call, helps fill in or shade the pie slices. Let's now see how you can create a three-dimensional pie chart. Using the Plottrix package, which has the Pie3D function, you can produce 3D representations of pie charts. There is an explode parameter that enables the pieces to be separated on the chart. However, you first have to install the Plottrix package and reference it using the library function install.packages Plottrix library Plottrix. This demo will show the steps to create a pie chart in R. In this demo, you'll learn how to create pie charts. Pie chart graphics are not available by default. You'll have to install the Plottrix package by using the given command. After installing, you'll have to load the package into R using the given command. For this demo, we'll create a custom dataset using vectors. We can create pie charts using the pie function in the Plottrix package. We can also add a title and labels by specifying the details in an argument. You can create 3D pie charts using the Pie3D function in the Plotrix package. For more options or help document, type the given command in the console. Let's look at another visual representation of data distribution, the histogram. Histograms are a great way to get to know your data. A histogram has an x-axis, a y-axis, and bars of different heights. The bars group ranges of values or continuous categories on the x-axis, and the y-axis shows how frequently the values on the x-axis occur in the data. They display the distribution of a continuous variable and the frequency of scores in each bin on the y-axis by dividing the range of scores into bins on the x-axis. As shown on the screen, the syntax for a histogram is hist in R. For a given set of data values, the generic function hist works out a histogram. If plot equals true, plot.histogram plots the resulting object of class histogram before it's returned. You can create a histogram using the histx function, where x is a vector of values for which you want to plot the histogram. Instead of frequencies, the option frequency equals false plots probability density when you want a histogram of proportion. To control the number of bins, that is bars, use the breaks equals controls option. The break argument helps you control the bin width along with the number of break points you desire. In the example shown on the screen, you can see histograms for dark green colored bins that indicate the miles per gallon or MPG value of the MT cars dataset. A more effective way of visualizing numeric variable distribution, kernel density plots are created using the plot density x function as shown on the screen. Here, x is a density object. You can use the density function to compute the density parameter in plot. In the example shown in this slide, you can create a kernel density graph for the mileage per gallon, or MPG, of MT cars dataset by first calculating its density and then creating the graph. In the second figure, use the polygon function for kernel density of the data for MPG. Vertices are given in X and colors of the area and the border are given by color equals sky blue and border equals black, respectively. This demo will show the steps to create a histogram and density plot in R. In this demo, you'll learn how to create histograms and a density plot. For this demo, we'll use the MT cars dataset available in R. Histograms can be created using the hist function. You can also specify the number of bins and the color of bin as arguments to the hist function. For the density graph, we'll have to calculate the density of data using the density function and then use the density data to plot the density graph using the plot function. you can color the curve representing density using the polygon function. For more options or help document, type the given commands in the console. Line charts represent a series of data points, called markers, connected by a straight line. This type of graphical visualization is typically used to display data that changes over time. As shown on the screen, the syntax for a line chart is lines, x, y, type equals, where x and y are coordinates of the points. Type indicates the type of plot to be drawn, say L for line and P for points, or B for both. Let's now look at an example of a line chart. In the code shown in this slide, you can create weight and months vectors, and then plot a line and points graph together by calling the plot function. These two vectors are passed as parameters along with main to set the title of the graph as baby weight chart. Also known as whisker diagrams, box plots display the distribution of data that is based on the 5-number summary. Minimum, smallest value in the data set. First quartile, 25th percentile. Median, 50th percentile. Third quartile, 75th percentile. Maximum, largest value in the data set. And data is broken into 4 quartiles in box and whisker plots, and each quartile has the same number of data values. Although these plots do not display the frequency, they show where the middle of the data is, a feature that is really useful if you want to analyze the skewness of your data. The syntax to create a box plot is shown on the screen. Box plot data. A box can be created either for individual variables or for variables by group. As shown on the screen, the syntax is boxplot x data equals, where x is a formula and data equals denotes the data frame providing the data. To make the widths of the box plot proportional to the square roots of the number of observations in the sample, use varWidth equals true. With horizontal equals true, you can reverse the orientation of the axis. Default false means the box plots are vertical. In the code shown here, a vector of numbers was created and the summary function called to print the values of the following variables: minimum, first quartile; median, mean third quartile; maximum. Then the boxplot function was used to display the box plot for the vector of numbers. This demo will show the steps to create line graphs and a box plot in R. In this demo, you'll learn how to create line graphs and a box plot. For this demo, we'll create custom dataset using vectors. We'll use the plot function to create line graphs. Points in a line graph can be connected by specifying type equals b as an argument in the plot function. We can create box plot using the box plot function. For more options or help document, type the given commands in the console. Heat maps are two-dimensional representations of data in which the values are represented by colors. The two types of heat maps are simple and elaborate heat maps. A simple heat map provides an immediate visual summary of information. An elaborate heat map allows you to understand complex data sets. Rows and columns can be clustered in a heat map, and the result of the hierarchical clustering computation is shown as a dendrogram in the heat map. As shown on the screen, the syntax to create a heat map is heat map data row V equals NA, column V equals NA. Here, row V and column V decide if and how row and column dendrograms should be calculated or reordered. Data refers to the matrix of values that has to be plotted. Let's look at an example that shows you how to create a heat map. In the code shown here, you can create a data frame by reading data from a CSV file and converting it to a data frame before passing it to the heat map function. Besides data, row V and column V as not applicable, color as 256, and scale as columns to plot a heat map graph are passed to the heat map function. This demo will show the steps to create a heat map in R. In this demo, you'll learn how to create a heat map. For this demo, you'll use the custom dataset imported from a CSV file. A heat map can be constructed using the heat map function. You can also specify the color and scale details as arguments to the heat map function. For more options or help document, type the given command in the console. Also known as tag clouds or text clouds, word clouds highlight the most commonly cited words in a text using a quick visualization. Creating a word cloud in R is relatively simple using a text mining package, TM, and word cloud generator package, word cloud. As shown on the screen, to create a word cloud, use the syntax word cloud, words equal data, frequency equals frequency, min.frequency equals 2, etc. You need to install the word cloud package into the R environment using the install.packages, word count, and library word count commands. In the example on this screen, text data is read from a CSV file, and a word count graph is plotted using the word count function. Passwords, frequency, min.frequency as 2, max.words as 100, and random.order as false. The minimum.frequency argument specifies the minimum frequency below which words that have a frequency lower than that value will not be plotted. The maximum number of words to be plotted are determined by the max.words argument. Random.order means that the words will be plotted in a random order. If false, the words are plotted in decreasing frequency. This demo will show the steps to create a word cloud in R. In this demo, you'll learn how to create a word cloud. Word cloud graphics are not available by default. You'll have to install the word cloud package using the given command, and then load the package using the other command. For this demo, we'll use the custom data imported from the CSV file. We can use the word cloud function to create a word cloud. We can also specify the minimum frequency and maximum word as arguments to the word cloud function. For more options and help document, type the given command in the console. Let's now take a look at the various file formats for saving your plots. R supports several graphic formats and runs on different operating systems. Consequently, there are many formats to choose from depending on what you want to do with the graph, how you connect remotely or locally, and what operating system you use. A few of the available formats are as follows. JPEG doesn't resize and can be used anywhere. PDF easily resizable and is the best choice with PDF latex. PNG doesn't resize and can be used anywhere. WMF easily resizable and works on Windows only. Best choice with Word. PostScript easily resizable and is the best choice with OpenOffice and LaTeX. On the slide, you can see an example to save a graphic output as a file. Regardless of the way you connect or the type of operating system you use, the general method that will work on any computer that has R involves the following steps. Select the file format you want. For example, if you want to save your plot as a JPEG file, use the JPEG driver, which only requires the name of the file that you will use to save the graph. Note that your plot will be stored relative to the current directory, which can be found by typing getwd at the R prompt. Entering your plotting commands next will save those to a file. Then use the dev.off command to close the file. Either you will get a partial plot or nothing in case you fail to enter the dev.off command after you are done with the plotting commands. So if you want to save a JPEG file called myplot.jpg containing a bar graph, you will type the commands as shown on the screen. Recalling the example from the previous screen, you will see that you need to re-enter the commands to save your plot to a file after making a plot to the screen. However, in R, there is another command, dev.copy, which will copy the contents of the graph window to a file without the hassle of re-entering the commands. In this approach, produce the graph as you usually do, and then call dev.copy along with the arguments that are appropriate to the driver. For example, to create a myplot.jpg file from a graph shown by R, type the commands shown on the screen. Until you call dev.off, the plot isn't actually written to the file. This demo will show the steps to save graphics to a file in R. In this demo, you'll learn how to save graphics to a file. You can save a graphic as a JPEG file using the JPEG function. You'll also have to use the dev.off function to return the control to the console back again. For more options and help document, type the given command in the console. In this screen, let's see how you can export graphs in RStudio. Follow these steps to export graphs in RStudio, a powerful interface for R. In the graphics panel of RStudio, click the Plots tab. Click the Explore menu and select the Save as Image menu item. The Save Image window is displayed. Select the image format and directory to save the file. Click the Save button. Follow these steps to export graphs as PDFs in RStudio. In the Graphics panel of RStudio, click the Export menu and select the Save as PDF menu item. Select the directory to save the file. Click the Save button. This demo will show the steps to save graphics using RStudio. In this demo, you'll learn how to save graphics using RStudio. You can save a graphic from RStudio by clicking the Export menu and selecting Save as Image. Select the directory to save the file, and then click Save. Let's summarize the topics covered in this lesson. R includes powerful packages of graphics that help in data visualization: bar chart, pie chart, histogram, kernel density plot, line chart, box plot, heat map, word cloud. You can save the outputs of graphics in various file formats, such as PDF, PNG, and JPEG. You can export graphs in RStudio by using the graphics panel.
Why do people go to Python for it? So the number of reasons. One, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3, or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark under the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm is really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our notebook. These are identical. Jupyter Lab is an upgrade to the notebooks with multiple tabs. That's all it is. And we'll be using the notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy. The least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1. And it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running, is still in the kernel. So it still has the numpy imported as np, and it still has our variable arr1 for array 1 equal to np array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want, what is the type of array 1? And let's go ahead and run that. And it says class numpy nd array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this. Because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a 1-dimensional array. That's all that is. And with the numpy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array 1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2, and we have 0, 1, 2, 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a numpy array. And in the numpy array, we need our first dimension, we'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this, we'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. 2-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3 comma nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2 comma 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1 comma 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1 comma 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here. Whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the numpy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array S for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0 to 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do NP, lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a NumPy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, Forgot the asterisk around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random random.random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go. You have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will, of course, print it out because it returns it as a variable. And you can see here, here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, We can run that, and you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which should generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's the cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, and so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645 and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go, you can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is the column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows. And if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go. There's our slice. Run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows, and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value, or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. We run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning because that's why it registers as 0, it just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. And we were just working with array 2. And what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1. And when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice. And we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on. or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create two arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge two arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back. Let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up in my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because V stands for vertical. And so if we print out cat V and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there because it's much has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing NP unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, neighbor, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have NP intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set X or 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff, 1D. And then set X or, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this Pandas and PyPlot. So Pandas PyPlot, just so we can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import Pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how Pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with Pandas, so a lot of times you just import them by default. Seaborn sits on top of the Matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the Matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have Matplot library as PyPlot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand Matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, you'll have a pop-up when it goes to display the Matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the SNS.set, and we're going to set the color codes equals true. Let them just keep the default one so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd dot read underscore CSV. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytics, using Python / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and inline because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last 3 values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. I'm going to go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in dot values, it converts it from a pandas list to a numpy array. And that's true of any of these. So then you end up in a numpy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a numpy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again, we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn, it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process, but right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. We were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, Pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because Pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a Pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there? So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember, we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.drop duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others, depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function.sum. We end up with HP, the horsepower at 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we've cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them, and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end, expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. We'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps. And there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet. It's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence. And car.corr, that's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our pie plot. So keep in mind that our pie plot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that. So that wraps up our demo part for today.
Let's learn about data manipulation in R. And here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function. And this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now What we can also do is we can use AND or we can use OR operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights, and in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA and you look at the value. So in this way, I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights overall delay. The computation remains same, but at this time, if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this. And that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column, and then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this, and let's look at the value of this one where we are basically now looking at the values, which is sum, and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping. But earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it where I am saying within this particular data set, I would want to get the sum, or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set, or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column, you can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on df. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in our random sample. So that's why when you did a view, it shows your 5 values, and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use DF, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say B, which is going to get a sample out of A, and I just want 5 random values. So let's look at that. So we have B, which is going to get a set of 5 values from A. Now I will create a result variable which will arrange B, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default ascending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns, and you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data. Let's look at this one, and if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name. I can say control shift m, which is for piping. And then basically what you can do is you can do a select, and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder. And here what I'm doing is I'm using a select, where I can look at the new data frame. So let's do this, and I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder, and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4, or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it.
Now, without further delay, let's get started with our demonstration on SQL data analysis for today. So we will be having two different Excel files. So one Excel file will be having the customer's dataset, and another Excel file will be having the dealership Excel file or dealership dataset, right? And along with that, we will get started with the SQL Workbench, MySQL Workbench data tool to run our queries. I hope I made myself clear with that. Now, let's get started. Now, this is our customer dataset. So our customer dataset will be having order ID, state where the customer belongs to, and the region of that particular state, and his customer ID and his name, right? Along with that, we have another dataset known as dealership dataset, right? Remember this order ID, the first column, remember this, right? When we're performing joins, this is the key based on which we are going to perform the joins with two different datasets, right? Now let's check out the second dataset. So this is our second dataset known as the dealership data, right? So we are having the first order ID, and after that we have order date, delivery days, and dealership name, which particular store is that, and the dealership's PIN code, category of vehicle bought, and product name, quantity, fuel type, traffic, leads, orders, revenue, profit, and basically profit as revenue minus cost to company, right? And the order status, is it in transit, is the order cancelled or placed, or is the order delivered, right? So is it not delivered yet? So these are the order statuses. So we have four different of one of them: order in transit, delivered, cancelled, or not delivered, correct? So these are the two datasets that we will be working on today. And let's also take a look on the workbench that we will be executing the queries on. So this is the SQL or MySQL workbench where we will be executing our queries, right? So currently it is using data from a different dataset. So we don't want that. We can create a new prompt and we can get started with our datasets here. So to get started with the new file, we might have to create a new schema first. So let's create a new schema. So you can just write down your name, car dealership, right? So that's the new schema name. Just apply. So you have just created a new schema. Now let's open the schema here, and you have the tables there, and you don't have any data table, right? So for that we might want to add a new table. So double click or right click on that, and here you can see a table, import visit. So browse the path, and here we have the dealership data. Open and click on next. And if you go back here, you have an option called drop data table if the table already exists, right? If you already have a dealership data table there, then you can just drop it off, right? And now let's try to make some changes to it because we don't want the confusion. So either what you can do is you can add an underscore, or if you want to keep the space, or you can eliminate that underscore. I'd prefer to eliminate that underscore and click on next. And there you have the data types, right? So if you want to change some data types, you can do that over here. And I think there is some issue with the first one. Here you have order ID with some extra thing which you don't want here, but we can clear that down the line, not a problem. And import the data file, click on next, and there you go. The data file should be shortly imported. It might take a little while, but it's all right. There you go. Click on next,
and 1000 records have been successfully included. Finish. And we want another table also to be included. So what you can do is use the import data wizard once again and browse and import the customers data this time. Click on next, and the file name, just make sure that you don't have any spaces, but if you literally want the space, use an underscore but not the spacing, right? It might cause some problem while you're writing queries. That's the reason for which we should either eliminate or use an underscore. So go with next, and here we have the same order ID. No worries, we can change the column name over here, right? It's alright, just import the data, go ahead with it. Click on next and finish. 1000 records have been successfully imported. Now let's run some basic queries like, okay, first we might have to use the dataset, right? So we want to use a car dealership. So car dealership, press enter, or you can use control enter. Okay, there was some spelling mistake. So I think we have created the schema with a wrong spelling, but it's okay. All we have to do is just change the name over here, car. So we have added an extra R there, but not a problem. So we are in the schema now. Now let's try to run. Okay, I'll not erase these names because we'll create a document out of it. So we can select any of the tables. Select, let's look at all the columns. Let's look at, okay, double click, start from, yeah, there you go. We have refreshed it. So if you extend, here you can see customer data, right? So let's type in customer data, semicolon, and there you go. When you run it, you have the data, right? So since we have 1000 rows, we can go with the current 1000 rows, or if you want to extend it, we can go with 50,000, or if you want the whole 1 lakh more than, right? There might be data with more than 50,000 rows. In those scenarios, you can also click on the don't limit option. But since we have 1000 rows, we can continue with what we have, 1000 rows, right? Now let's copy and paste the same command and change the name of customer data to dealership. So I'd like to pass a small suggestion here. So when you're writing the queries, use the keywords in caps, right? So uppercase and data tables or column names in lowercase, so that whenever you pass your queries or your document to your fellow developers, then they can easily identify the difference between the keywords and the column names or the data table names. This will help them to resolve an issue if there is, correct? So we have the table over here. Now we have discussed some issue with the column name, right? Now we will proceed with a quick editing query where we will change the column name of this particular dataset, or no, not just the column, correct? Just a moment. So we will take the help of alter keyword. So alter table, and our table name here is customer data. Before that, let's copy this particular keyword here, or we can do one thing, describe table. We can make use of describe keyword, describe table, customer data, enter. Okay, let's find a way to at least copy that column name. I'm not finding how to copy that. Okay, we found a way. Right click or double click, and we have an option of copy field name. Let's copy the field name, and here let's continue with alter keyword, alter table, customer data, and let's not use the semicolon here. Now use the rename keyword, rename column, paste the okay, order ID. So there's the mistake. So we found a way to copy this column name. Just double click or right click here, copy the field name, so that you get the format or you get the exact data which is written as a column name here. there might be some mistake or there might be some problem during the import, but that's not something to worry about. So we are renaming the column name from the existing name to order ID which we want. So just place it over there, or you can manually write it so that you don't want to take any chances for any more risks. So order ID, there you go. Just run this query. And now let's select the data from customer ID once again. And there you go. You have a proper functional working ID. Now let's rename the order ID column from dealership data as well. So I want to rename customer data to dealership data. Just copy the name of the table and replace it over here. And yeah, let's check the columns first. There you go. You have a similar problem here. So let's change or alter the name of the first column in dealership data as well. Now quickly run the query, and now let's select the data from the dealership data. There you go. So we have a fully functioning or fully corrected data set. So we have order data. Remember, you can see I'm using underscore symbol here whenever or wherever I feel like having the space. You can eliminate the space and keep it as order ID in a continuous form without having a space or without having a underscore. But remember, don't just leave it as a simple space. If you leave it as a space, then you might be having deep trouble while you are writing a query to fetch some data. Okay, so SQL or MySQL Workbench might be confused to have spaces in between the column names or the entity names. Let's not make that happen, right? Now let's continue with some queries. So we are currently in the order or dealership data. So here we have some orders data. So we have a product quantity. Now let's build a kind of a problem statement where we have to extract a couple of data sets or a couple of results from the data set that we have. Now let's make use of where statement and try to find some answers, right? Now let's say the dealer wants to know one of the dealership names where it is Prime Auto, right? So he wanted to know how many number of orders Prime Auto dealership has received. Now it's a simple where statement. Let's try to answer the query, answer the solution to the problem. Just write down, select. What do you want to select? I want to select the dealership name, right? Just write down, or let's use the auto suggest mode. So before that, select, leave a space from table name, which is dealership data. Right now you can proceed with the column names. What happens here is when I wrote select from dealership data, it is automatically giving me some recommendations here, right? So the typing time will be less, right? So I want to get back to dealership name, right? Dealership, press tab, and underscore name. I want this dealership name from dealership data, where dealership name is equals to single quote Prime Auto. And I also want to know total number of orders they received. So you can either use count or sum. I'll go with sum of orders. So far so good. So let's run this particular query. Control enter, and there you go. So we have found that Prime Auto dealership has received 5466 number of orders. So if you want to, if you don't want sum of orders here, you can also alias it by typing as total orders received. Yeah. So your column name has been successfully changed, right? And if you don't use alias as, it will still work. There you go. But in case if you want to make the code clearer to your fellow developers, I would recommend to use as, right? Now let's proceed with some other similar where commands so that you have a good habit of how to use where clause in your real-time queries. Now let's go back to our data and see what else we can build as a problem statement. So here we have days to deliver. Now let's say the client wants to know how many cars, if there is a premium, if it's a premium car, then he wants to know the premium cars which took more than 10 days for delivery. Now let's write a where query for that. Place the same query here, and now the name is where auto. I'll use an and statement here. Delivery date or days to deliver is greater than or equal to 10, or we just copy this and paste it over here, and we don't want the alias. There you go. Now let's run this query. And why don't we also write the product name here, right? So we understand which is that car which is taking so much of time. So some of the cars are BMW X3 Baleno. So maybe some reason why these cars are taking a long time for delivery, right? So what happens here is he's able to understand there are couple of cars from couple of categories or couple of manufacturers which are taking a lot of time for delivering the car. So what he can do is he can write down a request or an email to those manufacturers to reduce the time they are taking to manufacture the product so that he can give an early delivery to his clients, right? Now let's run our query back again to see some more places where we can use the where clause. Right, now let's see, we want to categorize or we want to find out specific cars from the segment sedan or the category sedan, where the dealership is Elite Automobiles and the fuel type is diesel, right? Let's try to build a where command for that. Let's copy the same where clause here, paste it again here, product, dealership name, and instead of days to deliver, let's type category. Instead of prime auto, we will be using Elite Automobiles. And the category is equals to, since we're using character data type, we will be using single quotes or double quotes. Sedan. Control Enter, and there you go. So Elite Automobiles is selecting or he is selling all the sedan class BMW series, and these are the details, right? So if the dealership wanted to know what are the cars or what are the products this particular dealership is selling in category sedan, he wants to know if he's focusing on any other manufacturer or a specific manufacturer, so that he wants to make sure that these type of cars or these type of makers should be proceeding with giving more deliveries of that particular category. Now this is one way of doing it, and now let's identify, since we have a couple of and a few more other categories, we want to find out the total number of orders received based on the category. Let's say the business owner wants to understand which type of category vehicles are being sold a lot, and he wants to make sure that his inventory has good number of such type of vehicles for future deliveries or future orders from the customers. In such situations, you want to group by the category, and group by is also a keyword in MySQL where you can use that and categorize based on the category provided. Okay, let's build the query so that you can understand it in a better way. So let's copy paste the same query here, and now we will change a few terms here. Instead of product, we will write category, and instead of dealership name, and instead of category here again, okay, we will write down sum of orders from dealership data, group by category, and order by sum of orders descending. Now what does this query mean? It means I want to find out the category. So SUV category, sedan class category, and hatchback category, right? So I want to find out which type of category is getting the highest number of orders, right? In that case, what happens is, if you find out that SUV category is getting a lot of sales, then what you will do, you will buy a lot of SUV based vehicles from the manufacturers and keep them in your inventory, so that whenever you receive an order for that particular vehicle, you can show the options and make a sale, right? And why are we using order by, right? So we want to find out the highest number of sales, right? Order by descending, what it does is it keeps the highest selling category on top and the lowest selling category on the bottom. So if I run this query, you will understand what exactly I meant. So here you can see SUV category is the one which is receiving the highest number of orders, followed by hatchback, sedan and multi-purpose vehicle, MPV, right? Now these are the vehicles. So what you will do is, the next business decision what you make is, you will try to order a couple of more SUVs for your inventory, and it can be from different manufacturers, and then you will provide multiple options when a candidate or when a client comes for buying SUV type vehicles. Now to deep dive, let's say, since you've already found out SUV is highest selling, and now you want to find out which is that one single car in SUV category which is getting those many high orders, right? So that you want to make sure that you want to understand this particular car is getting highest number of sales from SUV. So I want to keep a little bigger number of that particular car, so that whenever a client comes for that car, I have it ready, right? So if you make slight modifications to this query, you can come up with that category, and I'll also include a product and sum of orders, and order by product, group by product, order by sum of orders descending. Now I am expecting a small error here, but it's all right. There you go. So we might have to place category as well. Okay. Let's try to run this query once again. There you go. So now we also might have to use a where command here, where category is equals to SUV. Now run the query. I guess you will find the answer. There you go. So BMW X3 series is that one SUV which is getting a lot of orders, right? Now if you scroll down, yeah, these are the top five SUV products for which we are receiving total number of highest orders. So what we did here is, we are selecting the category column, product column, and total number of orders, right? So we are filtering, basically we are using where command to filter down the data. So wherever the category is equals to SUV, filter those data alone. And now we are grouping by the product, which is here. Group by product and category, and order by sum of orders descending. Keep the highest orders on top and the lowest orders on the bottom section, where the category is SUV. So in categories SUV, the lowest orders received are 1130 for BMW X5 series. So what you can do is, if you want to cut down, if your inventory is already having a couple of BMW X5 series cars, then what you can do is, you can cut down the imports for that category. And if you have less number of X3 series, you can increase a couple of more cars, maybe 5 to 10 more cars, so that you have your inventory ready with X3 series for your clients, right? So this is how you can use where group by order by in your query. So let's say you wanted to eliminate that particular one product manufacturer which is receiving less number of orders in sedan class. So ASC ascending order, and it is sedan. Now if you run the query, you will find out sedan class BMW X3 is the one which is receiving less number of orders in the category sedan, and you can eliminate that. And if you want to specifically identify a particular dealership name which is having lowest sales, then you can also do that, where category is equals to sedan and dealership name underscore name is equals to Elite Motors, Elite Automobiles. You can also include the dealership name in the column here, and group by category and dealership name. sum of orders sum of orders ascending, and run this query, and there is some problem here in the query. Dealership name category, error unknown dealership name in the field list. Okay, so Elite Automobiles. Let's copy this from here. So we might have made a spelling mistake in our query, but not a problem. Just place it here, and there you go. Now we must be getting the answer. Okay, dealership name. Okay, we messed out with the dealership name, so we had a spelling mistake in case of dealership name. Yeah, that's the one. And now let's run the query. There you go. So in Elite Automobiles and Sedan class, we have BMW 5 Series in less number of orders received, right? Now, there might be some reason for it. Maybe the location of the dealership, where it is. So there might be chances, right? So where, let's say you are in South India, or let's say you're in North India, or some part of a country where the roads are really wonderful. You don't have a ghat section. You're not living in Western Ghats, and you're having good longer highways. In those segments of roads, you would prefer sedans. But in case if you are in a ghat section, or if you are in a where we have a lot of mountains, a lot of off-roading trekking kind of regions, in those regions you might prefer SUVs, correct? So there is a chance. Now Elite Motors might be in a place where there are some odd roads, not good roads. They might be a hilly region. It might be a region where you don't have good roads, right? Even if you're not in the Western Ghats or a Ghat region, or even if you're not in a region where you don't have any kind of hillies or mountain regions, but the roads are not good, or if you are passionate about it, it might be a trend, right? It might be some cult. If you are coming from a region where there's a good cult for SUVs, right? There might be multiple reasons. So I think that is one of the reasons why there could be a high demand for SUVs or sedans or a specific category of vehicles in a certain region. Now, let's proceed with the next remaining queries or clauses. So far, we have dealt with the with clause, the which, where clause, and order by, group by clauses. Now, let's proceed with case clause, right? Now, case is something like a switch case where you have, if you're familiar with the switch cases in programming, then case is similar to that in SQL. Now, let's say the dealer wants to identify, or the business owner wants to identify different dealership names based on the profit they make, right? Or the number of the revenue they make. He wants to find out the highest profit making category as high profit, the medium profit, and the low profit. So the threshold is like 1 million. If they're making 1 million, then they are under highest category. If they are making in between 50 to 1 million, they're medium. And if they're making lower than that, then they are least profiting. And if they are least profiting, they might have to, the business owner might have to take some decisions, might be like helping them improve their sales, or fixing their contracts, or if they want to collaborate or combine that particular dealership, the high performing one, right? Some business decisions to make sure that everyone is breaking even in their profits. Now let's use the switch statement here. So as I discussed, high profit. So I'm going to take 2 columns here. So selecting the dealership name, sum of profit they are making, and case starts here. When sum of profit, I'm calculating the profit here, revenue minus the cost to company, is greater than 1 million rupees, that is 10 lakh rupees, then it is considered as high profit. And if the profit is between 50,000 or 5 lakhs or 1 million, then it is moderate profit, else low profit. Now, let's run this query, and we are grouping them by dealership. Let's run this query and see the output. There you go. So we have profit categories. Here we have high profit result. Okay, let's minimize this section here. Yeah, there you go. So there are 5 to 6 dealerships we have across the country, and most of them are in high profit, or all of them are in high profit. So if we increase the number to 10 million, So far we had 1 million. So if it is between 5 million to 10 million, now let's run the query and see if we have any. Yeah, so most of them are making good profits here. There you go. So far so good. Now this is how you can use a switch case statement. Now let's say I also want, okay, let's first use the pattern matching case here, kind of like statement we can use here, like clause. Now I want to make sure to identify a specific product. Okay, let's run this query once again where we have the dealership data. Select all from dealership data. So now we have 8 series, X8 series, right? So some of the premium vehicles. Now I'd like to go with X8, BMW X8. So I want to identify the dealership names which are selling X8 series. Now we can write down the query as select dealership name. What you can do is just copy the dealership name so that we don't make any spelling mistakes. I think we wrote dealership. Yeah, we can remove this. Dealership name product from dealership data where product like, or you can use like, I think we don't need to use equals to there, double quotes, percentage or mod x8 and percentage. Okay, so what am I specifically mentioning here is I don't care if it is having anything in front of X8 and after X8. So we are damn sure that the series X8 will be released only by BMW. So in few scenarios, the BMW could be in small cases, or there might be no space in between BMW and X8, right? So I don't want to take a chance. So I want the exact details. So I don't care if there is a space or not, if there is anything else. There might be even spelling mistakes, BM or Beamer X8 or the full form of BMW, right? So, and after X8, I don't want to take any chances here as well. It might be series, it might be cars, right? So I want every detail, the dealership name and the product from the dealership data, who is having X8 car in their inventory. There you go. So we have so many dealerships here. So if I have to take the exact names, or if I don't want any repetitions, then I can go with the distinct here. So distinct of dealership names, where we can find out who is dealing with X8 in their inventory. So we have 5 automakers here, 5 dealerships who are having X8 in their inventory. Now let's also have a count, right? So we can make sure that how many number of X8s they have, count of product. So we can understand how many number of, okay, so there is some query mistake here, aggregated without group by. So here we can add another statement, a group by dealership name or distinct of dealership. I'll just go with dealership name here, and order by count of product is sending. Now let's try to run this query by product. Now let's run the query. There you go. So we have City Motors, who has the highest count of BMW X8 series, and they have the biggest inventory, I presume. So in the next upcoming fiscal year, if there is a requirement of importing X8, then you can check out the numbers, right? If you want to import a huge inventory, or if you want to reduce the number, and you can also, if there is a good sale for Asian dealership for BMW X8 series, you can also improvise their numbers as well. So that's how you can use the pattern matching statement. And if you don't want, if you want to exclude X8, then what you can do is just place an I here, I like, or product not like X8. So if you're filtering out X8 and running numbers or codes for everything every other car but X8, you just want to run that query, and here you can see instead of X8 you can have details repeat, and you can see instead of X8 you have every other detail on every other card. That's how you can go with it. Now let's proceed with joins in our tutorial for today. Now let's create a use case, right? You wanted to identify all the customers who bought an X8, right? So if you check the data, if we go back to our query here and run the dealership query, and you can see here we have order ID, order date, delivery date, everything, but we don't have customer name. But I want the customer name, but customer name is in the table customer data, right? And here we don't have the product detail what they bought, right? So Vivan, Sai or Vihan are it can be anyone who got an X5 or X8, right? But now I want to know the exact customers who are or who have already placed an order for X8, or you've already delivered that X8, right? Or let's say you wanted to know if they have placed an order for X8. Now in this situation, you might want to make use of joins, which join two tables and give you the results. So there are basically a couple of joins that you can use: left join, right join, inner join, outer join, Cartesian join, right? So most of the cases you would just go with the keyword join. So it will basically function like a left join, right? You're choosing the first table and you are choosing the matching data from the right table. Now we want the order ID column, we want the customer name, and also the product name, which is equals to X8, and we want to run a join command based on order ID. So order ID happens to be the primary key based on which you can perform the join. So it could be a little complicated orally, so I will write the query so that you have a better understanding for it. So let's quickly run the query. I'm going to use the select statement here, and we wanted the customer name, right? So we want the customer name, or we have it here, right? Double click, copy the field name so that we don't have any mistakes done, and it is from customer data, right? So customer data dot customer name. Okay, let's also copy the customer data table name as well, right? So that we don't have any mistakes in our query. And want dealership data table name as well, so comma dealership data, and what we want from dealership data is product, and we also want dealership data dot order ID, copy the field name, comma from dealership data join customer data to dealership data on what terms. So order ID is common between customer data and order data, right? So we want order ID equals to order ID, but it will be confusing. So what we can do is join customer data on customer data dot order ID and dealership data dot order ID, right? And we will also use a where clause where product dealership dot product, like again the same statement which is here. There you go. Now we are selecting order ID from dealership data, customer name from customer data, and product name from dealership data from the table dealership data. Join customer data table on customer data dot ID is equals to dealership data dot ID, which is the order ID, where dealership data dot product, right? The product details are in dealership data table, and the product is like anything before X8, anything after X8, because we want the details only for X8, the customers who bought X8. Right, now let's run this query, and there you go. So these are the customers who bought X8s. So we have about 29 results. 29 members are the premium customers who got this premium vehicle X8 series. Now that's how you can use joins in a SQL table, a SQL data query. And so far we have covered joins, we have covered case, we have covered pattern matching, we have covered where clause, group by, order by, and select and few others. So we have also made a complete documentation out of it. We now know how to create a schema, how to import data, and few protocols to follow when you're importing data, like using an underscore, and we also have covered alter table. If you have some mistakes in your column name, how to alter the name of that column, right? So these are the fundamentals that you can know about SQL, and also some advanced concepts like case and joins that you can know about SQL. So so far we have covered everything that you must know for a beginner, and also we have covered something if you're an advanced level SQL developer. It's like a brushing up tutorial for you, how to use some clauses like group by, auto by, and how to use cases, how to use joins, right?
Hey there, have you ever looked at a pile of data and thought, how do I make a sense of this? Well, that's where Power BI comes in. Imagine turning boring spreadsheets into stunning interactive dashboards with just a few clicks. That sounds exciting, right? And in this video, we are diving into Power BI from the basics to transforming data, creating charts, visualizations, and even building a real dashboard in our demo. So whether you're a beginner or looking to sharpen your skills, this is the perfect place to start. So let's get started. Just a quick information, if you're interested to become a business analyst, Simplilearn offers the perfect certification program to help you achieve your goals. With this course, you'll learn how to solve complex business problems and gain essential skills, all aligned with IIBA Babcock V3 standards, including CBAP and CCBA certification. You'll also earn valuable certifications from IBM, attend masterclasses with IBM Expert, and get hands-on experience with real-world projects. So find the course link in the description box below and in the pinned comments. Let's get started.
So we're clicking on transform data here, and we are directed to Power Query Editor here. Power Query Editor is going to be a separate window. This is our Power BI desktop. This Power Query Editor window, you can see we have our tabs here, the ribbons. These ribbons are majorly concerned with transformation and cleaning of dataset. Also observe there are 3 panes, queries. This is preview. In Power Query Editor, we have 3 panes, queries, which are dataset that we are extracting from the data source. Second is this is a preview pane, and third is query settings. Currently, we will deep dive into visualizations part and into cleaning and transformation. We'll see that in another video. We'll still go through the basics here. So first is look at the date. We can see the preview that this is a date column. We can click on this calendar icon and we can change the data type that we have here. Usually Power BI is successful in identifying the data type. As you can see right now for the region, it has a successfully identified text for number. It's a decimal number, and likewise. We also have a vertical bar. We have a horizontal bar. We can explore other columns that we have inside the data set. As you can see, the data type is properly identified. We are only going to go ahead and change the name of the data set. Currently, it's a retail data set. So let's rename this to retail data set here. And now we will go ahead, closing the Power Query Editor and applying and loading the data set into the Power BI desktop. We do have an option to only apply and not close the editor. We do have the option to only close and do not load the data set there. Currently, we will be closing and loading the data set there. Closing and loading the data set into the Power BI desktop. You can see the data set is loading up here. It's a small data set of 100 rows. Now here we have our retail data set. Once we have our data set loaded, now we can go ahead and start working on creating visualizations. But before we create visualizations, we should be aware about the basic interface of Power BI and the terminologies related to Power BI interface and desktop. First is, there is not much space here to build. You can see the dotted line square here. Let's understand visualization. What are visualizations? All visuals are images created from data. They help you see patterns, trends, and insights at a glance. In Power BI, you can create visuals like pie chart, line charts, maps, and KPIs. Pie charts are great for showing proportions like sales by region. Let's discuss them one by one. Bar or column charts. Bar or column charts are created to see the distribution between one categorical variable and one numerical variable. As in the example, you can see we are looking at month-wise sales variance in percentage. Or you simply want to go ahead and see the average selling area size for 2 different store types here. Line and area charts. Ideal for tracking trends over time like website traffic, sales from last year and next year, or to look at a certain patterns, seasonal or cyclical. Line charts and area charts are typically created over time series. Time series is any component of date hierarchy or time hierarchy, meaning year, quarter, month, weeks, or days. Says pie charts, donut charts, and funnel charts. Charts are great for showing proportions like sales by region, sales by different chains or categories. Similarly, donut charts can be used for similar reasons to show percentage distribution across certain dimensions and categorical variables. Funnel charts here can show you proportion
in percentages here. As you can see right now, opportunity count by sales stage. We are looking at the sales funnel right now. How many leads we had? How many qualified out of that? How many have we provided solution for? Then out of that, how many went into the proposal stage? And how many out of the 100% were at last finalized and converted? So Power BI offers 4 core built-in map visuals to help you represent any kind of geographical data set. So here display geographic data such as sales by country, or maybe by state, or any other location or geographical location-based data set. There are 4 built-in maps. First is your basic bubble map. They can be created like these. Here are a few examples. Another is filled map. Filled map is where the geographical area inside the map is filled with colors. Third is ArcGIS map. ArcGIS map is an online connected map which can show you individual district. It is interactive and dynamic. It has many more features as compared to a simple bubble map and filled map that we have seen. Last one is shape maps. Shape maps are good for highlighting. In the shape maps, we cannot have data labels, and it can only highlight or color the region which we add in. Let's begin with creating charts and reports in Power BI.
Hi everyone, welcome back to Simplilearn, where we explore the world of data analytics and visualization. Today, we will dive deep into Power BI to create a variety of charts and explore how to make interactive, engaging dashboards, just like this. We will work with a sample retails dataset to visualize key metrics like sales, profit, units sold. By the end of this video, you know how to create bar charts, line charts, pie charts, donut charts, stacked bar charts, and even a map visualization, all on one page. So grab your laptop, open Power BI, and let's get started. Now, we're in Power BI. In this Power BI interface, you might find a few new things. On the right-hand side, vertical corner, you can see a data pane. You have to click on the second build pane, which will give you the options for visualizations. The third icon here is to format whatever object or chart that you select. With the plus sign here, you can customize and get more icons from the Insert menu here. If I click them on again, these will be vanished from your view. You can show and hide the panes by clicking on these icons. The left-hand vertical pane remains unchanged. Here are your report view. These are table view, and here you have the model view. Today we are going to explore different type of charts in Power BI. To create and explore the different type of charts, we are going to work on a very simple retail dataset, which is a CSV file. To connect with text or CSV, as usual, we can see here same as text to columns in Excel. It has identified comma as a delimiter. Now we are going to click on transform data. This will take us to the Power Query. In Power Query, there is, let's check the data type right now. We have date with the date proper data type here. Sales, profit is in decimals. Then we have country and state, which is text. This all seems fine with us. Let's close and apply. Always remember that the interface might look different as Power BI gets updated every month. Not interface, but the Power BI and Power BI online service, that too. Once we are connected with the here retail sales, we can see we have category, country, date, and profit. Let's set their properties first. Category is fine. It is simple text, and we are okay with that. Country is a geographical data set. So we go here and we will describe this, categorize this as country. It is now recognized as geographical data set.
Same goes with the state here. We will decide that this is a state. We communicate this to Power BI. It is a geographical data set. Now, let's begin here with exploring different type of charts. As you can see, the dataset we are using is a sample details dataset, which includes date, region, the geographical location, category, the product category, sales from individual amount, from individual date, total sales amount, profit earned on that particular date, and the total number of units sold for that particular category. We have started by importing this data into Power BI, and now we are moving on to visualization. Let's see some basic visualizations here. First, let's create a bar chart. You can see here we have a bar chart. It's a stacked bar chart, and here also we have a bar chart. Let's create sales by region. Click on the clustered bar chart visual in the visualization pane, which is the first row and the third icon here, inside the build pane here. On the right hand upper corner, you can see the preview of this bar chart. As soon as you have the preview of bar chart here, observing below the build pane, we have y-axis, x-axis, legend, and more options here. Drag region to the axis field. You can also go ahead and check on region. You can either drag and drop, or you can simply check on region. Region gets added into the y-axis. Then drag sales to the values field, that is x-axis here. So here is sales. We are dragging this to x-axis here. Or we can simply check on sales here. Now as you can see, a bar chart is created. We can resize it and keep it here. Now let's format this chart. Let's see the formatting options for the bar chart. To switch on the formatting options, I will go to the right hand side. In the vertical options, I'll click on format. Once I click on format here, you can see this particular format pane consists of all the formatting options designed only for this bar chart. First, let's switch on the data labels. Just scroll down and switch on the data labels here. Switching on data labels will give more information about the chart rather than going and comparing with the y and x axis. Once we see the numbers here, they are not much visible. So we can expand data labels, put values, and increase the font size, maybe change the font style here. And you can see now they are pretty much visible. We can also decide what units we would like to see here. Maybe we would like to see thousands with one decimal point. Now see, these numbers right now are written at the end of the bar, as you can see, and the position is not decided. You can scroll up here, and within the options, just above the value and the title, you can see the position currently is automatic. Automatic means whenever you will change the font style or size, the position is decided automatically. If you want to fix the position, you have the options here like inside end, outside end, inside center, or inside base. Currently, I am liking it better at the inside end. I would also like to go ahead and change the color of the bar, which is by default blue. In your organization, you might have been given template to follow, a color template to follow. You should go ahead and follow that template. Currently, I am following the basic color here. Format, under the visual format settings, we have changed the bar color and given the data labels and formatted them too. Within the format, we do have properties. These properties are not specific to the chart. These properties appear on every chart. For example, the header icons. We want tooltips to be there. This is the tooltip. When you hover over the cursor, what do you see? You do have advanced options here. Okay, we do have advanced options here too. All these are common to each chart. Visual here, you have size and style. The size and position of this particular chart, it can be created from here. You can also decide the background, visual border, and the shadow of this particular chart. Currently, I'm going to switch on the borders and the shadow here to show you how the basic formatting looks like. Below the size and style, we have title. Currently, title is sum of sales by region. Usually, we don't write like sum of sales by region. Instead, we will be writing total sales by region, or only sales by region will work too. You can also decide what kind of font should be there. Always follow the font given by the organization. They will have a fixed font to be used. You can also decide the font style, font size. If you want to give any background color to it. Also remember that it is once it is given, it can be reused multiple times. So no, we don't have to do it multiple times. We are formatting this only once. So this is a simple bar chart with the formatting techniques. Now we want to build up another chart. So let's see a line chart, everyone. Let's figure out trend over months. To create another chart, make sure that you click outside and none of the options should be visible for this particular chart. So click outside in the blank area and automatically you will see only the format option remains. Okay, that is the simple format for the page and the wallpaper. Once you're outside, let's go ahead and create a line chart, everyone. You might find the line chart here in the build pane. So click on the line chart and here we have the line chart. I'm going to place it up here on the second quadrant of the screen. You can see a preview of a line chart here. Now, since we are creating a line chart, always remember, line chart is always created to show a time series pattern and trend. Meaning we need a time series, a date column here. So we do have a date. We will simply check on date. And by default, that date goes into x-axis. You can see we have added year, quarter, month, and day, everything at once. Because date is a hierarchy, everyone. It's a natural hierarchy. So when you click on date here, it will add up to the day. Since let's see the sales trend over months. So we are not looking for day, we are not looking for quarter, we are only looking for year and month. So we will simply add year and month. We can simply cross it off here. Once we have the x-axis here, we want to see total sales here over trend over month. So we will check on sales, it will go to the y-axis. However, we are not looking at the line chart. What we have here is a single dot. Now let's figure out why. See here on the x-axis, it says that on 2023, this is the total sales. It means we have the data for only 1 year. Also observe, now you have multiple arrows, icons at the corner of your chart. These multiple arrow icons are the options to drill down. Currently, we can see year by sales here. See these 2 parallel arrows? It says that go to next level in hierarchy. The next level in our date hierarchy is month. So if I click on double parallel arrows here, now we can see monthly pattern here. We will drill up with up arrow key here. You can see a single dot again. Similarly, you see this fork here. This will expand down to all the levels in the hierarchy. It looks like a hierarchy flowchart. When you click in here, it will show you year and month both. See the icon here. See the x-axis here. This format, now you can see we have size and style. That is fine with us. Now we have, scroll down, we have something else other than the data labels. Always remember, in the line chart, we don't switch on the data labels. If you want to show the numbers on a line chart, it is always advisable to create the column chart or a table with the same date and the numerical value to show the numbers. Because here, line charts are only created to show trend and patterns and to predict those patterns there. Instead, what we have here is markers. When you switch on the markers, now you can see where each month lies that we cannot see on the x-axis here. When you increase the size of the line chart, okay, you might be able to see a little bit more. When we are switched on the markers, when you scroll down, you do have the option to change the shape of the marker. As you can see here right now, you can also increase the size of the marker. You can also go ahead and change the color of the line. Now, how do we change the color of the line here? So we scroll up. Here was our markers. Above the markers, here we have lines. In the lines here, currently we have just one line. So we are going for all. The line is solid, dashed, or dotted. So currently we are going with the solid line here. Join type is round. You have here miter, bevel. Okay, it doesn't show anything here. This is the width, everyone. I'm keeping it round. It doesn't show any changes here. Now this is the width that you can increase here. Okay, and currently we are going to keep it either linear. You have got a smooth option here. It looks like this. And here is the step option. Currently I'm going to go with linear. And remember that it might not be available in your Power BI. This is the latest version we are working with. Of course, you can go ahead and change the line color from here. So this is the line chart, everyone. And do remember, we need to still work with the title. So we scroll up, go with the size and style, which is common to every chart here. We can scroll down here. We have visual borders and shadows if you want. Below that, you will find the title. Inside this title, we are going to look in this as sales trend over months. Here, try to be give exactly similar. So here we have got line chart. I'm going to resize both of them so that they are looking aligned on our dashboard. We have seen a simple bar chart and a line chart. Next is a pie chart, everyone. As usual, to create another chart, we click outside in the area within the report. Now we can see a pie chart on the build pane. With the help of pie chart, we'll see sales contribution by category. So I'm going to click on pie chart. I'm switching off the format to have a better space. Now we can see the pie chart here. You want to see sales distribution by each category. So let's click on category, everyone. Automatically, you can see it is going to legend right now. Pie chart only shows the percentage distribution values here. So let's check on sales and directly go to the values. And automatically, you can see here, it is calculating the percentage for us. We can see category numbers are also here with the list of category legend here. So we do have got colors, we have got name of categories at the size as legend. Here, to make it readable and a better visualization, let's go ahead and format this pie chart. There are a few things that we are going to fix here. First is the vibrant colors. Second is I can see the number and the percentage. However, to connect it with which category it is, we have to still match the colors with the legend. Instead of that, we'll bring the name of the legend within the data label itself. So again, I will switch off data. I'll switch on the format option here. The format options is specifically for the pie chart. You must have experienced by now. For every chart, there is a different options to format. Let's first fix the detail labels, everyone. So here they are not calling it data label, they are calling it detail labels because we can add any details we want here. For example, we are not looking for number, we are looking for percentage and the name of category. So when the details options here, our position is outside. This is where we prefer here. Now we can go to label content, find here category and percent total. We do have more options here. We are going with category and percent of total, the most logical option right now. Now we can see both of them are here, right? Now we will expand the values. Again, you have the option here to change the color so that they are more visible. Maybe make them bold or increase the font size here. Now we can see here. Are there any units right now? There are no units. This is in percentage. Click on none. You do have the option to percentage decimal points. We can type 2. This is our detail labels. After detail labels here, we have the rotation. For example, if you want to show the highest one first, you have the option to rotate it and show the highest slice first. It all depends on you. Which kind of rotation are you looking for? These settings are similar to what you have seen in Excel so far. You'll find the exact same settings in Excel too. Now last is the vibrant colors and the legend. So we don't require legend anymore. We can simply switch it off here. Let's fix the colors. What I'm going to do here is I'm going to simply select the lighter version of each color. Remember that usually you will have a template given to you by your organization and you are supposed to follow that template and the colors that are associated with the brand. And that is a much better way to go. Currently, picking up the colors which are more soothing to the eyes and have a good contrast to be seen with each other. So this is our pie chart, everyone. Now in this pie chart here, we do like to go ahead and edit the title and the background and the shadow, right? Now we can actually do, what we can do here is, we can again go here to size and style. With size and style, we have the visual border and the shadow, and below that we have got title. And this title here, this is sales contribution by category. So let's name it properly, sales contribution by category. Okay, we can increase the size, we can change the font style right now. We can give a background color here and make it at center. Now, this is our pie chart, everyone. Next chart is donut chart. Let's explore the donut chart here. Let's figure out profit by region. So we have profit margin here by region. To do that, to see profit margin by region here, let's see it by donut chart. Now to create a donut chart here, it is just beside the pie chart. Again, click outside in the region. We are going to click on the donut chart here. In this donut chart, we have the exact same portion here. Remember that donut chart and pie chart are exactly similar in concept. However, they do look different, as you can see here right now. You can see the preview of the donut chart. It is quite different from pie chart. It is still showing the percentage distribution here, but the center part of the pie, it looks like a ring. So let's go ahead and view how does a donut chart look like. We are simply going to check on region and the profit as we did for the pie chart. Now we would like to go ahead, and you can see here it is exactly like the pie chart with the middle circle is gone. We would like to go ahead and format it similar to the pie chart, with all the regions written here, with only the region and the percentage of the profit here. And of course, we would also like to write the title here as it is. But since we are in Power BI, we don't need to go ahead and format it every time. Since we are in Power BI, we are not supposed to do redundant steps here. We'll simply go ahead and select pie chart. We can click on Format Painter. We can come back here. You can see the paintbrush is here. And now click. And here we are. You can see the title has been changed. You can see the labels are here. Only thing that is not changed is the colors. So we now open the format. We switch on the data here. In the format, I'll go to slices, and again, I'm going to simply select a shade lighter than the original color here. Here we are. You can see sum of profit by region. Of course, you would like to go ahead and change to a proper title. So let's give the title as profit margin by region. As you can see, there is no OK button. Whatever changes you do in the format pane and build pane, they are automatically applied here. That is total region by, we have seen 4 charts: bar chart, line chart, a pie chart, and a donut chart. Now, next is we will see a little bit advanced visualizations. For that, I'm going to the next part here. I have added one more sheet, named it Basic Charts 2. And you can see I have a background here. What are the other basic charts that we're going to see? In here, we are going to see stacked bar chart, drill through line chart, and a map visualization. Let's first see what is a stacked bar chart. We are into the build here. The first chart that you see here is called as a stacked bar chart. A stacked bar chart, as you can see here, it looks like a normal bar chart. However, we do have the option here to add more than one categorical value and see the distribution over one single numerical value here. For example, here we can see units sold by region and category. Region and category being 2 categorical variables. And we want to see the distribution of units sold by region and category both. So first check on region, then on category. You will see automatically they will place themselves. Since there are 4 regions, regions will go to y-axis here. Legend is coming back to category. And now we check on units sold, everyone. And it goes directly to the x-axis here. And here is our stacked bar chart. Of course, it is the exact same bar chart, right? With in each bar is getting divided into individual regions here. So here category, we have groceries and region both. I don't want to go ahead and do the formatting all over again. So we can go back here. We can select the bar chart. We can format paint it and paint it out here. Now let's understand this bar chart effectively. Each color represents individual category. So as you can see here, okay, we have got clothing, electronics, furniture, and groceries. And each of these numbers represent the number of units sold in that particular category in that particular region. It means that 362 units of groceries have been sold in West region. And within one bar, we can see the differences here. This is units sold by region and country. It is a stacked bar chart, everyone. Let's resize and keep it here. Let's explore the formatting options that we have here. You will find the formatting options are exactly similar to what we have seen before. We have seen data labels, but here we do have total labels here. Total labels will give us total by whichever we have on the y-axis. Right now, I don't see much use of the x-axis right now. So we can scroll up. We can go to the x-axis and we can say that I don't want to see neither the values here nor the title, which will give us a better space. It will give us a better space here. This is a stacked bar chart. Now let's learn in detail what is a drill through line chart. Let's learn. To understand about the drill through line chart, you might be thinking that we have just seen a line chart. We have drilled through that. Yes, we did. But now we have to actually learn the difference between the continuous and the discrete drilling down in line chart. So let's see here. We are going to go ahead and explore the line chart again. So click outside, please. Then click on the line chart here. The line chart appears, as you can see here right now. As we are aware, line chart requires the time series. So we go ahead and we check on date hierarchy, which automatically goes into x-axis here. Now this date hierarchy actually goes ahead and gives us the drill down ability. We don't want to drill till individual day here. We are looking for only year, quarter, and month. Usually, we only have one line that we have seen so far. So we go ahead and we check on sales for now. Now we are aware that currently it is showing us only by year. That's why we have just one dot because we do not have multiple years. And we are also aware that we can go to the next level in hierarchy. This time, the next level in hierarchy is quarters. So when you go ahead and go to the next level in hierarchy here, okay, what you are looking at quarter-wise total here. Sum of sales for each quarter. Since it is only 1 year, this particular sales of quarter is fine. It shows us quarter 1, 2, 3, and 4. However, if you had multiple years like 2022, 23, 24, and so on, then it will still show quarter 1 total sales from all of the years. Meaning, currently it is showing us discretely only for quarters. It is not considering that quarter belongs to a certain year. Similarly, you can see right now, since we have one more hierarchy left, that is month, we do have this is still activated. If we go in here, we do have monthly distribution of sales over the month. In here also, it will aggregate every year, month sales over all the years that are present. So it is just 1 year. It doesn't show much difference to us. Now I will drill up again and we see quarters again, and then here we see years. Now if I go ahead and switch in here, expand all down to one level in hierarchy, here you can see same January, April, July, and October 2023 here. However, it does write month on the x-axis, but this line chart shows only as per quarters. You'll also find that currently this will also ask you that here is still the scope of drilling down is available. So we go ahead and we click here again, and here we are having exact same line chart as we have seen before after the drill down. What is meant by drilling down more here? So here you can click on the chart here. Now, since we are looking at the basic charts here, let's also explore. Right now, we have only just one line. We have always added only one line in a line chart. Let's also go ahead and add profit here within the line chart. Now, you can see we have got two lines, everyone. And now both the lines can be drilled up or can be drilled down. And we can compare the trend between profit and sales. Again, we will go back to basic charts here for the formatting. We will go ahead and get our format painter here. And use the format painter to format our line charts. Since we have got two lines here, we might want to go ahead and change the colors. So we will go scroll down here. We do have lines. We can decide the color for individual line. So remember that when we go to the lines here, you need to select which line you want to change the color for. So for example, I'm going for sum of profit. We will scroll down here and we expand the color. Now we can change the color here for the profit like this. As you can see, this width and everything will remain exactly same as the formatting before. Below the lines here, we do have markers. Again, for the markers, you can choose which particular line are you looking forward to. Go ahead and change the markers for. I'm simply changing the color for the markers here. So right now, what we can see here is sum of sales and sum of profit here. You can see here, it says add a legend title right now. This is for sum of sales and sum of profit, but we don't see the title is required. So we can collapse these options right now, scroll up and find the legend. Within the legend here, we do require the sum of profit and the sum of sales. This particular explanation here in the legend that what these lines represent. We do have the option right now to switch off the title. We don't need the title anymore, so we can see the titles right here. If you think that these are too small to be seen, you can increase the font size here. And you can decide the position of the legend too. You can keep them at top right. So at the end here, you can see that what these lines are for. You can also decide to keep them here too. So it all depends on you. Where would you like to keep the legends? Currently, I'm going to keep them at top and center. So these are the line charts where we have two lines in one single chart here. Of course, if you want to go ahead and set the title here, you can always go to the title and change the title here to monthly sales and profit trend. Sales and profit trends. To remember that these drill through options will be available to the end user too, whether they have editing rights or not. This is one of the interactive features in Power BI. And next, the most interesting one here is the map. As you can see right now, in Power BI, we do have multiple different type of maps. This is our basic bubble map. Another is filled map. This is shape map. This is an Azure map. Yes, it is related to Azure. We have to go ahead and we will see the map from there. Another map is ArcGIS map. That on all these maps are needed to be SMAP here. Simple map is available to everyone. This doesn't need to be activated here. So first, let me show you how to activate the map visuals here, and then we'll go ahead and create a map. File here, everyone. We go to options and settings. And options and settings, we go to options. Options. We have two types of settings, global settings and the current file settings. We'll do our global settings here. In the global settings, go to security. In security, scroll down, and you can check on, you can go ahead and check on ArcGIS for Power BI. You can also check on map and filled map visuals. We are simply activating them. After activating them, Power BI might ask you to restart the whole software application. Remember that restarting means closing each and every instance of Power BI that you have opened up currently. After security, you have regional settings, and then you have preview features here. Now, these preview features here might differ in your case and this particular version here. As you can see, the first checkbox is shape map visual. Simply check on that, please. You can also go ahead and explore other options here. These are not related to the map for now. Simply check on shape map visual. So we have done two settings here, everyone. First setting was security, and the second is preview features to switch on the maps. And then click on OK everyone. It might ask you to restart it. Yes, you need to restart to activate the maps. So save your file and restart. Currently, maps are already activated in mine, so I will continue with to show you the map visualization. To create the map visualization, as usual, click on the blank space here. This is the first map that we are creating. As you can see, it shows that it's a bubble map. We can see the bubbles here and the grayed out preview feature too. To create the map here, we are going to use the geographical columns here like country and state. When you're creating a map, look at the options that we have available here: location, legend, latitude, longitude, bubble size, and tooltips. We don't need to have latitude and longitudes here since we have country and state. Please remember that any data visualization tool, if you have the ISO standard spelling of country and state, correct spellings as per ISO standard, then any data visualization software can go ahead and fetch the latitude and longitudes and place them on the map visualizations. If you require to pinpoint a certain geographic location, okay, which can be a pin code or maybe it is a particular district or a street area, then you might require the exact latitude and longitude to be uploaded here. For now, we will check on country and state. When you check on country and state, the bubble chart doesn't look good. Why? Because by default, you can see the country is getting added into location and the state directly going to the legend. However, we want our state to be added below the country. So we'll drag and drop the state below the country here. As usual, you can see, and we will close off the legend from here. Now you can see we have got bubbles across here, right? The countries here, and we do have the option of drill down. Once we drill down here, we will see a few more bubbles across. So now it is showing us individual states in each country. That's good for now. So we have bubble here. If we will scroll down, you will also find currently these bubbles are only showing the position right now. If you scroll down here, we have few more options like legend. Then we have options here like bubble size. It means that we can use the bubble size here to see how much sales has happened where. And as soon as I drag and drop the sales into the bubble size here, it is sum of sales right now, and we can see the size of the bubble has changed, and we can figure out the highest sales here is in Scotland. Similarly, we have legend. In the legend here, if I will go ahead and bring a state again into the legend, you will find that each state is colored separately. We can see the legend up here. Let's go ahead and format this map. To format this map here, everyone, we will go ahead and switch on the format options here. In the format options, we do have very less options in the format visual settings here. First is our legend, which is not properly visible. So we can switch on the legend right now. The position is top left, which is not properly visible. We can go ahead and keep them on the left side. It's tagged like this. Now they are pretty much visible to us. We don't need the title right now. We know these are states. So we can switch on the title here. Now we have the whole map in front of us. We do have few map settings. In these map settings here, okay, we have different styles of map. This is our road map right now. We do have an aerial map, which we are accustomed to, the satellite map. We have dark themed map and the light themed map here. Please do remember that if you're using dark theme, your whole report has to be dark themed. This is our grayed out map, and it's a simple road map here. Why it's called a road map? Because if you will zoom in, okay, you can actually see the road maps here, just like this. Next here is controls of the map. In controls of the map here, currently it is automatic zoom here. For example, if I click on west here, it will show me only west region and it will automatically zoom on that particular part. You can also add the zoom buttons out here. So you will have plus and minus zoom buttons here too. This is all in the maps. So currently what we have created is a bubble map, everyone, and we can see each bubble here and where we have the signs. Now it depends on you. How would you like to keep your legend and add more colors to it? And as usual, okay, we want to go ahead and format the title here. So we can always go ahead and use Format Painter and we can have the title painted here. Use the Format Painter to paint the title here. Of course, we can always go ahead to the title here. And what we are looking at here is the sales distribution by location. So let's give a proper title, everyone. This is sales distribution by location. You might have observed that there is no option here to add data labels here. We do have category labels. Category labels will simply go ahead and switch on the name of the state and the country. If you have city and district name too, it will add it back to here. However, we cannot go ahead and show the labels out there. So I don't like the state labels always. Okay. It crowds your map and it is not properly visible. I'm going to switch on the category labels right here. So everyone, these are stack bar chart, multiple line chart, and a bubble mark. Now let's go ahead and create a report out of these charts that we've created so far. In this report here, we will also add few more objects and we'll make our report interactive. Now in Power BI, there's a difference between a report and a dashboard. In general, what we call a dashboard is the collection of multiple charts and other objects, which are either interactive or static, but they should serve and solve a particular objective or a function. However, in Power BI, whenever we are working in Power BI desktop, each of these pages that you open up, and when you have multiple charts on it, it is called as an individual report. When we will publish this into Power BI service, or you can call it online Power BI, currently we call it Microsoft Fabric, then there we create a dashboard, and that dashboard can create charts from multiple Power BI reports, not only one data set, from multiple data sources too. So dashboard is a different part. What we are going to create here is an interactive report. Now that we have all charts on individual report page, let's go ahead and copy paste few charts here within the pages too. Report page, we are going to design it as per the objective of analyzing our sales and profit for this particular retail store. First, let's give a title to the report, everyone. To give a title here in the home tab, we'll go ahead and click on text box. In the text box here, I'm going to simply type right now that it's an annual sales for performance report. So this is annual sales performance report, and we are keeping it for retail sales 2023, for example. Now this is a text box. I'm going to increase the size of the text box here. Of course, the data that we have written here, it is not visible. So you can Control A or select as I've done right now. I'm going to change the font size here. I'm going to keep it bold. Let's keep it at the center. I am going to change the size of this retail sales 2023 that I've written here. Like this. And here we are. So this is our annual sales performance report. What I'm going to do here is showing you another way to create this. I'm going to select this whole thing. All right. I am going to make it a little bit gray. Of course, white on gray is not visible. So we go ahead and we open the format option for it. And in the format option, within size and style here, we are going to give it a background color. We are going to give it a darker background color here. And here we are. Much better. We will give it a border too and a shadow here. So this is going to be our title for the report. You can size and place the title. Once the title is here, you do have few options like padding. Okay, what does that mean as how far it is from the borders here. If you want, you can go ahead and decrease or increase them as per your choices. Within the visual borders here, okay, you can change the color of the border here. Corners rather than a rectangle. Here you can have the rounded corner rectangle. You can see it looks like this. Here, do you see the rounded here? Rounded corners here. It looks like this. So right now, this is the title that we have given. After the given title, let's go ahead and get few charts. So first, I'm going to go ahead and get the simple bar chart. I'm simply copying and pasting for now and keeping them at a certain place. I'm also going to get our line chart and the map here. As you can see right now, we are resizing it. Every chart is getting resized here. Since we are bringing all the charts together to create a certain report, that can give us the performance for sales here. I'm also going to bring our pie chart, and a donut chart. It does look everything is very small and compact. However, it is because we are currently designing in the zoomed out version here. As in when we will resize it to a proper viewing capacity of your laptop screen and the general 16:9 size, it is going to be perfectly visible. So we do have our all charts here. Let's go ahead and add few more objects that are required in the reports. Few other objects are, first, let's go ahead and add a slicer for country. Why not see the sales distribution by region, by category, and by location for each country? To bring out the slicer here, click outside on the, and here is the slicer, everyone. This is how the icon looks like. What is a slicer here? Slicer here is an interactive filter which the end user can directly interact with. They can change the view of the whole report. And this particular slicer by default will be connected to each and every chart here. So if I select here, for example, Australia, you can see it zoomed in into Australia here. I can see over the time here. You can see contribution by category and region too. If you want to clear it out, okay, you can go ahead and clear selections from here. However, we do have an option. So if I open up the formatting options here for slicer, okay, we go to slicer settings. In slicer settings, we have vertical list. That's good. This is what we are looking for. In the selection, we can go ahead and switch on the select all button. Select all button make it easier for the end user to understand what's going on here. And if they want to go ahead and uncheck any selection here, okay, they can simply go ahead and select all too. It gives them flexibility to understand how the slicer works. Now, after the slicer here, I would like to keep my KPIs and the aggregate numbers on the display here. To do that, we have multi-row cards. So again, click outside here. I'm going to click on multi-row cards. Cards are the display cards here. In these cards, we can go ahead and display any numbers that we are looking for. I'm going to show the cards here. I'm simply placing it in the available space here. Inside this card, as you can see here, within the format and the build, it simply has one option to fill, that is fields. In this fields here, let's go ahead and check on our numerical variables, like we have got sales here, profit here, and number of units sold. When you check on these, within the format here, we do have the option here to make them visible properly. For example, we can go ahead and decide the font here, which kind of font you will be looking for values and the labels too. So I'm going to increase the font style for values. Okay, you can go ahead and also decide the font style too. So these are category labels and these are the numbers here. The cards here. Okay, you can go ahead and decide the background color for individual card too. Now there are multiple formatting options available for us. If you want to go ahead and give border to these, okay, you can go ahead and give the border to, like this. Okay, so now here are our multi-cards. Multi-cards, we can have our KPIs placed, right? We can see our sales, total profit, and the sum of units sold too. This is multi-cards here. When you talk about objects on a report here, okay, now we have got a slicer and multi-row cards here. Now we can also have an image. How do we insert an image here? We can always go to the insert drop down here. Right hand side here, you can see image. This is an image that we have here. Let's find another. Here I'm using one image right now. Okay, a general logo here. Here for Simplilearn. As you can see, the image is right here. I'm going to keep it here. Now remember that this image can serve multiple purposes too. You can add actions into it. You can add multiple formatting options too. So right now I am not giving any title to it, okay, and this is our image style. Currently the scaling is normal. Either we can fit it to the size here, or we can ask it to fill whatever size that we create here. It all depends on us that how we would like to go ahead and view this image and save this image here, right? Now it all depends on what kind of scaling you are looking for here. So here we have added an image as a logo, everyone. I'm keeping the scaling as normal. So if you're working with me here, congratulations. You have created a fully interactive Power BI dashboard with bar charts, line charts, pie charts, and map visualization too. Now let's go ahead and decide the interactive part, everyone. Here, whenever you click on a chart here, you will find 2 extra tabs called as Format, Data, and Drill. Let's go to the format here. So currently I'm selecting the bar chart here. I go to the format. In the format here, we have on the left and upper corner, we have edit interactions. This edit interactions here decides that how each chart decides to behave with another objects and charts available on this particular report. When we switch on edit interactions, you can find that this particular bar chart is currently filtering out the map. We have 3 options here: highlight, filter, and stop, meaning none. So currently it is highlighting the donut chart, highlighting the pie chart here, filtering the line chart, and filtering the map. What does that mean? So let's see here. If I click on West bar chart, you can see the line is getting filtered out. Your bubbles are changing. However, look at your pie chart. Your pie chart currently has highlighted a certain area of a certain slice of that particular West region. And within the West region here, it is trying to highlight within the donut that how much percentage is here. So for West, it only highlights West as 32%. We would like to change that. We would like that only filter should work. So we go ahead and we highlight filter and we highlight filter here. We can go ahead and decide the interaction for individual charts too. So if I click on the pie chart here, I would like it to filter out the bar chart and filter out the profit margin chart too. I click on the donut chart. I will make sure that it filters out the bar and the pie chart here. Similarly, we decide for the line chart here. Okay, it is going to filter out each chart here. By default, everything is set on highlight. Same with the map here. We can select on map here. And we can ask it to go ahead and filter out each chart that is associated with it. If you want that no one should be able to click on the line chart and filter out anything else, then you can go ahead and select none. If you select none, then it will not be parted out here. Once you're done with the settings for individual charts, you can go ahead and switch off edit interactions here. And remember to save your work. Now let's see how does it look like. This is our final report, everyone. If I want to go ahead and see what's happening in Australia, I can simply check here the slicer. Okay, we can see the Australia here. Over the time, how was the sales? How was the profit there? What was the how the sales? We have sold out clothing at 41%. And the highest grossing region has been West here too. So if I click on West within Australia, the West region, we can see the West here, we can see the South here, okay, we can see the North and the East here too. In a similar manner, we can go ahead and check for another countries too. And you can see how easily and smoothly the map moves. And we can go ahead and give multiple filters by using slicers and multiple charts too. If you want to go ahead and give multiple filters, always remember, you can select on individual chart by holding on to control on your keyboard, just like this. So West into clothing store, this is how the sales and the profit has been working. Australia, if I want to go ahead and see the West and only the clothing, this is the trend that we see. If I select only for UK, this is the trend that we see in UK and US too. So here we are applying multiple filters. So So congratulations everyone, you have created a fully interactive Power BI dashboard with multiple charts and interactions. Remember, always choose the right visualization for your data. Avoid clutter and focus on insights. Use interactivity to make your reports engaging for the end user. Thank you very much everyone. If you found this video helpful, please like, share and subscribe to our channel, and see you in the next video with text measures. Thank you very much.
So that's a wrap on our full course. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Today, I've got a question for you. What's the difference between a data analyst and a data scientist? Well, in this video, we will give you the answers. From healthcare to ride-hailing apps and online shopping to streaming services, big data has transformed applications and how we interact with them. Two key fields underpinning this transformation are data science and data analytics. Now, I know these concepts can be a bit tricky to grasp at first, so let's use a fun analogy to make it more clearer. Imagine for a moment that a business is like a human body. In this scenario, a data scientist would be a general practitioner, while a data analyst would be more like a specialist consultant. Both play crucial roles in keeping the body, or in our case, the business, healthy and functioning well. Think of the data scientist as the GP who looks at the entire body. They need to understand how all the different parts work together and how external factors affect overall health. This big picture views allows them to ask important questions about the body's well-being that others might miss. On the other hand, the data analyst is like a specialist focusing on a specific part of the body, let's say the heart or the brain. They dive deep into the area of expertise, answering specific questions and solving particular problems. For example, if there's an issue with the heart, the data analyst or heart specialist would be the go-to expert. But remember, while the specialist focuses on the area, the GP will still keep an eye on the overall health. They work together, each bringing their unique skills and keeping the body or the business in top shape. So in a nutshell, data scientists and data analysts both play vital roles in keeping a business healthy. The data scientist looks at the bigger picture, while the data analyst dives deep into specific areas. Throughout this video, we will explore these roles in a more detail, looking at the specific tasks, skills they need, and how they contribute to the data-driven world we live in. So let's discuss the differences between data analytics and data science. Imagine a thriving social media app with millions of users sharing photos, videos, and messages every day. At this company, we have two data heroes, Alex, the data analyst, and Chris, the data scientist. They both work with data, but their roles are quite different. Alex is like the app's detective. Their job is to figure out on how many people are using the app right now. Alex looks at two things. Firstly, which features are most popular, when do most people log in, and how long do users spend on this app. Alex digs through user activity logs, engagement metrics, and customer feedback to answer specific questions. This helps the team make the app better today. That's what data analysts do. They solve current puzzles using existing information. Now, Chris, they're more like the app's fortune teller and inventor rolled into one. Chris takes all the data Alex collects, put a whole lot and more, and tries to predict the future. They ask big questions like, what new features will users want next year? How can we use AI to make the app more fun? What if we could predict trending topics before they explode? Chris uses complex mathematics, machine learning, and computer programming to spot trends and create new ideas. That's what data scientists do. They use data to predict the future and innovate. Both Alex and Chris are crucial for the app's success. Alex helps the app run smoothly and keeps user happy day to day. Chris helps the company plan for the future and stay ahead in the competitive tech world. Let's look at the key definitions of how they differ from each other. Comparing data science versus data analytics. Data science and data analytics, while related, serve distinct purposes. Data science is a broad multidisciplinary field encompassing areas like machine learning, artificial intelligence, and computer science. It involves researching vast amounts of unstructured data to ask and answer strategic long-term questions. Data scientists often build complex models and algorithms focusing on innovation and strategic decision making, and they usually hold senior roles. In contrast, data analytics is a specialized discipline with data science that focuses on analyzing existing structured data to answer specific and immediate questions. Data analysts interpret data, identify trends, and provide actionable insights using tools like SQL and Excel. They often work in specific departments like marketing and sales. While their skill set is narrower than the data scientists, they have a deep understanding of their particular business's area. Essentially, data scientists create a big picture framework while data analysts zoom in specific elements within that framework to optimize current operation. Let's talk about the skill set comparison. Skills for data analyst. Proficiency in business intelligence tools, strong statistical analytical skills, intermediate programming skills in SQL and Python, expertise in data visualization tools like Tableau and Power BI. Next, let's discuss the skills for data scientist. To be a data scientist, you must know advanced knowledge of machine learning and AI. You must have experience with big data platforms such as Hadoop and Apache Spark, strong programming skills in Python and R, proficiency in predictive modeling and data mining techniques. Let's discuss the workflow comparison. Now, let's compare the workflows of data analyst and data scientist. The workflow of data analysts typically begins with data collection, where they gather data from various sources to ensure they have all the necessary information. Next comes data cleaning, a crucial step where they remove any errors and redundancies from the dataset to ensure accuracy. Following this, they perform data analysis, using statistical methods to interpret the data and uncover patterns and trends. To present their findings effectively, data analysts then engage in data visualization, creating charts and graphs that make complex data more understandable. Finally, they provide actionable insights, offering recommendations that can be implemented immediately to improve business operations. In contrast, the workflow of a data scientist starts with identifying the problem, where they define a strategic question or opportunity that needs to be addressed. Then they proceed with data mining, extracting relevant data from large data sets to gather the information needed for the analysis. Similar to data analysts, data scientists also perform data cleaning to prepare the data for analysis. However, they take it a step further with data exploration, conducting exploratory analysis to understand the depth of data. Next, we have feature engineering, where they create new features from raw data to enhance their models. And then they build predictive models to forecast future outcomes based on the data. Once the models are ready, they deploy the model into production and start generating insights in real time. The final step is their workflow to monitor and iterate, continuously improving the model based on the new data and ensure it remains accurate and effective. Let's discuss the tools and techniques. Let's explore the tools and techniques used by data analysts and data scientists. Data analysts like Alex uses a variety of tools to handle and analyze data efficiently. They often use Excel for data organization and basic analysis due to their accessibility and functionality. For querying databases, SQL is the go-to language, enabling them to extract and manipulate data effectively. To visualize data and create insightful dashboards, Tableau is commonly employed using robust data visualization capabilities. Additionally, Python is used for more advanced data manipulation and analysis, making it a versatile tool in data analyst toolkit. On the other hand, data scientists like Chris rely on slightly different set of tools to handle their more complex tasks. Python is a staple for data manipulation, machine learning, and artificial intelligence thanks to the extensive libraries and frameworks. R is also a key tool particularly for statistical analysis and visualization, providing powerful statistical techniques. For processing large data sets, Hadoop is indispensable. Enabling scalable and distributed computing, Apache Spark is used for large-scale data processing, offering speed and ease of use for big data analytics. Lastly, we have the TensorFlow, which is important for building and deploying machine learning models, making it essential for AI-related tasks. Let's discuss the application comparison. Let's see how the work of data analysts and data scientists relies in real-world scenarios. Data analysts like Alex plays a vital role in understanding user behavior. For example, they analyze which app features are most popular among users, providing insights that can enhance user experience and app's functionality. In the realm of sales, they identify trends and optimize marketing strategies, ensuring that the company targets its audience effectively and maximizes revenue. Moreover, by analyzing customer feedback, data analysts help improve product features, ensuring the company meets customer needs and expectations. Conversely, data scientists like Chris engage in more predictive and innovative application. They use predictive analysis to forecast future trends and behaviors, allowing companies to make informed strategic decisions. For instance, they build recommendation systems that suggest products or contents to users based on their past behavior, enhancing user engagement and satisfaction. Additionally, they develop AI innovations to improve user experience, such as chatbots or personalized user interfaces, leveraging advanced machine learning models to stay ahead in the competitive tech landscape. At last, we will talk about the career path comparison. Finally, let's discuss the career paths and opportunities and salaries for data analysts and data scientists in both the United States and India. A career in data analyst often begins with marketing or finance. Over time, they can transition into senior analyst role to specialize further in business intelligence. There are also opportunities to move into management positions, overseeing data analysis team and driving strategic decisions based on data insights. In United States, the average salary for a data analyst is around $65,000 per year, with senior roles potentially earning up to $90,000 annually. In India, the average salary for a data analyst is approximately 6 lakh per year, with senior roles earning up to 10 lakh rupees annually. In contrast, a career as a data scientist typically requires advanced degrees and specialized training in data science. As they gain experience, they can progress to senior data scientist roles or lead data science teams, taking on more responsibility and tackling complex challenges. Data scientists also have opportunities to work in cutting-edge fields like AI, machine learning, and big data, where they can innovate and contribute to significant technological advancements. In United States, the average salary of a data scientist is approximately $1,20,000 per year, with senior positions often earning up to $1,50,000 annually. In India, the average salary of a data scientist is around 10 lakh rupees per year, with senior roles earning up to 20 lakh rupees annually. In summary, both data science and data analytics are crucial in today's data-driven world. Data scientists focus on the bigger picture and long-term strategy, while data analysts hone in on specific questions and provide actionable insights. Choosing between the two depends on your interests, career goals, and desired salary.
Welcome to Simplilearn. In this video, we are focusing on ChatGPT and its groundbreaking role in data analytics. In a world where data is the new gold, understanding and analyzing this wealth of information is crucial. But as the volume of data grows exponentially, traditional analysis methods are being pushed to their limits. Enter ChatGPT, a revolutionary AI developed by OpenAI that's transforming how we approach data analytics. But what makes ChatGPT stand out in the crowded field of data analytics tools? How can it not only streamline complex processes, but also uncover insights that were previously hidden in plain sight? Stay tuned as we unravel the capabilities of ChatGPT, share real-world applications, and show you how it's being used by analysts and businesses alike to make smarter, data-driven decisions. And whether you are a data scientist, a business professional, or just a tech enthusiast curious about the future of AI in data analytics, this video is for you. So let's dive in and discover how ChatGPT is not just revolutionizing data analytics, but also how we understand and interact with the vast universe of data. And don't forget to hit that like button, subscribe, and ring the bell to stay updated on all our future explorations into the fascinating world of technology. Now let's get started and unlock the potential of ChatGPT for data analytics together. And guys, if you're one of the aspiring data analysts looking for online training and graduating from the best universities, or a professional who elicits to switch careers with data analytics by learning from the experts, then try giving a shot to Simplilearn's Purdue postgraduate program in data analytics in collaboration with IBM. The link is in the description box that will navigate you to the course page where you can find a complete overview of the program being offered. So let's get started, guys. So guys, an Excel data analyst always looks for ways to improve their efficiency and gain deeper insights from the data. That's where ChatGPT comes in handy. So ChatGPT is an AI-powered language model that can assist you in various tasks, including Excel-based data analysis. And for that data analysis, let's dive into some demos to see how it works. So guys, as you can see, this is the ChatGPT 4, and you could see this has the support of DALE, browsing and analysis, and usage limits may apply. Like we have the version that has some usage limits. And for the data, I have downloaded the data from the Kaggle. I will provide you the link in the description. If you want to download the same data, you can. And I have that in my downloads. So this is the data that we'll be using. So the first thing we'll be doing is data cleaning and preparation. So firstly, let's explore data cleaning and preparation. Before diving into analysis, it's essential to ensure our data is clean and ready for processing. So for that, we will write a prompt in ChatGPT and ask him to clean the data. ChatGPT has the feature to insert the files, provide the Excel file to the ChatGPT, and we'll ask him that can you help me identify and remove duplicates in this Excel spreadsheet. So let's ask him, can you help me identify and remove duplicates? Duplicates from this Excel spreadsheet, from the provided Excel spreadsheet. So you could see that ChatGPT has started generating the response, and he is telling us that he can definitely help us with that, and he is analyzing that. So you could see that ChatGPT has provided us the response. So let's first go to our spreadsheet. So this is the spreadsheet: order number, quantity ordered, price of each quantity, and order lines. So you could see that first ChatGPT has encountered an error, and that is with the character encoding mismatch. And then he has loaded the spreadsheet successfully with the second attempt, and you could see that he has provided like the smaller or the briefer version of the spreadsheet. That is, the dataset consists of sales data with columns such as order number, quantity order, price each, order line, sales, order date, status. So he's asking us, could you specify how you would like to identify duplicates? For example, should we consider a row a duplicate if all its values match another row exactly, or are there specifically columns we should focus on to determine duplicates? So we should, or here we'll be focusing on the column section. So here we want to identify column section. So is asking which columns they should identify duplicates. So we want the duplicates in order number. So the ChatGPT has started analyzing the spreadsheet. So you could see that ChatGPT has produced the response that they have identified a total of 2,807 rows in the spreadsheet that have duplicates based on the order number column. So this indicates that multiple rows share the same order number, suggesting there might be different items or transactions within the same order. Would you like to proceed by removing these duplicates while keeping either the first or last occurrence of each order number, or do you have another approach in mind for handling these duplicates? So before identifying the duplicates, what we'll do is we'll first get rid of the extra spaces. So we'll ask ChatGPT that first find the extra spaces in the spreadsheet and help us remove them. So you could see that it has started analyzing it. So he is asking us that would you like to proceed with any further cleaning or data manipulation? Yes, we want to proceed further with data cleaning only. And now we will treat all the blank cells if there are any. Now treat all the blank cells if there are any. So the spreadsheet contains blank cells in the following columns with the respective counts of blank entries. That is, address line 2 has 2521 blank cells, then the state. So depending on your preference or the requirements of your data analysis, we can treat these blank cells in several ways, such as filling them with a placeholder value that is not provided using a specific value that makes sense for data. That is, example, a default state or territory, but potentially leaving them as if blanks carry meaningful information in the context of your data. So what we will do, we will provide a placeholder, instead, that is not provided or not applicable. Okay. So you would see that ChatGPT has responded that it has replaced the blank cells in the columns, that is address line 2, state, postal code and territory, with the placeholder not provided. So you could see there's a verification sample showing the updates. So this is how you could clean the data. And now with ChatGPT, you can quickly identify and eliminate duplicates in your Excel spreadsheet using built-in functions and formulas, saving your time and effort. So that would be done by the ChatGPT, and you can download the Excel file from the ChatGPT only. After that, you can just ask him that provide me the output or the resulted spreadsheet. So if we talk about now data analysis and visualization, let's delve into that. So Excel offers powerful tools for analyzing and visualizing data, and ChatGPT can help you make the most of them. So for this also we'll write a prompt to the ChatGPT, and we'll write, for example, please create a pivot table and a corresponding chart to analyze sales performance by region. So let's see, like this prompt, what output does ChatGPT show to us. So let's ask him, please create a pivot table and a corresponding chart to analyze sales performance by region. So you could see that ChatGPT has started analyzing the data and the spreadsheet, and you could see that the pivot table below shows the sales performance by region or the territory. So this table indicates that the EMEA region has the highest sales performance, followed by regions where the territory was not provided, then APAC, and finally Japan. So now let's create a chart to visually represent this sales performance by region. You could see that it has provided a chart, that is a bar chart illustrating the sales performance by territory. So you could see the guys that it has provided us the analysis, and ChatGPT can guide you through the process of creating pivot tables, charts and other visualizations in Excel, enabling you to gain valuable insights from your data with ease. So let's move to advanced analysis and automation. So lastly, we will explore advanced analysis and automation. So Excel capabilities extend beyond basic functions, and ChatGPT can help you leverage its full potential. And for this also, we'll write a prompt to the ChatGPT that can you assist me in building a forecasting model to predict future sales based on historical data present in the spreadsheet. So let's see what ChatGPT respond to us. So let's ask him, can you assist me in building a forecasting model to predict future sales based on historical data. So let's see what ChatGPT respond to us. So you could see that building a forecasting model to predict future sales based on historical data involves several steps. So for this, you have to prepare the data, select a model, train the model, evaluate the model and make predictions. So let's start by preparing the data. We'll aggregate sales by order date to create a time series of total daily sales. Then we'll choose a model based on data's characteristics. So we will grant the permission to ChatGPT to proceed with the steps. So he has started analyzing the data. So you could see that the data has been prepared into a time series of total daily sales. And before choosing a forecasting model, it's helpful to visualize the sales time series to understand its characteristics such as trend and seasonality. So ChatGPT has plotted a daily sales data, and then he has given the visual trends and the possible seasonal patterns. And the next steps would include testing for stationarity, model selection and parameter tuning, model training, and then forecasting. So you could follow all these steps with the help of ChatGPT and could create a forecasting model. If you want, we can move to the next step. So you could provide a prompt to the ChatGPT that move to or proceed with next step. So step by step, ChatGPT will provide you a forecasting model, or it will help you create a forecasting model. As you can see, it has started analyzing it. So the augmented Dickey-Fuller, that is ADF test, gives up a p-value of approximately 0.0033. Since this p-value is less than the common significance level of 0.05, we can reject the null hypothesis that the time series has a unit root, meaning the time series is stationary. So you could see that he is asking us, shall we proceed with the SARIMA model parameter selection? Yes, here is the model parameter selection. So you could select any based on the trends and the bar graphs plotted by the ChatGPT. So you could see, guys, that the ChatGPT has analyzed the spreadsheet and provided the response that the grid search for the optimal SARIMA parameters based on the lower ACALI information criterion, such as the best fit model uses the parameter 011 and for ARIMA and 01112, that is for the seasonal component. So you could see that it has provided the model and the parameters. Now it's asking us, shall we move on to forecasting future sales with this model? Yes, proceed with that. So you could see that with ChatGPT's assistance, you can build complex forecasting models in Excel, allowing you to make informed decisions and plan for the future effectively. So ChatGPT is a valuable tool for Excel users and data analysis, offering assistance in data cleaning, analysis, visualization, and automation. And by integrating ChatGPT in your Excel workflows, you can enhance your productivity and uncover new insights from your data. So you can try ChatGPT for Excel data analytics today and take your Excel skills to the new level. And you could see that there's an error in the analyzing, and he has encountered an error while trying to plot the forecast with its confidence intervals. So this type of error can occur due to data type issues, particularly when handling data indices and forecast. And despite this hiccup, the forecasting process using the SARIMA model was completed and we were able to generate forecast for the next 12 months. Unfortunately, due to the plotting issue, we couldn't visually display it. So we'll ask him, can you try once again? So you could see that this time ChatGPT has provided us the forecast for the next 12 months. That is, the forecast have been successfully plotted along with the historical daily data. So here we have our forecast model, and with the ChatGPT's assistance, we can move with other analysis also.
Hello and welcome to Data Analytics Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our Discover It. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to you're going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then averages the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within 1 standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like two different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. The next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket, and it doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, director, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible and Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table, where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array, and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list, so you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.data frame on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and then you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things a group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example: there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example: there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP order by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the dataset. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset. In here, you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. and you just have number 2 comma 1 and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are two arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created two different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see in the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in cells rep and item onto row labels. It will give the sum of the cells made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select Percentage of Grand Total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total sale. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, two separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as cells. And then we have our pp.product ID from production product as pp inner join, sales.sales order detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare our variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstore dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np, random arrangement equals np.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values in a column, and we want to look for the unique, that returns an array, where in unique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new DF. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new DF equals the data frame, or DF, the data frame where age is less than 35, and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplotlib. Plot a sine graph using NumPy and Matplotlib in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplotlib PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplotlib inline, that little percentage sign Matplotlib inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
Now with that, we have come to the end of our full course. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. If you want to watch more videos like this, do not forget to hit the notification bell and subscribe to our YouTube channel. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.